to this Python for Data Science series. If you have ever been curious about how companies analyze social media trends, how doctors use AI to predict disease, or how meteorologists forecast hurricanes, you are about to learn it all in this video. We will cover what data science is, how machine learning fits into data science, why Python is widely used for data science, and how to set up your system to start coding. So let's get started. In this video, you will learn what is data science, how does machine learning fits into data science, and why Python for data science. Okay. And next we will make setup of Python and Jupyter notebook, and we will write our first Python program. So let's start with the big question, that what is data science? So data science is the field of analyzing data to uncover insights and solve real world problems. We have to understand the data, and to find useful information from that data, this data science field is required. We'll clean the data, we'll analyze the data, and then we can make better decisions from that data. And this is what done with the help of data science. Think of it like solving a puzzle using numbers, charts, and computer programs. So those all things are only that it comes in the data science. Now, why is it important? It helps businesses, governments, and research makers to make informed decision. So these are some of the examples that where this data science fields are being used also. So examples are like in wildlife conservation. Data scientists use satellite images to track an endangered species and predict poaching activities. Okay. Next, in sports analytics, teams analyze players' movements and biometrics to optimize training and prevent injuries. So that is also a use that where data science is being used. In agriculture, it is also being used. Okay. Farmers use weathers and soil data to predict the best time to plant a crop for maximum yield. So many of the fields are there where data science is being used. Now imagine a scientist tracking tiger populations using satellite images, or a football team predicting injuries using AI. So that's data science in action. Let's move on to the next question, that how machine learning fits into data science. Many people confuse data science and machine learning. So let's break it down with a unique example. So machine learning versus data science. So what data science is? It involves collecting, cleaning, analyzing, and visualizing the data, whereas machine learning, it is a subset which allows systems to learn from data and make predictions without being explicitly programmed. And to that only, what is artificial intelligence? Let's understand that also. It is a broader concept where machines perform human-like tasks. So artificial intelligence and machine learning are also different, as well as data science is also different. These three concepts are different from one another. So example, we'll understand it with the example. Like imagine you wear a smartwatch that tracks your diet, activity, and sleep. A machine learning model can analyze this data and recommend a personalized meal plan to improve your health. So this is how machine learning turns raw data into actionable insights. Now, why to learn Python for data science? Now you might be wondering, why do we use Python for data science? There are so many programming languages out there, like R is there, Java, and even SQL. But why Python? Python has become the undisputed king of data science. So let me tell you why. Python is easy to learn. Okay, easy to read. It is high level language. So first, Python is one of the easiest programming languages to learn. It reads almost like plain English. Just look at this simple code snippet. Like you will understand this program, okay? temperature, we have assigned the value to the temperature, that is 30. Okay, so we have took a variable, we have assigned the value to it, that is 30. So we know that temperature is equals to 30. Then we have give the condition. Conditions are also simple. Okay, if temperature is greater than 30, then what it should print like it is hot outside, stay hydrated. It is showing us the message. This message will be printed. So if the actual temperature is 30 or greater than 30, then it will print as it's hot outside, stay hydrated. Elif or means like the temperature is less than 15, then what it will print, it's cold outside, wear warm clothes. So that is the condition it is showing us. Like if our temperature, not ours, like but if temperature is less than 15, then it will print like this message. Or what it is going to print means like if the temperature is not satisfying between this greater than 30 condition or less than 15 condition also, means like temperature is in between 30 to 15, then what it is going to print, it will print the weather is nice and comfortable. So this is the temperature that we can handle, like between 30 and 15. So that is why the weather is nice and comfortable. So this code snippet is too simple to understand and it is written in the Python. So that is why we can understand Python language very easily. It's just like we are just reading some of the English sentences. Even if you have never coded before, you can guess what this code checks, right? So that is why only Python makes our life easy, especially for beginners. That is why most of the time it is also said that if you are beginner in the coding, then you can start with the Python. Then your Python is your go-to option. Now next we will understand about Python libraries. The real reason Python dominates data science is its incredible libraries. Libraries are pre-written code that saves our time. Instead of writing complex algorithms from scratch, we can use Python libraries like these. These are some of the Python libraries like Pandas, Scikit-learn, Matplotlib, NumPy, Seaborn. So these are pre-written code. If we just install them and then work with it, then also it will save most of our time. So NumPy, it is used for numerical calculations, like handling big numbers calculations. So in that cases we are going with the NumPy. Pandas is for working with the real world data sets like Excel, but it is way more powerful than that. Okay. Matplotlib and Seaborn are for data visualizations, means like if you want to do basic plottings, then we can go with the Matplotlib. And Seaborn, if you want some of more advanced things than Matplotlib, then we can go with the Seaborn option. Scikit-learn is for machine learning to train the models and make predictions. So in that cases we are going with this Scikit-learn. So within just few lines of code, you can analyze thousands of rows of data, create graphs, and even train AI models. That's why Python is first choice for data science. Now it is used by many top companies worldwide. And if you're wondering whether Python is just for beginners, no. Major companies like Google, Facebook, Tesla, and Netflix rely on Python for their data science and AI projects. If they trust it, then we can too, right? Alright, now that we know why Python is best choice, let's get it on our system. For that, what we have to do? Before we start coding, we need to install Python in our system. And trust me, this is super easy. There are two ways to do it, depending on what works best for you. Option 1 is, we can install Python manually. To install Python manually, what you have to do is, you just have to go on python.org. On your browser, you will go on your python.org. So when you will come on your browser, you will type there Python and click enter. Here you can see that this interface will open in front of you, and here you can see that we have all the things present over here. Here this is downloads option, and when you will come in this, you can see the latest version for your system, whatever it is, you can see it. For right now 3.1, 3.2 is the latest version. you just have to click on this download, and then downloading process will get started. Once it will get downloaded, in your downloads folder there will be a folder or a file. So what you have to do is you just have to double click on that, and then your installation process will get started. You just have to follow the commands, and then installation will also get started. So that is the thing. But now as we are learning Python for data science, so what we can do is we have some different trick to install. And if you have installed it properly, then what you can do it, you can go on your command prompt, and there you can write as py space hyphen hyphen version or python space hyphen hyphen version. If it will show you the version here, you can see this version. If you can if that command is being executed properly, it is not showing any error, then congratulations, you have installed Python in your system. Okay, but wait, there's an even better way for data science. Instead of installing Python alone, we can install Anaconda, which comes with Python and all the important data science libraries pre-installed. So what you have to do for that? You just have to go on your browser and type there Anaconda download or anaconda.com. Also you can type there, then click on this first link. Yes, you can see the things present over here. Just click on free download, and then it will start getting downloaded. So whatever your system is or your system preferences are, you are going to download it with that. And installation process, you are just going to follow the instruction. Okay, that's easy. Once you have downloaded and installed it, in your search bar you can type Anaconda Navigator. You just have to click on this Anaconda Navigator. It will take some time. So when you will open Anaconda Navigator, you will see this interface. So what you have to do, there are different things present. There are different notebooks or IDEs are present over here. With that we can work, like PyCharm is there, Anaconda AI Navigator is there, Toolbox is there, and different things are present over here. The one which is of our use is like this Jupyter notebook. We are going to do all the Python programming in this Jupyter notebook. For that, what you have to do is, once you have installed Anaconda Navigator, open it and then come in this Jupyter notebook and then click on this launch. So it will take some time. Here also read these instructions properly, okay, once you will. Here we are on our Jupyter notebook IDE, okay. So you can see these things present over here. These are the folders which are in your system. Means like in my system these are there, in your system it may be different. So if you want to create a file or open a file, you can create in these also, or else here you can see this new. If you click on this new, you can just directly create a Python conda, means environment based file, or you can open terminal or console, or new file is there. Directly you can create new file in the sense, now we can select this Python also, now as we are working with the Python only. But why new file? If you don't want to create Python file, or rather than different other file is there, then we can go with this new file. Or if you want to create a new folder, then you can go with this new folder also. I'm selecting this new folder, this is untitled. Give name whatever you want. I'll go with Python for data science, like this. I'm going to give name to this. You can give whatever you want. I can just click on that and then it will select it. Now here I am going to create a Python file. So this is a Jupyter notebook which we have installed, opened. Now here we don't have to install Python and then install libraries are pre-installed in it, okay. So here also you can see that Python conda environment base. So most of the things which are related to Python or which are related to data science, these have been installed in it. So now as we have opened this, what we are going to do is, let's write something in this. Now we will write our first Python code and explore some basics that will help us in data science. So let's jump right in. When we will work further or in the upcoming videos, I'll come with the tricks and techniques also which you can use in this Jupyter notebook. Okay, if you want to give the name to this Jupyter notebook, you can just double click it or single click it, and then whatever the name you want to give, you can give. So I will give it as first file, and then IPYNB. This is the extension of Jupyter notebook. Okay, and then you can click on this rename. So you can see here the first file, it is the name which we have given to this notebook. So there are many things present over here. Here is file, like if you want to take new file, new console, save this notebook, rename this notebook, download it, and then if you want to close, log out, shut down, and those things are present over here. In this edit, you can redo the things, undo the things, or those things are present. If you want to cut, this is known as cell. Okay, this thing is known as cell. So if you want to cut the cell, copy the cell, paste the cell below, paste cell above, shortcuts are also present over here. Okay, paste cell and replace it, delete and select, deselect, then those are things if you want to do, those are present in this edit also. Anything that is related to cell, we can edit it in this edit section. Okay, if you want to find, and rest of the things are present over here. In this view, file, browser, open Jupyter Lab, and these all things are present. How we are going to use most of the things which are being used, those things also we will understand one by one when we will start coding in this. Run is there. If you want to execute any of the cell, like now I am typing here, let's just write something in the Python. Now this is a simple and universal thing, like if we are starting with any of the programming languages, we are writing hello world. So I am not going to go with it. I'm going to write as hello to my viewers. Sorry. Now who all are seeing this video, I don't know, but still, yeah. So I have written this, and then if I want to execute that, and then I can simply click on this run, or this is also present over here. Kernel is there. Now how we are going to run this, I'll show you, or I will tell you a trick for that, but wait for that. Okay, if you want to change the theme of their notebook, means like if you want to keep dark, high contrast theme, scroll bar, means if you want to change your workspace. Okay, this will consider as a workspace of a Jupyter notebook. And then if you want to change the settings in it, like if you want theme to change, color to change, and then the rest of the things are present over here. If you want any help, then you can see in this. I prefer, if you are new to it, if you have opened the Jupyter notebook for the first time, then you should go with this help section also. Okay, now here also there are some of the things present, like if you want to add a cell below, if you want to add a cell above, this is known as cell, right? Yeah. So if you want to do those things, if you want to go down, if you want to edit something in the upper cell, then you can go with this. If you want to delete any cell, then you can delete it from here. So those are things are also present over here. Now we want to execute this. Now I have made a code of hello viewers. I have said hello to my viewers, but I have not executed it, right? So what I have to do, I can simply go with this command enter option also, and it will run. It will show me the output if it is correct, or if there is any error, then it will show me error. Okay, but still, if it will run, means it will execute, it will show me the output, and then it will create a new cell also. Okay, so there are the shortcuts also. So if what you have to do is, if on Windows you are working, then you will just go with this command enter option. If now I am using Mac, so with here I have pressed shift and return. Whenever you are using shortcuts, it will seem like you are professional in it, you are pro in it, right? So we should know, but one by one we will explore the shortcuts. For right now, this much only. Okay, so I prefer you all to install Anaconda, make a setup of this Jupyter notebook, and understand that how this Jupyter notebook works if you are new to this. You made it to the end of this lesson. Great job. You're officially one step closer to becoming a data science pro. So let's understand what we have learned in this. So let's take a recap like what we have learned in this video. So we learned that what is data science and how it is used in real life. We explored how machine learning fits into data science. We discovered why Python is the ultimate tool for data science, and most importantly, we set up Python on our system and we are ready to start coding. Now it's your turn. Drop a comment below and tell me, why do you want to learn data science? What's one cool example of data science that excites you? So in the next video, we'll start with the Python basics and we'll learn like what are the things present over there. So make sure you subscribe and turn on notifications so you never miss a lesson. Smash on that like button if you found this helpful. It really helps me to create more awesome content for you. Share this with a friend who wants to learn data science too. So alright, I'll see you in the next video. Till then, let's keep this data science journey rolling. Hey everyone, welcome to our channel. In this video, we are going to learn about Python basics. So if you are new here, I am Devashri and I make learning Python fun and easy. In the last video, we covered Python installation through Anaconda and Jupyter Notebook. We learned like what is data science, what is machine learning, artificial intelligence, and rest of the things. If you want to know what we have learned in the previous videos, you have to watch the previous video. So today we are diving into fundamental programming concepts, Python basics, variables, data types, operators, strings, comments, and indentation. These are key for writing clean and efficient Python code. So grab a cup of coffee or chai, whatever you prefer, and let's get started. So Python is an easy to learn high-level programming language known for its readability and simplicity. It is widely used in data science, machine learning, and automation. So let's write a first program. Actually, we have written a first program in the previous video only. Like I have wished you all hello viewers, but you all have not said hello to me in the comment section. So let it be. Okay. So this simple code has printed hello viewers in one line only. So if you'll compare this with the rest of the programming languages, you'll need to write a line of 2 to 3 lines of code for just to print just these 2 words. So let's just start with variables and data types. So variables store data in Python. The best part, you don't need to declare their type explicitly. Like there are 2 concepts of first I want to discuss that is dynamically and statically typed. So what is a dynamically typed and statically typed language? I'll explain that this concept. Okay, so for Python, a variable is what you have to write it first. Okay, so let's take an example. So this name is known as variable and this Devashri is known as a value of that variable. Okay, so I have writing this. So this is written in Python, but if you are going with different other programming languages, then what you have to do is now Devashri is in text or string. Okay, so you have to mention it first, like what it is, what are the value you are going to give. Like I am taking this variable, this is known as name. Okay, so this is a variable, so I have to tell first like what I am going to. Okay, I'm taking any random value. Okay, and don't take this seriously, this is not name of anyone. Okay, so I have to mention in any of the programming languages, if I am going with, then I have to mention like what the value in this variable I am going to give. So like this is the text value or this is a string, like whatever. In different languages this it is said different, so whatever is said in the Python I will take that only. String. So this is the string type, then that is the variable is name, then in that it is the text value or string value, like that it has to mention. Like if I am taking any number, So I have to mention it first, like a is equals to 34. Okay, so this is the syntax of any other programming language, and I'm not going to name of any programming language, but it is considered. But whereas in Python, if you want to write, then what you have to do is you can just simply give a variable name and then assign a value to it. So this is the difference between Python and any of the other programming language. So here this thing is known as, or in whichever language we are declaring the things, we are first telling only that what it is, so that is known as statically typed. And this, where we don't have to mention anything first, is known as dynamically typed. So this is only the difference between the dynamically and statically typed. So what Python is, now you know that. Just let me know in the comment section if you still have any of the confusion. So here you can see that we have written this text value or the string value in the double quotes, whereas when I'm going with the number, then I'm not going with the double quotes. So this is also a thing. Now here I'm not going to teach Python in detail, okay? You have to understand the things because our main focus is going to be on libraries and using those libraries, what we have to do in the data science. So that is only the main focus. So here I'm just going to tell the basic of the things, but that I'll go with a speed over here. It's true. So this doesn't make any sense, okay, but don't take it seriously. But you can say see that we have different kinds of variables present over here. Like we have assigned to name, this is the variable, and we have assigned the Vishri this value to it. For age we have assigned 110, for height it is 5.8, and it is true. So this is the string value, this is the number, this is the floating point number or float, you can say that, and this is the boolean. So these are the basic things which are there. So when I came into this next cell, and here I just wrote name, so it has identified that what name is, so it has executed that and it has shown me the answer, like what is the value present in that name or what is the value present in that name variable. So these are the variables that are present. Like some common data types in Python are, data types means like this is the data type, sorry, this is not the data type, this is the value of that data type. Like 110, it is written into the number. So number or integer, we will say integer is there in the Python, it is not number, integer. So integer data types are like, we have data, okay, there is a trick. Here you can see when you click on this drop down, let it be these things, okay. So here you can see on this drop down, here is the markdown option. What you will do is you will just select this, and here you can write the things whichever you want, like whichever you want into the comments. So these are some of the data types which are present in Python. Now next we are going to learn about type checking. We will write that in the comment, okay. So how comment is written in the Python? By giving this hash symbol. Type checking. Type checking means like this is name, this is age, the height, this is, what is the type of it? Now we have understood the data types, okay, that integer is there, float is there, we can identify that 5.8 is a decimal number or it is a float number. So we can identify it. But what if anyone is new, or if I would have not told you the concept of data types and then directly I would have told you the type checking concept, then it would have been easy, but let it be, okay, you'll try. So what you have to do is, let's just write it print type. Now from these things of what you want to check the type. Now let's say I want to check the type of A. So type checking is what? Like if you want to check any of the type, like what it is. Now this name, this is no, this we know that it is string. This is no, this height we know it is float. So, but in case if we can't identify the thing, then in that cases we can just print this type, and then whatever the name of that variable is, that we can assign over here. So this is how we are going to check the type of it. So let's quickly check the type of everything. We are just going to copy this, and we are just going to, so you can see first age is of integer type. In age there is integer type of value. In name there is string type of value. In height there is float, and in is there is boolean type of value. So this is also how check the type of it. Now knowing data types helps us to work with them correctly. So this is the advantage of it. Now next we are going to learn about operators. So let's just quickly take the markdown. Let's just make this a markdown. You can see that whenever we are writing it as markdown, it is not considering it. So in arithmetic what happens? I'll show you example only. Let's take the value for a. We have not took a, right, before this. Yes. So let's take the value of a as 45 and b as 23. Okay. So if you want to see the sum of this, if you want to see the difference between these two numbers, then you can print it. So those all things come into the arithmetic operators. Likewise, that if you want to compare these operators, like 45 is greater than 23 or 45 is less than 23, those things if you want to see, then those things come into the comparison operator, or logical operator, and or those things come into that. So let's see this arithmetic operators. So what I'm going to do is print a plus b, and then, so you can see we have added two numbers, right? So this is the addition, and which comes into arithmetic operators. Okay. So this is what arithmetic operators are. There are different kinds of operators also there, like floor division is also there, modulus is also there, exponential is also there. So if you want to see that also, then we can do that also. If we write here, so what we'll do is we will just print one of that. A exponential we will print. So that also value we can see over here. This is the arithmetic operators. Let's see the example of we are going to give the values of a and b as that only. Okay, we'll just come here, give the comment over here, and then so now these things come into the comparison operator. Here's here first I'm saying that a is greater than b. So yes, it is true, so it will print true. If a is less than or equal to b, then it will show us the value, like if it is correct, then it will print true. If it is false, then it will print false. A is equal to b. If it is really, like 45 is not equal to 23, right? So that is why it is not going to print true. And a is not equal to b. Yes, this is also right. So see the answers: true, false, false, and true. So like that we have seen comparison operator. Now let's see one example of logical operator. A and b means it will add. Okay. So let's take another example also. A, this is also the thing we can see over here. You can see the values a or b. So like that it is also printing. So operators are crucial for data manipulation and decision making. Now next we are going to see about strings. Like what are strings? Here when we were learning about variables, as I said, that name is equals to the history. So this name, this value in this name is known as string. Means anything we have written in the text is known as string. Okay, so we'll learn that. Let's first take a markdown. Markdown is a place where we are going to write any of the rough things which we want to note. Like if I want to highlight some of the things. Here this operators, arithmetic operator, comparison. These things are optional, right? We are not giving them comment also. So that is the thing that we can write in the markdown. And this is also, the markdown name itself is telling us like something we are marking in a book. So that is why this markdown is there. It is really important when we are working with any of the thing, to keep our things marked. So let's learn about strings. Strings and string function. I have pressed shift enter. Okay, so I'm taking the new cell. So strings are sequences of characters enclosed in double quotes. Python provides many built-in functions to work with these strings. So this, as it is known as string, and it is enclosed in double quotes. You can see this. This is also a string, right? It is also enclosed in double quotes. And Python provides built-in functions to work with these strings. So what are these functions? We are going to see. First, let's see how string is being created. String creation. So we have to take any of the variable name, like whatever you want to take, you can take it. I am taking it as text, and as it is rule is that it should be in double quotes. So let's take double quotes and write any of the strings in it. Now you can write your name or any other thing you want. So I'm writing this thing. So I have created this string, and let's see what are the different functions we have with this string. Now to print this string, what you can do is you can take the print statement, and in that what you can do is you can take this print and you can write here text. This printing statement is there for us. Or else what you can do is you can take next cell and just write there the name of that variable. So it will execute in that way also. You can see we have got the output over here. So now let's see functions on these strings. Like some common functions we are going to see, like if we want the string in uppercase, if we want the string in lowercase, or if we want to capitalize the first word, or if we want to replace anything from the string. So those things we can do with the help of string functions. So let's see what are those. First we will see about capitalize. Now this is the string. Okay, so what we are going to do is print text dot upper. So now what is the output you are going to get? See, you can see this. We have got the whole string printed into uppercase. So this is the function we can use if we want, or else next we can see that here you can see. Now I'm writing in the same cell only. So because these all are the string functions, that is why. Now if you want to remove the spaces at the starting and at the ending, then what we can do? We have the strip named function. So let's see how to use it. It has written the same string, okay, but it has removed the spaces, but that we cannot see right now. But in case if we want to use it, we can use it. Let's replace something. Now this, for this replace, what we want to replace, that thing also we have to mention, right? Let's replace this hello with capitalized word of hello. Okay, So you can see we have replaced this hello word with this hello. Means like capitalized we have made it. We can also do with this upper function, but we have did it. Or else if you want to replace it with any other thing, then you can replace it. But these all are functions that are present. These are some of them, okay, not fully, not full functions I have shown. Here also I'm making a mistake. It is case sensitive, okay. So make sure what you are writing. Like if you are writing print statement, and in that p if you are mentioning as capital, then it will take it as error. So we have to type it very. So now let's see split function. So it has splitted it, because you can see that here it has all been printed in one line, and this is being splitted. So these are the some of the common functions on string which we have seen. Let's now see something that is indexing and slicing. If you don't know the concept indexing and slicing, we'll understand it. Like what is indexing and what is slicing. Word equal to Python, okay. And now I'll show you what is slicing. Here you can see that this Python. So what is indexing? These all alphabets are being assigned an index. So what index is there? Like if you want to see, this P is being assigned index as 0, then 1, then 2, then 3, then 4. So like this indexing are being done. We cannot see those indexing, but if we want to, now if anyone asked us to just print y from this Python, so what you are going to do? So in that cases this indexing really helps us. So what we are going to do to print that? Now let's see. Print word, sorry, you have to mention the indexing into, we wanted to print y, right? So this is 0, this is 1, so let's write here 1 and then close it. So see, we have printed y from this text. So this is known as indexing. Let's do something else. Now here I have made this -1. So if you are saying that 0, 1, 2, 3, 4 and 5, these are the indexes assigned, then where this -1 and why this -1 is being assigned the value of n, and where you can see this n, it is in the last. So negative indexing is also present. Negative indexes are like, let me show you, wait, -1, then -2, it doesn't starts from 0, okay. So like this the negative indexing is there, okay. For this n this -1 is there, for this o -2 is there, h for -3 is there. So like that, if we want to extract y from negative indexing, if anyone tells us, now at what place this this y is there, means like which negative index is being assigned to this y. Let's see, -1, -2, -3, -4 and -5 is there. So let's give this -5, and sorry, here also, yeah, now it is complete. Oops. Here you can see that we have printed this y. So this is the thing, we have negative indexing also and positive indexing also. So strings are powerful in Python, and mastering them will help us handle text-based data efficiently. Okay. Now next we are going to see about comments and indentation. Now here, yeah. So here you can see that I wrote this negative -1, -2, -3 for our understanding purpose, right? It was not needed, or it is not the requirement of our code. So but still if I run this code, or if I execute this code, I'm just pressing shift enter, okay, to execute the code and take the new cell. Yeah, so if I'm executing this code, I'm getting error. And what it is error is showing that indentation error. So indentation also we are going to see indentation, and what these things are there, the Python code is not able to understand this thing. So what we can do now, we don't want to execute this line, this code we don't want to execute. So what we are going to do is we are going to make it as comment. Now let's run this again. So see, it has executed the code, but it has not took this line. So this is the thing that we have in Python, that is known as comments. Comments are to be ignored. Now as Python is known for its readability, simplicity, this is because indentation and comments. With the help of comments, we can explain our code. Now here I am explaining the code. This line is to explain the code, okay? But now I don't want to execute it, but I want to keep that in my code. So that is the thing, only comments are there. If we don't want to execute any line of code, now here I could have here I have written the string creation. This is also I have written in the comment. And what is the symbol for the comment? This hash. Now this hash is for single line comment. In Python we have multi-line comment also. So what we can do now, here we have seen this multiple string functions in one only cell. So what we can do is, now here I don't want to execute all the functions one only. I want to execute one function at once. So what I'm going to do is I'm going to, so now if I execute this cell, so what I'm getting, only the split functions execution is being done. Rest of the things are in the comment. So this is known as multi-line comment. If you want to give if you want to write any multi-line comment in our code snippet, then what we can do, we can enclose it into 3 colons, and we have to end it with that only, okay? So if you want to write multi comments in Python, you have this option, or if you want to write a single line comment, then we have this option. Now next, let's learn about indentation. Like, what is indentation? Now, unlike other languages, what Python does is it uses indentation to define blocks of code. Now, if we will forget indentation, then what will happen? It will lead us to error. So let's see one of the example of that. Oops, caps lock was on. So define, this is a function. We are going to see it in the next video. Now what is this def? Now what is this greet? I am writing here. I'll explain it in detail in the next video, but for now let's just see this. Okay, so this is just a function we are going to see. Okay, now here when I pressed enter, you can see that this line has directly added some space by itself only. That space is known as indentation. If it didn't give that space, what we will get, we will see that also. Now let's just write something. Okay, so this is the code snippet. I have created a small function called greet, and in that I have this is the def, this is the keyword that is used for function def. Then this is the name of that function, that is greet, and in that I have assigned an argument to it. Then if whatever name we are going to give, it will print for that this thing. So let's execute this once and see. Whatever name I have passed to this function, it has printed as hello, and this name it has done. Now what is this indentation? Here if I took this print under this def, so what it is going to show me. Now let's execute this. So see, indentation error, expected an indented block after function definition on line 1. So it is also telling me that indentation error is there, and where is this indentation error? At this print. So, and press the tab, yeah. and now if you execute, our code will get executed. So this is the importance of indentation in programming. We have to identify, or we have to keep it in mind, like what are the things and where they should be placed and how we should write this code. Now this is to make a code efficient, so that is why indentation is also needed. Here also, if I took this greet over here and then execute this code, it is not getting executed because it is not proper, because we have not assigned any name. It is considering that we have not assigned any name to this function, so that is why it is not printing any output. Now here if we'll do that, then it will take it as nil. Then we have passed this value for name. So that is why indentation is important in Python, or in any of the language. We should make sure that we are writing a code efficiently. So forgetting indentation leads to error. We have seen that how. Bad indentation will cause an error only. So that's it for today. We have covered Python basics, variables, data types, operators, strings, string functions, comments, and indentation. Now let me give you a small assignment. You can do it and tell me the answers in the comments, okay? So this is the assignment for you. What you have to do is you have to take two numbers and then print their sum. And if you will do that, just drop your answers in the comments. So that's it for today. We have covered Python basics, variables, data types, operators, strings, comments, and indentation. If you like this video, then smash that like button, subscribe to our channel, and stay tuned for the next video on Python data structures. And happy coding! Hey everyone, welcome back to a Python for Data Science series. If you are new here, I am Devashri and I make learning Python fun and easy. In the last video, we covered variables, data types, and operators. Today, we are diving into fundamental programming concepts of data structures, conditions, functions, and etc. These are key for data analysis, and let's get started. Here I have created the new file, new notebook and named it as second file. So whatever names you want to give, you can give it. So data structures help us to organize and manipulate our data efficiently. Python provides list, tuples, sets, and dictionaries. So let's explore them in depth. First we are going to see list. A list is like a dynamic array where you can store multiple values. Lists are great for handling ordered data. So what is the concept of list and how we are going to write a list? Let me show you first writing one of the list. So let's take the example. List. Now what we can understand from this? Like list is written in square brackets. Now we know the concept of array. In array, it is like a container of some of the things. Okay, like if you can store numerical values, if we can store. So I'll tell you some of the things about list. From observing this list, we can say that list are in enclosed in square brackets, or list are made in the square brackets. So whatever things are present in the list, that are in the square brackets. So list are mutable. Mutable means we can change the things within the list. It is ordered, like you can see, like we have given this as ordered. So list are ordered, and heterogeneous means like any kind of data we can add into that. Now this is the text of text data, right? So here if we add the number, or if we add a decimal point number, So that is also, so this is also considered as least. Like if we can write apple and we want this much amount of apples, this much amount of cherry, so like that also it can take. So least, like, we can consider it as a grocery least we are making, right? We can that kind only you can take it as least. But here you have to keep in mind that least are enclosed in square brackets, or least are made into square brackets. And now as we are focusing on data science, right, so least and dictionary are mostly used data structures. Okay, so we have to focus and we have to give more attention to least as well as dictionary. So let's understand about least more. So this is the least I have created. Now in the previous video we have learned the concept of indexing also, right? Here also the indexing concept is there. Like for the apple, this is 0, means index is assigned as 0. For cherry, that is 1. Now what I will do is I will write it into comment only. So these are the indexes which are assigned, and as there is also negative indexes are also there. Okay, so this will be considered as -1, -2, -3, -4, -5 and -6. So now if you want to print any of the fruit from the list, like if you want to see like which fruit is present on the third index, or which fruit is present on the fourth index, or else if there is anything present rather than fruit, so those things also we can do. Or if you want to delete, now if anyone asks you to delete the names of the quantity in the present in this list, so what you can do, or if you want to show that those things, so that things are also present over here. So what we are going to do is I'll take as, now we in the print statement first we have to write the list name. So what is the list name? Here if I have written capital, so you have to make sure what you have written, and that only you have to write. Now which fruit we want to print, so let's take this apple. So I have assigned it the index of 0, and then if I execute this, apple will be printed. Now there is another concept, like if you want to see how many items or how many things are present in this list, like if you want to remove the count of these things, count is being removed for the numbers. For least, for the text values, it is length, right? So what we are going to do is we will let's see how many elements or how many things are present in our list. For that we have this length function. Okay, so what this length function is there, it will return the number to us, like how many numbers of items are present in this list. So we can see that we have 6. Now here as we have given indexing, and these are up till 5 only. Okay, but it has starting from 0, right? So that is why, but in all there are 6 items present in our list, so it has shown us the count of that. Okay, it has shown us the length of those things present in our list. So in our list 6 different kinds of fruits are present in our list, so we can say that. Like if your mother told you to buy these fruits, and you went to the shop, and now she called you and she told you that add one more fruit, that is oranges, buy oranges also. So what you are going to do means, like, so one of the fruit is being told you to add in this list, so how you are going to do? Many times this case can also occur. So let's add a new fruit in our list. So what you have to do is you have to take the name of the list. Okay, in that we have append. This append function is there for us. So, and now you have to mention the name of the fruit or the name of the thing or item which you want to add in your list. But we have not printed the list, right? Again, in the next cell, let's take as so you can see this orange is being added to our list. This is a new list with one element externally added, or one element added afterwards. After creating the list, one element we have added in it, or one fruit we have added in it. So indexing is also there, and when we are working with it, we in the data science field, we have to consider this as array. While working with the array, there are some of the limitations. Like in array, there is the thing that we cannot take different kind of data. Like in list, as we can say, take the data of decimal data also, we can take numerical data, we are taking strings also. But while working with the array, we have this one limitation, okay, that we cannot take different kind of data. Means we have to take homogeneous data only in it. Like if we are taking text values or string values, then we have to go with the strings only. If we are taking numerical values, then we have to go with the numerical values only. But while working with the list, we cannot, we have this ability that we can take different things also. So to reduce that limitation of array, we have this list. Now next, let's see what are the different operations we can do on the list. I'll create a new list named as num. In that I'll assign numbers to it, 10, 20, 30, 40, 50. Okay. So I have created this new list and I want to add 60, 70, these two numbers if I want to add. Now here you can see that you have used append also. But let's see what is there with the numbers. So you have to write the name of the list, and then we have this insert operation also. So in that, now you have to write what are the numbers that you want to add to it. 60 I want to add, so now what you have to do is, you know the concept of index, right? So at which index you want to add number. So I want to add 45 between 40 and 50. So what I have to do is, I have to mention the index of that place. So what index it will be, like 0, 1, 2, 3 and 4. So let's take this 4 and then separate it, and then what number I want to add, I have to mention that. So you can see that 45 is being inserted between 40 and 50. So for to insert any of the thing in between a list, what you have to do is, you can go with this option also, like operation is there, insert operation is there. Like that we have remove operation also, like if we want to remove any of the thing. But what happens into remove, num dot, let's see, num dot remove, yeah. Here we don't have to mention index, which place we want to add this number, right? But here we have that ability that we don't have to add any of the index. Now let's see how. Now I have executed this again, so you can see that this 20 is being removed from the list. So like this is also there, like insert operation is there, remove operation is there. Let's see least comprehension. Like and it is too much used in data science field, okay? Like we need to least comprehension in many of ways. It will say most of the time. Now in most cases what happens, it is used for squares. Like if you want to print the table of 2, so what you are going to do is, you are not going to write print always and then multiply it. So like that it will take too much time, but we can do it into simple way. Now as I know that we are working with the least comprehension, okay, I'll mention it above. So I've mentioned it above. Now we are working with the least comprehension, okay? We know that we are working with the least comprehension, and we have to take a variable name to that, as we are going to print the table of any of the thing, with any of the number we are going to print the table. So what we are going to do is, we are going to take the name of the variable. Then we know that list are being created into square brackets, so we have took the square brackets. Now next thing is there, we are working with the numbers, and for numbers there is no need of double quotes, right? So we are not going to give right now any double quotes. Then next we know the thing that we are working with the numerical values. So what we have to do is, as we are printing the table of 2 or any of the number, okay, you can take any of the number in that. So for the number, and what is the logic to print a table? Means like x, and for multiplication there is multiplication, there is star. So here we are multiplying. Now consider this x as any number which has to be multiplied with multiplied 2 times of that own number only. Okay, so that is the logic of a table, right? You can see the output, it has taken from 0. Okay, so here we have to mention it like 11. Now if we'll execute, then it will come take all the values of 10. So we can create this in function also, and then while passing the argument we can pass any number whichever we want, right? Def squares, and then this logic in that, and then print square. While printing square you can write that as squares and any number whichever you want. So that is also there with the functions, but to print with the least comprehension, like in one single least only, we have given multiple conditions. Okay, means 3 to 4 3 logics have been compressed in one single least. So this is known as least comprehension. It has saved much of a space, right? And within one line only we have made this table. So this conditions or this thing is known as least comprehension. Okay, now after least comprehension we are going to learn about tuples. Like, what are tuples? Tuples are like least only, but they are immutable. Immutable means we cannot change them. Once created, we cannot change the tuples, meaning this value cannot be changed. They are useful for storing fixed data. Like if we create once a tuple, then after that we cannot add or remove or insert. Those things we cannot do with the tuple. So once now I have created this tuple, okay, and I have executed it. Here once I have initialized the value, that is 10.5, 45 and 5.6. These I have initialized it now. So if I want to remove this 45 from it, I cannot remove it. Or if I want to add any other element or number or any other thing to this tuple, then I cannot do that. That is why it is said as immutable, means we cannot change a tuple once created. Why we should use these tuples? Because they are faster than least, and they can be used as keys in dictionaries because they are immutable. Now what is dictionary and how we are going to use this, that we are going to see. Now let's learn about sets. Sets are an unordered collection of unique items, great for filtering out duplicates. Now why it is unordered? And unordered means when there can be duplicate values also. Let's create one set and then you can see the example. I'll take this as, oh sorry, we should not take name. It is not a good practice. Now here I have created a set. Okay, now if I'll print this set, you can see that the set was unordered, means like there was after 2 it was not 3, or after 3 it was again 4 or 2, so it was unordered. Mutable means we can change things whatever once it is created. Now if I want to change this, then I can change it. And unique values, but when we will print this, it will only give us unique values, means it is showing us that, means like this 2 is being repeated, this 3 is being repeated. It is not printed unique as it is. It has reduced the duplicate, or it has removed the duplicates, and then it has print. It is great for filtering out duplicates. That is why it is said as. Now what are the operations which we can perform on set? Now I have this unique one. Create 2 different sets first. So I have these 2 different sets, and what are the operations which I can perform on these sets? Means like if I want to join these 2 sets, so union means we are going to join these 2 sets. So you can see that we have joined 1 2 3 4 5 6 7. These 2 sets are being joined with the help of union. Now if I want to intersect, means common things which are in both the list, like there are no common things in both of the list. So what I'll do is I'll add here 4 and okay. So I just want to print that. So what I can do is print A was not defined. So you have to check the things yourself also. You have to understand that why that error is being occurred. I didn't executed this code snippet. I changed the value but I didn't executed it. That's why it was showing empty. But once I executed it, now it is not showing me the empty. The value of 4 is being shown to me. Intersection means the common one which is in both of the list, that is being shown over here. Let's check one more thing. So these are things that are with the sets we have seen. Now our main focus is going to be with the data science. So that is why I have made sure that I have explained least mostly, and then tuples and sets are not being used mostly. So that is why I just want to explain, like, there are tuples and there are set also. And now I'm going to explain dictionary. So dictionary is also important. So let's see what a dictionary is. In dictionary there are key value pairs. Means like let's see only example only I'll tell. Dictionaries are one of the most powerful data structures in Python. Okay, they allow key value storage. Now in what these dictionaries have been created, so these are also being created in the curly braces. So this is dictionary. Has I created it as markdown? This was the error because it was not showing us, right? So this is dictionary. I have created one sample dictionary. So dictionaries are most powerful, and which allows us to store the values in the key value storage is there. Then how to now print this dictionary? So it has shown us the values in the, like, this is the key and this is the value of that key. So if we want the values in these format, then we can use this dictionary. Now let's see some of the operations we can perform on dictionary. Now here, this age, this is 90 over here. If I want to update this age, like if I want to add any different value, or if I want to add that age, update that age, then what I can do? First you have to mention, like, in of what key you want to update the value of. So this is the our key, right? So I have mentioned this key over here, and then what value I want to add into it. So I want to make it as 91 now. So I have added this as 91, and then let's execute it. So you can see this age is being updated. We have added this age, or we have increased this age by one number. So if you want to update any of the thing, you can do this thing. You have to first mention the name of the key in which you want to add the things, and then the value to it. And don't forget to print that value again, because if you want to see the changes, you have to print the things again. Now if you want to add any new key and value to your dictionary only, then what you can do? Now here this course is there, this age is there, this name is there. Okay, so if I want to add name to, so what you have to do in that case? Now what value you want to give, that you have to mention over here. Now that we have created this new key and the value for that, we are going to add it. So you can see in the end here, this name to this key is being added, and the value to that key is also being added in our dictionary. Now if you want to delete any of the key, now this we have created this new key, and we want to delete it now. So how you are going to delete that key? For that we just have this del operation. You can use that. Here this name to, I want to delete. Just mention key only, don't mention rest of the things, then you can, it is being deleted. Now if you want, you can see that here. Now we have updated a dictionary. We are not having this key value, that is second, which was created again, that is not there in our dictionary. So we have seen up till now how to update our dictionary, how to delete the things from our dictionary, or how to add any new key value. Now let's learn about conditional statements. In data science, we need conditions to make decisions. So let's see how. if, elif and else. So I'm going to write a small code and then I'll explain it to you. So here I have took one variable. We are working on this conditional statements, okay? So I have took one variable in which I am telling a user to tell me his age. So if you want to take input from user, then the value from user, then you can use this input, and then whatever the sentence you will write in over here, that will be asked to the front person. So it asked me, when I executed this code, it asked me about age, like enter your age, and then I gave the value whichever I wanted, and based on these conditions, then it has filtered that and printed me the statement, like whichever in this age which I have entered is fitting, then it is showing me with that value. So first condition was like, with these three things we are going to give conditions. So first condition was like, if age is greater than or equal to, these are operators, right? So this is our variable. So if age is greater than equal to 18, what is it going to print? Now as I have given the value of 34, so yes, it is greater than 18, so it has printed that you are eligible to vote. Elif, if not, then age is equals to 17, then what it was going to print? That almost there, one more year to go. And if the value which we are giving, or the user is giving, is will not satisfy both these conditions, means like age is not greater than or equal to 18, as well as if age is not even equal to 17, then what? Means like age is of 5 years or 10 years, then what? Then it is going to print that you are not eligible to vote. So if I'll again execute this cell, so now I will tell that age is equals to 17. Yeah, so it has printed that almost there, one more year to go. And if again I'll execute this cell, and here I'll give the age as 7 and press enter, then you are not eligible to vote. So these are the conditional statements, means based on the condition given, it is going to execute. So you can give any conditions, like if the color is not equals to blue, then it is not a ball, for like that, any kind of condition whichever you want to give. Like if the value is not of 24, then you can say that it is not fitting into the criteria. So there are many conditions where we need these conditional statements. These are also important, so we have to keep them in mind. Now next we are going to learn about functions. So what are these functions for? Functions helps us to reuse code and keep it organized. So let's create one function. Now in the previous example also I have created one function. Let's see if I can use that or not. No, it is not there. Okay, let's create one. For function we have to give a keyword, and keyword for the function is def, then the name which we want to give to our function. So I have took this name and assigned the value of name to it. Means like whatever the value we will give in the name, it is going to be executed. Means this function is going to be executed for that. So I have this function which I have created. For creating function we need the keyword, that is def. This is the name of the function, that is greet, and this I have passed the value to that argument. So in return it is going to just say hello to the name whichever we are going to pass. So here in the print statement I have passed the name as Dev and function is greet. So if there were different functions present, like greet is there, then maybe there was other function also, criteria, like different kinds of functions may be there in one code or one single book. So which function we want to access, we have to mention that, and then what value do we have to add, that also. So here I have given this value, and this is how a function is being created. So now as it is said that with the functions we can reuse code. Functions are there to reuse the code. So if now here I'll just write print greet, and now I have not written any functions, like means it is just a print statement, and it is telling that greet something and then Divya, this name I have passed. So what it is going to give me? I missed one closing bracket, so that is why it gave me the error here. Now I have not returned this function again over here in this cell, but still it is being executed. So this is how we can reuse the function again and again by just its single name, like whatever name we have given and whatever the code which we have written over there, that is going to be reused again with the different name. So this is how we are reusing the function. As we are working for the data science, so let's take something related to that only. So now we wanted to calculate the mean of this data. So we have this data and we wanted to calculate the mean of it. So we have created the function, and then this data is there. We have given this data and then print mean, calculate mean, and what we have assigned to it? Data. So this is also a real world example. Like in data science, we are going to use these things most of the time, right? We will have data and we are going to use these things. Like if we want to calculate mean, median, mode, so that's for that we can create a function and then store it, and then we can use it again and again. So like this things also. Now let's hear about lambda functions. So what are lambda functions? Let's see. For that I'll write an example and then I'll explain. Lambda functions are the anonymous functions like which we can use once in the program. See, we have to as before writing a function we have to mention it with the def keyword. So here also we have to mention it with the lambda keyword. So here I have written as square. This is we know that what it is. Like we have given this variable, and then in that within one line only I have written this function lambda x, and x double star 2 means x multiplied into 2 means whatever the value we are going to give of x, it is going to multiply with it 2 times. So like that, lambda functions are the anonymous functions. We have no need, like here we are defining here, this is calculate mean. So here there is no need to define any of the function over here. It is just by using lambda keyword we are going to use this. So this is lambda function, and just quickly hear about map also. Using map function with lambda. Now let's see for example for that. Here I have created a list of numbers like 1 2 3 4, these are the numbers in the list, and then here I took the variable of squared numbers in which I took that list. So I am going to use on list this squared number the thing. Then I'm going to map, means like I have created this lambda function and I have mapped it. Like this is only going to means I have now here you can see that we have got the output in the list only. If we would have not created this map, we would have got output like 1 2, even though if we would have used lambda functions, that is okay, we would have got this output like 1 4 9 16. These we have to square, then we would have made the square and then got the output. We want the output in the list only. So here in that cases this map comes in. So that's it for today. We covered data structures, conditions and functions, key concepts for data science. Now I'll give an assignment to you. So this is the assignment for you all. What you have to do is you have to write a function that takes a list of numbers and returns the maximum value from that list. So this is your assignment, and whatever your answers are, you have to drop it in the comment and then I'll analyze them. So like, subscribe and stay tuned for our next video on data manipulation with Pandas. Hey everyone, welcome back to my Python for Data Science series. Today we are diving deep into the 5 most important Python libraries that every data scientist must know: NumPy, Pandas, Matplotlib, Seaborn and Scikit-learn. Imagine trying to analyze data using basic Python. It's like trying to build a skyscraper with just a hammer. But these libraries, they give you superpowers. So let's unlock them together. But before we start, make sure you like, subscribe and hit the bell icon so you don't miss any future data science videos. First up, we have NumPy, short form for numerical Python. This library is a game changer for handling large amounts of numerical data efficiently. Python lists are cool until they starts behaving like a tired tortoise with large datasets. But NumPy, it's like a sports car. So how do we install NumPy? So in our system, we already have installed NumPy, so that is why it is showing us. To bring NumPy in a notebook, we have to import it first. So how we are going to import? Import NumPy, and this is alias. Means like we are using short form for NumPy, that is NP. Means for numerical Python there is NumPy, and for NumPy there is NP. Too much shortcuts, right? Okay, so we have imported NumPy in our notebook. We have not given name to this notebook actually. So let's quickly give name to our notebook. This is a third. Okay. Now creating NumPy arrays. Most of the time what happens, lists are there, but we cannot use list for large data sets or like that. There are some of the limitations that list have. And in array also there is one limitation, that is we have to store the data of same kind, like heterogeneous data we have to store in it. So to overcome these limitations we have this NumPy. So let's first create an array using NumPy. For that what we are going to do is, so see, this is the simple array. It's like it is list, but it is an array or it is a NumPy. Okay, so we have printed it, just a simple code, right? We have just created a NumPy array. Why do we, even though we are having list, but still why though we are using NumPy array? So there is one code snippet. I'll just write it quickly and then you will understand. After execution, you will understand the thing clearly. So this is the code snippet I have wrote over here. Here, what is the difference? We are the time of a list to execution and the time of NumPy list or NumPy array for execution. So you can see the difference between both of them. So for that I wrote this code. What I have did is imported time. Then for size I have initialized this value. For list one I have created this, and for NumPy array I have arranged it. So I have arranged the size in it. It was just to show that why we should use NumPy, because it is faster than least. NumPy always wins in terms of speed, and not just that, it also helps with matrix operations, statistical functions, and more cool features. Let's take another example. Now, as I said that it works with matrix also. So what I did over here is I have just created a matrix within just this single line. Like np.zeros, I want to create a matrix of zeros, and how much 3 by 3 matrix I have created over here. So working with these matrices also becomes easy. Like if we are going to create a matrix with the list, then it will take our time to write the code. Okay. Same I have did with one also. So this 2 by 2 matrix I have created, and random values I have took to create the random matrix. So these are the random values which it has took by itself. So NumPy is like a superhero. It slices, dices and calculates at super speed. So now next we are going to learn about pandas. So Pandas is your best friend for data analysis. What is Pandas? Built on top of NumPy. It handles CSV, Excel, JSON, SQL and more, and performs powerful data operations easily. So how we are going to install? We have already installed it in our system, so we can directly import PD. So now it has been imported. So in Pandas there are two things, that is series and data frames. So now let's understand this. I have created a data, and in that there is name. There are 3 values for the name. For age there are 3 values, and for salary there are 3 values. So we can consider this as a data. So this is df. Df is what I have stored. This is a variable I have took, and in that I have stored my data. So this is the data and I have stored it in this df. So PD is for our pandas, right? We have imported pandas as PD. So we can use this PD whenever we want to use pandas. So PD dot, and in pandas as we have series as well as data frame. So where the series is, and series I wanted to print the data from panda into series. So like that it is, and then data is there. So when I printed this, when I executed this, you can see the value of name, age, salary. These are in the columns. These values are also in the columns. It is not a proper format for right now, right? If I could have value of just one name, like in dictionary how we have key value pair, so like that if my data would have been, then series was okay, right? But now, so series are where we want to print the data into columns. Series is like if we are having a data, and then I could have explained it better, but okay, I'll explain it from here. So series, if we are printing the data into series, we get series means we want to execute or we want to extract the data in just one column. To work with the column, the series data is there. So series, we can go with the series. Next, if we want data frame, mostly this is used because data, we cannot, whenever we are working for the data, we cannot work for just one column, right? It depends. So when we want whole table, or when we want to work with that full data set, then we are going with the data frame, because data frame is like this. In data frame, it is all organized. We can work with multiple columns. So that is the difference between series as well as data frame. So in pandas we have both the things, that is series as well as data frame. In series we are working with just one particular column, and data is also executed in the column format. Okay, here also you can see this. And in data frame we are getting whole table only. So in just few lines we have loaded and explored a data like a pro, right? Or if you want, now there are no 5 rows, right? Like there are only 3 values, so that is why it is not getting. But let me show you one example. df So if I want to just see the things from above, means like starting to things, or the starting rows I want to see, then I can use this head, print df. Df is a data, means like it is a variable in which our data set is stored, and then head means the first rows. From first rows we have given it the value of 2, means it is going to print the value of, means like first 2 rows values it is going to print. So here you can see. Now whenever we are working with the large data sets, so at that time we can just view first 5 rows and then work with that. So like that, if you want to see like what columns are present in a data set, then we can use this, right? df.head. Same goes with the tail also, means like if we want to see the values from below, then we have the option of tail, and there also we have to give the values like from bottom how many rows we want to see. So now next we are going to learn about Matplotlib, the ultimate visualization tool. Now that we have data, let's visualize it with Matplotlib. So how we are going to do that? Yes, so Matplotlib was already in our system, so that is why it is showing that requirement already satisfied. Now let's create a simple line chart for the data. So okay, I have created this data. In my x variable I am having these values, and in my y variable I am having these 10, 20, 25, these values. So what I am going to do, PLT is like Matplotlib, right? We have used alias and then created this short form for Matplotlib. In that I have x and y. What I want to give title to this. Now in the line chart there are x-axis as well as y-axis. Okay, so for that so we have created a simple line chart. For Matplotlib is for basic plotting. Okay, explain this. So in my x-axis I was having this data, in my in my x variable I was having this data, and in my y variable I was having this data. PLT is like Matplotlib. So Matplotlib, from that I want this plot. There is one folder, okay, and from that folder I want a particular thing, and I know the name of that particular thing, okay. So from Matplotlib folder I am it is just for example, okay, it is not a folder, it is library, yeah. So from Matplotlib folder I am taking plot. In that there is this plot named function, and from that plot, what I want to plot with that function, I want to plot x and y, and x and y are these things. So from there I have to these x and y, and from matplotlib.plot I am giving the values of this x, and then whatever there is a plot function, it is going to execute this for this y. We have seen function like there are already written code, and then we can just execute them using whatever our variables we want to pass, right? So we are passing these variables, and then the function which is in Matplotlib, it is going to execute. Same goes with this title also. Title named function is also there, and what that title does is this, we have passed the variable for line chart. So the title to our simple this line chart is being given, that is line chart. Whatever we want to pass the title, then it has given over here. We have passed whatever we wanted to give title, and then it is being seen over here. Next, now as we are plotting it like line chart we are plotting, there x-axis comes and y-axis comes, okay. So what you want to now, if we don't label them, if we don't tell that this is x-axis, this is y-axis, and for what value you want to give to x-axis, y-axis, then it is not we cannot understand, right? We are making visualizations, and we should make clear visualizations. The front person who is going to view those visualizations, he or she should understand that this is x-axis, and on the x-axis we have the data of this thing, on the y-axis we have data of these things, like that there is need, right? So there is x-axis, y-axis, it is okay, but if we don't label them, we cannot understand the data, right? So that is why this from plt x labeled function is there, and in that, for that I have given this name, that is x-axis, and for y I have given y-axis. Plt.show, what it does, it just shows whatever we have created this thing over here. So it is going to show. So this is the simple line chart we have created. So Matplotlib makes it super easy to turn numbers into beautiful charts, right? Now let's learn about Seaborn. So let's learn about Seaborn, that is Beautiful Statistical Visualizations Library. If Matplotlib is great, Seaborn makes visualizations even better. So let's see how. We have Seaborn in our system, so we are just going to import it. Now let's create a histogram. Simple histogram I'll create. Okay, this was simple line chart. We need extra visualizations also, right? So for that we need data. So to create a histogram we need data. I have created this data over here. It is just simple names and age and then salary of those peoples, okay. So next what we are going to do is we are going to store it into df, that is data frame. So this was the sample data which I took and then which I wrote over here. we stored it into df from pandas.dataframe. What we have did from pandas.dataframe, what we did, we have took that data and stored it into this df variable. Okay, from sns, as we have imported sns means cborn.hist, we want to print histogram, right? So for histogram and then plot means we are going to just plot it. For whatever thing we want to visualize, we have to write it plot. So histogram, plot, and then what we want to plot from that, salary. So salaries column is being printed over here, and bins means like this distribution of 0.00 is there, then 25 is there, 50, so like this difference is there. And then here salary is there, and then here count is there. And plt.show, what it does, we know that, right? Now let's create a scatter plot. So what is scatter plot? We know that, right? So we have created the simple scatter plot using SNS. SNS we know C1 it is scatter. We have did the same thing which we have done for a histogram only. Just we have to write the whatever chart we want to print. So scatter and then plot, and then we have passed the variables, or we have passed the columns which we want to plot, and then plt.show. Simple, right? So C1 gives us stunning visualizations with just one line of code, right? This is just a one line of code, and it has given us this chart. So installing Seaborn is great, right? For this simple line chart, what we needed to give labels also, right? We needed to give title also, but here in Seaborn, you can see that there was no need to give the labels to it. Next we have Scikit-learn library. Scikit-learn library is the machine learning powerhouse. It is the go-to library for machine learning in Python. Now I'm not going to explain much about Scikit-learn, because we are going to see Scikit-learn in depth for creating models. We are going to, in further videos, we are also going to create models. So for that I am going to keep this Scikit-learn and I'll explain it over there. But for right now, you must have understood, like we have NumPy. For what NumPy is there, how we are going to use NumPy, and what is the difference in the speed of least and NumPy. Why we are using libraries. Every library has its own feature to enhance our code. Okay, Pandas is there. In Pandas we have series and data frame. How we are going to clean the data with the Pandas, we are going to see that in the next video. So stay tuned for that video. Okay, don't forget the things. And then we have seen about plotting. With the Matplotlib we have this basic plotting things. How we are going to create plots with the Matplotlib. Here it is, we have data, and we have just there are functions present in that library. We just have to bring them and pass our variables, pass whatever is present in our data. So understanding data is also important. Next we have learned about the Seaborn library, how we are importing the Seaborn library, and then we have took this data, simple data it is, right? And then we have stored that data into data frame, into data frame, and then in df. Then we have plotted histogram and scatter plot of it. So today we covered most powerful libraries for data science. NumPy is for numerical computations, Pandas for data handling and analysis, Matplotlib for basic data visualization, Seaborn for beautiful statistical plots, and Scikit-learn is for machine learning, which we are going to learn in the upcoming videos. So if you enjoyed this tutorial, smash the like button and tell me in the comments which topic should I cover. Also subscribe for more awesome data science content. Hey everyone, welcome back to my Python for Data Science series. Today, we are diving deep into the 5 most important Python libraries that every data scientist must know. NumPy, Pandas, Matplotlib, Seaborn, and Scikit-learn. Imagine trying to analyze data using basic Python. It's like trying to build a skyscraper with just a hammer. But these libraries, they give you superpowers. So let's unlock them together. But before we start, make sure you like, subscribe, and hit the bell icon so you don't miss any future data science videos. First up, we have NumPy, short form for numerical Python. This library is a game changer for handling large amounts of numerical data efficiently. Python lists are cool until they starts behaving like a tired tortoise with large datasets. But NumPy, it's like a sports car. So how do we install NumPy? So in our system, we already have installed NumPy, so that is why it is showing us. To bring NumPy in a notebook, we have to import it first. So how we are going to import? Import NumPy, and this is alias. Means like we are using short form for NumPy, that is NP. Means for numerical Python there is NumPy, and for NumPy there is NP. Too much shortcuts, right? Okay. So we have imported NumPy in our notebook. We have not given name to this notebook actually. So let's quickly give name to our notebook. This is a third. Okay. Now creating NumPy arrays. Most of the time what happens, lists are there, but we cannot use list for large data sets or like that. There are some of the limitations that list have. And in array also there is one limitation, that is we have to store the data of same kind, like heterogeneous data we have to store in it. So to overcome these limitations, we have this NumPy. So let's first create an array using NumPy. For that what we are going to do is, so see, this is the simple array. It's like it is list, but it is an array, or it is a NumPy. Okay, so we have printed it, just a simple code, right? We have just created a NumPy array. Why do we, even though we are having list, but still why though we are using NumPy array? So there is one code snippet. I'll just write it quickly, and then you will understand. After execution, you will understand the thing clearly. So this is the code snippet I have wrote over here. Here, what is the difference? We are the time of a list to execution and the time of NumPy list or NumPy array for execution. So you can see the difference between both of them. So for that, I wrote this code. What I have did is imported time. Then for size, I have initialized this value. For list one, I have created this, and for NumPy array, I have arranged it. So I have arranged the size in it. It was just to show that why we should use NumPy, because it is faster than least. NumPy always wins in terms of speed, and not just that, it also helps with matrix operations, statistical functions, and more cool features. Let's take another example. Now, as I said that it works with matrix also. So what I did over here is I have just created an matrix within just this single line. Like np.zeros, I want to create a matrix of zeros, and how much 3 by 3 matrix I have created over here. So working with these matrix also becomes easy. Like if we are going to create a matrix with the list, then it will take our time to write the code. Okay. Same I have did with ones also. So this 2 by 2 matrix I have created, and random values I have took to create the random matrix. So these are the random values which it has took by itself. So NumPy is like a superhero. It slices, dices, and calculates at super speed. So now next we are going to learn about pandas. So Pandas is your best friend for data analysis. What is Pandas? Built on top of NumPy. It handles CSV, Excel, JSON, SQL, and more, and performs powerful data operations easily. So how we are going to install? We have already installed it in our system, so we can directly import PD. So now it has been imported. So in pandas there are two things, that is series and data frames. So now let's understand this. I have created a data, and in that there is name. There are 3 values for the name. For age there are 3 values, and for salary there are 3 values. So we can consider this as a data. So this is df. Df is what I have stored. This is a variable I have took, and in that I have stored my data. So this is the data, and I have stored it in this df. So PD is for our pandas, right? We have imported pandas as PD. So we can use this PD whenever we want to use pandas. So PD dot, and in pandas as we have series as well as data frame. So where the series is, and series I wanted to print the data from panda into series. So like that it is, and then data is there. So when I printed this, when I executed this, you can see the value of name, age, salary. These are in the columns. These values are also in the columns. It is not a proper format for right now, right? If I could have value of just one name, like in dictionary how we have key value pair. So like that, if my data would have been, then series was okay, right? But now, so series are where we want to print the data into columns. Means series is like if we are having a data and then I could have explained it better, but okay, I'll explain it from here. So series, if we are printing the data into series, we get series means we want to execute or we want to extract the data in just one column. To work with the column, the series data is there. So series, we can go with the series. Next, if we want data frame, mostly this is used because data, we cannot, whenever we are working for the data, we cannot work for just one column, right? It depends. So when we want whole table or when we want to work with that whole data set, then we are going with the data frame, because data frame is like this. In data frame, it is all organized. We can work with multiple columns. So that is the difference between series as well as data frame. So in Pandas, we have both the things, that is series as well as data frame. In series, we are working with just one particular column, and data is also executed in the column format. Okay, here also you can see this. And in data frame, we are getting whole table only. So in just few lines, we have loaded and explored a data like a pro, right? Or if you want, now there are no 5 rows, right? Like there are only 3 values, so that is why it is not getting. But let me show you one example. TF. So if I want to just see the things from above, means like starting to things, or the starting rows I want to see, then I can use this head, print df. Df is our data, means like it is a variable in which our data set is stored, and then head means the first rows. From first rows, we have given it the value of 2, means it is going to print the value of, means like first 2 rows values it is going to print. So here you can see. Now whenever we are working with the large data sets, so at that time we can just view first 5 rows and then work with that. So like that, if we want to see like what columns are present in a data set, then we can use this, right? df.head. Same goes with the tail also, means like if we want to see the values from below, then we have the option of tail. And there also we have to give the values like from bottom how many rows we want to see. So now next, we are going to learn about Matplotlib, the ultimate visualization tool. Now that we have data, let's visualize it with Matplotlib. So how we are going to do that? Yes, so Matplotlib was already in our system, so that is why it is showing that requirement already satisfied. Now let's create a simple line chart for the data. So okay, I have created this data. In my x variable I am having these values, and in my y variable I am having these 10, 20, 25 these values. So what I am going to do, PLT is like Matplotlib, right? We have used alias and then created this short form for Matplotlib. In that I have x and y. What I want to give title to this. Now in the line chart there are x-axis as well as y-axis. Okay, so for that so we have created a simple line chart. For Matplotlib is for basic plotting. Okay, explain this. So in my x-axis I was having this data, in my in my x variable I was having this data, and in my y variable I was having this data. PLT is like Matplotlib. So Matplotlib, from that I want this plot. There is one folder, okay, and from that folder I want a particular thing, and I know the name of that particular thing. Okay, so from Matplotlib folder it is just for example, okay, it is not a folder, it is library. Yeah, so from Matplotlib folder I am taking plot. In that there is this plot named function, and from that plot what I want to plot with that function, I want to plot x and y, and x and y are these things. So from there I have to these x and y, and from matplotlib.plot I am giving the values of this x, and then whatever there is a plot function, it is going to execute this for this y. We have seen function, like there are already written code, and then we can just execute them using whatever our variables we want to pass, right? So we are passing these variables, and then the function which is in Matplotlib, it is going to execute. Same goes with this title also. Title named function is also there, and what that title does is this, we have passed the variable for line chart. So the title to our simple this line chart is being given, that is line chart. Whatever we want to pass the title, then it has given over here. We have passed whatever we wanted to give title, and then it is being seen over here. Next, now as we are plotting it like line chart we are plotting, there x-axis comes and y-axis comes. Okay, so what you want to, now if we don't label them, if we don't tell that this is x-axis, this is y-axis, and for what value you want to give to x-axis, y-axis, then it is not we cannot understand, right? We are making visualizations, and we should make clear visualizations. The front person who is going to view those visualizations, he or she should understand that this is x-axis, and on the x-axis we have the data of this thing, on the y-axis we have data of these things, like that. There is need, right? So there is x-axis, y-axis, it is okay, but if we don't label them, we cannot understand the data, right? So that is why this from PLT x labeled function is there, and in that, for that I have given this name, that is x-axis, and for y I have given y-axis. PLT.show, what it does, it just shows whatever we have created this thing over here. So it is going to show. So this is the simple line chart we have created. So Matplotlib makes it super easy to turn numbers into beautiful charts, right? Now let's learn about Seaborn. So let's learn about Seaborn, that is Beautiful Statistical Visualizations Library. If Matplotlib is great, Seaborn makes visualizations even better. So let's see how. We have Seaborn in our system, so we are just going to import it. Now let's create a histogram. Simple histogram I'll create. Okay, this was simple line chart. We need extra visualizations also, right? So for that we need data. So to create a histogram, we need data. I have created this data over here. It is just simple names and age and then salary of those peoples. Okay. So next what we are going to do is we are going to store it into DF, that is data frame. So this was the sample data which I took and then which I wrote over here. We stored it into DF from pandas.dataframe. What we have did from pandas.dataframe, what we have took that data and stored it into this DF variable. Okay, from SNS, as we have imported SNS means cbon.hist, we want to print histogram, right? So for histogram and then plot means we are going to just plot it. For whatever thing we want to visualize, we have to write it plot. So histogram, plot, and then what we want to plot from that, salary. So salaries column is being printed over here, and bins means like this distribution of 0.00 is there, then 25 is there, 50, so like this difference is there. And then here salary is there and then here count is there. And plt.show, what it does, we know that, right? Now let's create a scatter plot. So what is scatter plot? We know that, right? So we have created the simple scatter plot using SNS. SNS we know C1 it is scatter. We have did the same thing which we have done for a histogram only. Just we have to write the whatever chart we want to print. So scatter and then plot, and then we have passed the variables or we have passed the columns which we want to plot, and then plt.show. Simple, right? So C1 gives us stunning visualizations with just one line of code, right? This is just a one line of code and it has given us this chart. So installing Cbon is great, right? For this simple line chart, what we we needed to give labels also, right? We needed to give title also, but here in Cbon you can see that there was no need to give the labels to it. Next we have Scikit-learn library. Scikit-learn library is the machine learning powerhouse. It is the go-to library for machine learning in Python. Now I'm not going to explain much about Scikit-learn because we are going to see Scikit-learn in depth for creating models. We are going to, in further videos, we are also going to create models. So for that I am going to keep this Scikit-learn and I'll explain it over there. But for right now, you must have understood, like we have NumPy, for what NumPy is there, how we are going to use NumPy, and what is the difference in the speed of least and NumPy. Why we are using libraries. Every library has its own feature to enhance our code. Okay, Pandas is there. In Pandas we have series and data frame. how we are going to clean the data with the pandas, we are going to see that in the next video. So stay tuned for that video, okay? Don't forget the things. And then we have seen about plotting. With the Matplotlib, we have this basic plotting things. How we are going to create plots with the Matplotlib. Here it is. We have data and we have just there are functions present in that library. We just have to bring them and pass our variables, pass whatever is present in our data. So understanding data is also important. Next, we have learned about the Seaborn library, how we are importing the Seaborn library, and then we have took this data, simple data it is, right? And then we have stored that data from into data frame, from the into data frame, and then in df. Then we have plotted histogram and scatter plot of it. So today we covered most powerful libraries for data science. NumPy for numerical computations, Pandas for data handling and analysis, Matplotlib for basic data visualization, Seaborn for beautiful statistical plots, and Scikit-learn is for machine learning, which we are going to learn in the upcoming videos. So if you enjoyed this tutorial, smash the like button and tell me in the comments which topic should I cover. Also subscribe for more awesome data science content. Hey there, data enthusiast. Welcome back to another exciting episode on MCAA Global. Today, we are diving into one of the most crucial steps in data science, that is data cleaning with pandas. So, if we have messy data sets or missing values or maybe duplicates in a data set, then there is no problem. By the end of this video, we are going to clean it all. So, what we are going to cover in this video? We are going to handle missing values, removing duplicates, changing data types, detecting and removing outliers, and encoding categorical data, and much more things. So grab a snack and let's clean some data. So here I have opened a Jupyter notebook, means like I've opened Anaconda Navigator, and from that this folder which we have created, that I have opened. Now in the first chapter first video, we have created this first file, then second, this third, and this employees CSV file I am going to use today to clean. I have just downloaded it from Kaggle, so you can also take. So let's quickly take new Python file and give it a name. So we have renamed our file. Now today we are going to start with our data cleaning. So alright, let's start by importing our favorite libraries. Libraries we have learned in our previous videos, seen what kind of libraries are there and what libraries are, or common type of libraries which we are going to use. So first library which we want is, now as we are cleaning the data with pandas, right? So we need pandas. So how we are going to import it? We have to write import keyword as pd. Next, the library which we are going to need, that is NumPy. So okay, these all are the libraries which we are going to need in our today's video. So we have imported pandas. We know how pandas is and what pandas is actually. We have seen it in the previous videos. NumPy, we know that for numerical data we are going to need it, like if we have data into list or like that, or we need a data into array form, then we are going to need this NumPy library. Next, Seaborn is for making Seaborn and Matplotlib. Both we know, like it is for basic plotting and it is for statistical plottings, right? So these all are the libraries. Now let's execute it. How you can just click on this run button and then also you can execute it. But now I'm going to go with Shift Enter option, because it will also execute that cell as well as create new cell also. Now let's load the data set, our main thing, that is data set, right? We need a data set, and I've told that I have took the data set from Kaggle, so you can also take that. Now let's load the data set. What I have did, I have downloaded that data set and then I have saved that data set or moved that data set in the folders in which these in which these files I am storing. Okay. Now let's load our data sets. Imagine you work at company and you have been given employees file. So let's take a quick look at that file. So I'm creating this variable. In this variable, I'm going to store that data set, or I'm going to take that data set and it is being stored in this variable. We know what variable is, right? So this we are going to take this pandas. Now what is this read underscore CSV is doing? It is going to read that file which we are going to give the location of. Now how you are going to take your CSV file into here. Here, this is the important step, okay? You have to mention the path of that file and it should be very accurate. So what you have to do is, and this slash line, what it is going to do is, it is going to change the folders. So make sure where your file is and then go according to that. So I have in my PC users name folder. If you press tab, then also you can see in which folder you're going to have that file. So here it is already showing me like I am only having this single file, means like in users in this folder, then in this Python for data science folder, these many files are available. So from this which I want to select, I can just click on that. Now we have loaded the data set, okay? We need to see that data set. So just execute this cell and you can. Okay, so these things are present in a data set. I have took this data set small only so we can understand the things. Or even whenever we are working on any of the data set, we are just taking first 5 or 10 rows and then we are working on it. Okay, so let's see what we have in our data set. This is the employees data set. So we have ID, we have name of those employees, then their age. See, age here it is in the decimal form, right? It is not needed. So that is also thing we are going to see. Here you can see this NAN. NAN means there is no value over there. So means this David named employee has not mentioned his age. So we have now this is a null value we can say. So we have to clean this value. So how that we are going to see in here, this departments, like in which department these employees are. So that is also present over here. Then their salaries. Here also one employee's salary is not being mentioned. Then their joining dates are there. Okay, city is there. In city also we have some null values. Okay, education is okay. Okay, fine. So now we have understood our data. We have loaded the data set and then we have printed it. So as I told that this is a small data, so it is okay, fine. But whenever we are working, so we may not have this small kind of data. We may have data of 200, 500, 1000 and many more rows may be present in a data set. So are we going to view all the data and then going to clean it? No, right? In case if you want to just print first 5 or 10 or 15 rows, then in that case what we can do is we have this option of print. Print is a printing statement from data frame. We are going to, this head is there, and in that we have to mention like how many rows we want to view. So let's take 5 if we'll take. and then enter. So you can see that only the first five employees information is being displayed over here. If we change the number over here, like from 5, if we take as 3, then see only 3 employees, 3 rows information is being displayed to us. So this is also a thing present. Same now if we want to view the data from bottom, so we have the option of that also. Print df dot and tail. Now from last, how many rows do you want to view? So let's take this 4 and then execute this. Okay, from last, see 9, 8, 7, 6. These were the last rows of our data set, right? So from last we are going to see these 4 employees information. So this head and this tail is there. So now we have our employees data set. Okay, but is it ready to use? So let's check that. So here this df means we know that it is a data set, right? So information of that data set we are going to see. So what is the type of it? It is data frame, and then indexes means range of indexes is there are 10 entries, means like 10 values are present. See, it is starting from 0 until ending till 9, so it is 10, right? So there are 10 entries, 0 to 9, means like indexes are from 0 to 9. So that is given over here. There are total 8 columns, means it is showing us information of our data. So there are 8 columns present, and the column names are mentioned over here, like ID, name, age, department, salary. These are the columns present. Okay, not null count and data type means what is the data type of ID? It is integer. Name, it is object. For age, it is float. I think for age we don't need this float, we can change that. So how we are going to change? We are going to see those things. Salary, department, and all the things, means like what is the data type of those columns? It is present over here. Then as we know that we have 10 entries, right? So here it is showing that non-null, means in age there is one thing missing. In one block there is empty value. We have seen that it was NaN, right? So in salary also we have one empty value or empty block is present over there. In city also there is one empty block. So educational level, okay, it is also there, column only. So data types, what kind of data types in all do we have? We have object kind of data type, there are 5. 64 means like integer kind of there, it is one column only in which integer values are present, and float there are 2. So how much of memory usage is there? It is showing us. So what is the information if we want information about our data set? Now if there is large or big data set, so what we are going to do? We are just going to print df.information and info, and then we will get like how many columns are there, what type of columns are there, if there are any null values, so like that. There is one more thing. So this df.describe itself is telling what it is going to describe, means it is going to describe a data set. That is okay. So here it means like what were the numerical columns present in our data set. So those columns it has took, and from that what this describe is going to do, it gives summary statistics like mean, median, and standard deviation of our the integer, means whatever the integer columns are there, of those only. It has also took float also. Okay, so what is anything that is related to numerical, it is going to show those, because mean, median, those things can be done with the numerical columns only, right? Numerical values can be only we can remove the mean of that, standard deviation of that, so like that. So it is going to describe a data set. So here it has told us count, like 10 is there. In age, as there is one missing value, so it is showing us there are 9 values in age. Then mean of those columns, standard deviation, minimum value in the column, so like that. Here this 25%, 50%, and 75%, this is also important. Okay, I'll tell you why it is important. So but just keep in mind that it is also important. Whenever we are going to learn the concept of IQR, that time I will tell you. Now let's check if our data is having missing values. We have already known that in our 3 of the columns, here also it is telling us, right, that in age there are 9 values, and in salary there are also 9 values, because so there is one missing value in that columns. So still we are going to check it. So these missing values can cause major issues. So let's check for them and then solve them. So what it is doing, telling us that print from df if there is anything null, then that, and make sum of that. So let's see how much is there. So it has counted all the things and then shown us. So in our age there is one missing value, in our salary there is one missing value, as well as in city also there is one missing value. So what this is now here, what is important, this is null. So what this is null is doing, it is counting the numbers of missing values per column, and this sum, it is going to show us the sum of that. Okay, so there are some ways in which we can handle these missing values. So what are those? First is there we can remove them, but it is not ideal. We may lose the data, right? If we will remove this age, this one column is okay. I'll show you only where it is. In the age we were having here, if we'll remove this, then it will be empty, right? And then it will not give us accurate results. So removing them is not a good option. Okay, it is not ideal option. So we are not going to go with that. Next, what we can do is we can replace with default values. This we can do if we are having any default values, so we can replace it with that. Or we can use statistical measures like mean, median, mode. If we can use the use mean, median, mode on them, anything that is statistical measures, if we can use on them, then we can use it and then solve that null value, right? Means what I'm going to do is I'm filling them with the default values. Okay, default means whatever values are present, like I'm going to first remove mean of them, or whatever is preferable to you, that you can do. Okay, now fill with, I'm telling it to fill this whatever empty value is there, I'm telling it to fill with the mean of age column. Okay, okay, so now what I have did over here is to handle our missing values. That is, in the age we are having one missing value, right? So what I have did, this is a data frame or data set, and from data set I have took that column in which empty value is there. So this is the age, and in this we are having empty value. Fill now what it does is it fills that value which is empty in that column, in this column. So it is going to fill that value with what we have to mention that. So from df age, what we have to fill that value with the mean of that column. So that it is telling us to do. So we have written that. Same goes with the salary also, but here we are filling that empty value with the median of salary column. And now as city is the string, in city the values are present in string, right? So that in that column which is empty, okay, there I have put this unknown word. This unknown I have put over there. Here we are having this where is it, the city? Okay, here this empty value is there. Here I am telling in that block of code that put here unknown. Okay, so now this is okay. If we'll execute this, it is going to run and it is going to show us. Okay, so here see, it has just executed the city column, and then unknown is this value is being seen over if that empty was there. So I have printed the data set again. Okay, Here you can see in age we were having one null value, right? So it has filled this that empty value with the mean of this column. Then in salary we were having with the medium, it has filled that empty value. And in city it was here it was value, and we have filled that with unknown value. If we would have got any default value, then we could have filled it with that also. So this is how you are going to fill. You are not going to drop the you are not going to remove them, because removing them is not a good option. Now every employee has an age, salary and a city, and there are no more blanks. Even if for every employee there is no city, for this Eve there is no city, but still we can tell that our data is filled. Now if you must have observed this data clearly, you could have saw this alias is present over here, okay? Department is IT, salary is there, joining date, and everything is okay. So here the seventh index, you can see that there is alias. Again there is same person with same salary with same department, and all the things are same of that. Means this person's information is being repeated in a data set, right? So this is the duplicate. So now we are going to handle this duplicates only. So what this is going to do is whatever duplicate rows are present and whatever the count of them is there, it is going to print it over here. Okay, so we are going to directly drop them from our data frame. We have this drop function, means like drop duplicates. So now whatever duplicates are there, those are being dropped. What this duplicated and sum does, it counts duplicate rows and returns them. And this drop duplicates, what it is going to do is it removes them permanently. So there are no more clones. If an employee appeared twice, we just remove that duplicate. Clean data is happy data, right? So next what we are going to do is we are going to convert the data types. We have seen what data types are there of our each column, right? In the information, I think yes, in this information here there are column names, and here there are their data types. So they were not proper, right? So we are going to change those data types. So now let's fix incorrect data types. Having dates as text is disaster. So let's do it quickly. Okay, now we are going to change the data types. First what we have did is, what this code is, I'll explain it first. We have took this df means a data set, we know that. From that data set, this joining date is there. Here also you can see this joining date is there. It's let's see, where is this information we have printed? Yeah. So here this joining date, what is the data type of it? It is object, and we know that it is not right. So we have to change that. This joining date we have selected the column whichever we wanted to change the data type of. Then from PDs are pandas, right? From pandas we have this toDateTime function. So whatever we have selected this, it is going to change the type of it as date time. So we have mentioned it over here. Same goes with the salary also. We have this salary column, and for salary also I think it was not detected. Where is this information again? Yeah, for salary also it is float. Okay, we want it into integer, so we have the as type of int. We want to make it of integer, right? So we have did that. If you want to see again, what you can do is df.info. We can again print it and we can see. Here now, if you will see the data type of this joining date, you can see that it is date time. And what we changed again, we changed the salaries also, right? So this salaries is in the integer form. So this is how we are going to change any of the data type if we want. For that we need to know that how many data types are present in Python, right? Now we have to remove outliers. Outliers are those which whose flow is not normal from everyone. Like if, let's consider this as a group of friends, okay? If in any of group of friends there is one friend who is totally different from that group, right? So like that there are outliers. Means like this whole data set is there, everyone is functioning properly, and one of the member is not don't want to be in this group. So like that the outliers are there. So outliers can mess up our analysis. So let's visualize them, okay? Now we know this SNS is what, right? So what we have did from SNS means why this blocks plot, I'll tell, okay? From this SNS means a Seaborn library, okay? From Seaborn we are plotting this box plot, and in that now it is going to be y-axis, x-axis, okay? So for x we have given the value of salaries. From salaries there might be a outlier present, and there is, okay? I'll tell you why there is outlier in salary, okay? So everything here is okay. So you can see this salary of first person is like 50,000, then 45, 52, okay, this is also 62, it is also okay, acceptable. Then but here you can see the salary like 4 lakh and like that, it is not acceptable, right? So this is an outlier. So we have took this salary column. And why this box plot? There are many things that in which we can plot, like many different visualizations are present, right? But why this box plot we have took? Because it visually represents the distribution of data and highlighting extreme values. Means if there is any value which is not in the range, or not in proper format, or not following the order, then it is going to detect that and it is going to highlight that. So that is why highlighting extreme values that falls outside the normal range. So that is why we have took this box plot, and let's see what it will give us. So it has detected that anomaly or outlier. So let's remove them using the interquartile range. And what is this IQR? If you want to know, you have to mention it into comments, then I can make a video over on that also. So I told you that when we were printing that df.description, right? So in that there was 25%, 75%, like that was also there. So that is related to this Q1, Q2, Q3, okay? So I told you what is IQR, that is interquartile range, okay? So it has one formula, and based on that formula we are going to solve this error or solve this outlier. So we have executed this and we have solved this outliers. So let's see how we have did that. So now what this has done, it has removed those outliers. Okay, so let's say goodbye to our extreme outliers. Now a salary distribution looks much better. If you want to see, let's see. So now in salary, see, it has changed that salary, it was not acceptable, so that salaries, it was changed the thing. So now let's learn about encoding categorical data. So turning words into numbers. Why this encoding is important, I'll tell you. Because machines don't understand text, right? Machine will not understand this bachelor's, this master's, this city. It is not going to understand. It is a human understandable language, right? We are working and we are solving, or we are filtering data, cleaning that data in the machine level language, right? Human language, right? So but machines are not going to understand it. So how machine will work and give us the output? So machine will not understand these words like HR or finance. So what we have to do is we need to convert them into numbers. So how we are going to convert them? Let's see that. Take your data set. In the pandas, we have this get dummies function. Means it is going to create dummies of this, and then like of which we want to convert, that it is asking. Means we know about binary numbers, right? Like zeros and ones. So it is going to categorize those things in this zeros and ones. Means like here there is bachelor's, master's, okay. So in now in numbers, it is going to form like give the values. Means like this 30 is greater, then it is going to give this value as 1, then it is 0. So like that it is going to sort the things and give them binary numbers, okay. So and whereas in the text, what it is going to do, so it will first take the alphabet. Like if you must know that how in the dictionary the numbers are text are arranged, like words are arranged. So first if we want to search any meaning of the word, then what we do is like it is starting from S, so we will go in the S section, and then from S, so we sort it, like we sort the things and then we search it. So it makes that things easier. So in that way only it is going to sort the things and then give them 0, means binary numbers, and then it will create, means like encode it. So that is what only happens in this encoding thing. So in pandas there is a get dummies named function, so we have took that, okay. And from Scikit-learn dot preprocessing, it is an SNS, okay. So from that Scikit-learn, means because Scikit-learn is not proper or separate library, okay. It is not different or individual library, it is in the Seaborn. So from Scikit-learn, because we have imported Seaborn, right? So from Scikit-learn dot preprocessing, in Scikit-learn, that is preprocessing named function, from that we have imported this label encoder, and we have created the variable named encoder. In that, this label encoder means like why we are going to write all the function, right? So we have just mentioned that function in this encoder, and then we have encoded our things like in. So now every category is represented as numbers. So it is ready for machine learning, okay. So machine can understand our code now. So we have cleaned our this simple small employees file, okay. In that we have detected the outliers, we have removed the duplicate values, we have and what else we have did, let's see from first only. Okay, so we have loaded the data. We have seen that from, if we want to view the data from top, then we can how we can do that with with this head function. Same with we have a tail also. What this info does, info is going to tell us the description, like all the information about our data. Describe what it is showing, that is also important, right? Then one more thing was there in our I'll execute this. In our data set, if there are now here only 8 columns were present, okay, but there might be the case that in our data set there may be 15 to 20 columns, right? So if you want to see the name of those columns, so what we are going to do, so from data set we have this columns option also, like head, tail, info, like that. We have these columns also. So whatever columns are present, it is going to show us. Like if we want to change the column name or like that, then we can use this and then work with it, right? So in the last, what we are going to do now, we are going to save this clean data set. This data set we have worked on it, right? We have handled the anomalies, like outliers we have removed from it, then we have removed duplicates, then we have cleaned the data, filled the empty values, right? So this is the clean data. So what we are going to do is we are going to save this data. What we have to do for that, for df convert to CSV or whatever file you want to create of that. Okay, now as we want, first we wanted to read, means like load our CSV. So what we did, pd dot read CSV, right? So now what we have did here, df to CSV, means like it is going to convert to CSV in, and what, with what name it is going to save, it is going to save that file with the name of clean employee CSV, and what this index is equals to fall is doing. Okay, here you can see this ID is there, name and all things are there. This is known as index of it, and we don't want these indexes. Okay, so that is why index is equals to fall. If we would have kept index is equals to true, then it would have saved this indexes also, but we don't want that, so that is why we have kept this as false only. Just execute this, and then clean employee CSV named file will be created in the folder from which you have extracted this data set. Okay, like I have took that employees file in here also, so that is why it will show me. Okay, it was my folder in which you can see this cleaned employee CSV. This is the file which we have cleaned right now. Okay, so just like that, you are now a data cleaning ninja. Your data sets will fear you and your analysis will love you. So say no to messy data. But wait, I have a challenge for you. There is one assignment which you have to complete. Like it is your mission, but if you choose to accept it, then only. Okay. Yeah. So I'll quickly write here what is your assignment. So this is your assignment. What you have to do is you have to load any data set. You have to identify the missing values in that data set, and then duplicates also, outliers also. Then convert those into categorical data, means that categorical data into numeric data, and then whatever your approach is, you have to drop it in the comments. So if you like this video, hit that like button, subscribe, and wait for the next video. Until then, happy coding. Hello data lovers. Welcome to today's Pandas adventure. If you ever dealt with messy data and found it frustrating, then don't worry. You are in the right place today. So we are going to clean and organize data like pros using Pandas. Okay? So what are we going to learn today? We are going to learn about aggregation, like what we do with the aggregation, like summarizing the data. Okay? So next we are going to learn about sorting, that is arranging the data in orders like of ascending and descending. Next we are going to learn about group by. So how we are going to group our columns and organize and analyzing groups. So that we are going to learn in this group by. Then renaming columns, means like making columns names clearer or giving nicknames to our columns. And next we are going to learn about merging and joins, like combining multiple data sets together and working with them, and handling missing values. We have seen this in the previous video also, but still we are going to learn a bit about it. And working with Excel files also, like importing Excel file or exporting it. Okay, stay till the end for an assignment to test your skills. So if you are new to data cleaning, check out my previous video on Pandas basics before continuing. Okay, today we are diving into advanced techniques to level up your skills. So our first topic was going to be aggregation in Pandas, right? For that we need a file, so quickly create a new notebook and give a name to it. So first what we are going to do is we are going to create a markdown. For markdown, what you can do is we have 6 different types of headings. If you are familiar with HTML, then you know that there are, or any other language, there are headings. For headings we have 6 options. Okay, so what we are going to do is, this is there, space, this is markdown, sorry, I should write aggregation and just execute this. So you can see the heading is being written in bold words. So here if you add 2 hash symbols and then you will execute it, it will be a little bit smaller in size. Again if you'll add 1 and execute it, it is reducing the size, right? So till 6 we have these hash symbols. So let's keep it this much is okay, right? Okay, fine. So now this is code. Okay, here it is mentioned that this cell, it is code, and here if we come in this cell, it is markdown. So there is difference between markdown is not a code, and code is the place where we are going to execute our things. Okay, so now in code also to not execute anything, we are having comments, right? Yes. So now what is aggregation? Aggregation is simply the process of summarizing large data sets into meaningful insights. For example, if you have a data set of employees, okay, with their salaries, then you might want to find like the total salary of each department, then highest and lowest salaries. Also maybe you want to find average salary or the most common salary. So in that cases this aggregation helps us a lot. Okay, so in aggregation we have different kinds of functions. So what are aggregation functions? Like we have sum to add up all the values. I think I should write this in the markdown only. Okay. So in aggregation we have functions, and those functions are like we have sum function, we have min, max, median, mode, mean. These all functions are commonly used. So sum is to add up all the values. Min and max are to find smallest and largest values. Okay. Median is to find average. I'll mention it over here only, right? So okay, leave it. So we have min max for the largest and smallest values. We have mean to find average values, median to find the middle value, and mode which finds the most common value. Okay. So let's now learn these things with the example. So we were having a data set, right? So let's take that data set. For that we need the things from a previous file. Okay. So you can open that previous file and load the things over here, but so now what we are going to do is the file which we have cleaned last time, we are going to take that only. Okay. So let's just execute this and see what we have in our data. So last time we created the file, clean it, like we were having employees name, source, in salary, age, there were missing values, so we handled those duplicates, we handled, right? So those things we did in the last, and in the end we saved that clean file, right, in the CSV form. So I have took that CSV form or CSV file and again loaded it over here. Okay. So it means that we are continuing that file only, right? So these were the things which we were having. We changed the data types and we changed the column names also. These many columns were present. Here you can see that departments are also be segregated, right? City, unknown, and all things. We also encoded it, right? We needed a machine to understand the language, right? For that we did encoding. So now what we are going to do is we are going to we have loaded this file. Now let's take an example and then summing up salaries by department we are going to do. For this I'll make it as comment only. So I'll write it first and then I'll explain. Okay. So here what I have did, I have initialized a variable, salary summary named variable I have created. Then I have used this group by. What this group by is going to do, it is going to merge the things. Okay, it is going to make the group of the things. Now which of what it is going to make the group of department IT and then salary. So where is the salary? Yeah, this salary and this department IT, it is going to group those columns together. Okay, and then it is going to return the values. So this department IT, it is grouped, and salary, and then what is there in the values it has took. Okay, here it is true or false because we have encoded the data, that is why it is showing in this. Okay, if we could have took that uncleaned data which was previous, then some of the values were missing, we needed to clean it again, that is why I have took this data only. And if we would have not done encoding, then the values like names of the department and then those things would have been over here. Okay, In the aggregation, we were having sum, min, max, median, count, those all things also, right? So let's see about them if we have any. So we have imported Pandas library, we read the CSV file, we use group by to add up all the salaries for each department, right? So each IT department we have done this with the help of group by. The result, what the result is showing, total salary per department. So IT department total salary it is showing. Now next what we are going to do is we are going to find min and max salary per department. I am going to use IT department only for example, okay? It is also going to show true or false like that only, okay? We are going to print minimum and maximum salary according to department, right? So in IT department, minimum salary is this much and maximum salary is this much. It has identified the things according to and then showed us the output, okay? So I'll explain this code. What I have did, these are the variables in which I am going to store the things, right? Min salary, max salary. DF we know it is a data set, then group by is there. Why we are using group by? To join two columns, right? So and based on a condition. So your condition is given in this min function only and max function only, that is why there is no need for us to give the things, okay? So department ID department IT and the salary we have grouped them, and then based on that we have removed the maximum of it. Here also we have did, but here we have removed the maximum of it. Sorry, here minimum it was and here maximum it is. So this is just this print statement in which minimum salary means, like here you can see this minimum salary. If I would have removed this /n, it is going to take new line, okay? So this department IT, it is coming besides the minimum salary only, okay? If I would have removed this, then this department IT would be here, okay? So that is only the thing. /n is used to take here new line. So that is the thing. And then max salary also we have to pass that variable name in the print statement, okay? If we would have not took this min salary in the double quotes, then also it would have been okay, but it is to make a code a bit readable, okay? That is why I have took that. Now let's move to the next, that is mean, median and mode, okay? So what is mean, what is median, what is mode, we have understood it first only. I am directly going to find the values from the salary, okay? So mean, median and mode. For that quickly you have to take a variable, mean is equal data set, and of salary I am going to remove the mean, okay? And we have this mean function, we just have to write it, okay? If you will execute this, then also it close it, execute it. The mean value of the salary column, we can see this, okay? This same we are going to copy. I'll paste it over here. Here I'll just change the value to median and this function to median and pass the value also of median. So this is the median value, and then mode also quickly now remove it. So this is the mode value. Means these are the repeated values, okay, most common values in that data set. So So what mean is? Mean is the sum of all salaries divided by the number of employees. Median is the middle salary where all the salaries are sorted, and mode is the most common salary in the data set, right? So we have understood these things. So keep this sentence in mind, okay? Aggregation is like grouping pizza orders at a party. Like mean salary means average pizza price, median salary is the middle priced pizza, and the most salary means the most popular topping, okay? It is just for example, but we can understand the things bit clearly if we take such examples, okay? So now next our topic is going to be sorting the data. Let's take a markdown for it. If you press escape M, then also it is going to turn into markdown, okay? It is the shortcut for that. You can see up that we have created this as a markdown. For how many heading we took for the, okay, let's take 3 and sorting data. So sorting helps us arrange data in ordered, okay, just like ranking songs in a playlist. So what we can do is we can sort employees by salary in any of the order. Order means like ascending order or descending order. Whenever the concept of sorting comes, there ascending and descending, these two factors come only, okay? So what we are going to do is, oops, we should not take this tab also, then also values will be seen for you. Sort values, then by, oh, it should be by, okay. So in one single page, this page the table was not going to fit, that is it has took some of the columns down, okay? So this is a whole one table only, okay? Don't think it as different tables. Okay, so sorting data, how it is going to work. I have took this, I'll explain this code first. I have took this df.sorted, it is the variable name, okay? Then df, this is a data set, sort value is the function which we are going to use the sort a data. So sort values is there. We have sort indexes function also, okay? So depends that when we want to use which. So sort values we are going to take, then we have to mention by which column we want to sort the things. So by salary column name we have took over here. By salary, based on the salary it is going to sort the things. Ascending order we have took, which order do we want, we have to tell it over here, and then false or true. Okay, so now writing descending, then false, then changing the things, means right now it is in descending order only. You can see that the highest is at first one, then next to that, then next to that, right? That like that it has sorted the things. If you will just change over here as true and execute it, you can see the lowest salary is at the first place. So to sort the values in the descending, what we have to do is we have to take this ascending and give it the false, and if we want to sort the things in the ascending order, then we have to pass the value of true. So this is how we are going to sort the data. So sort values by salary, what it is doing, it sorts the salary from highest to lowest, and ascending is equals to false. What it does, it ensures that we get the highest salary at first, right? So imagine sorting out your friends by who replies fastest to text, right? Based on that, if we sort of friends, how easy it would be or how funny it would be. Okay. Next we are going to learn about group by. Now we have already used this group by, but still we will understand it into detail. The group by function allows us to analyze groups within the data. Now finding the average age per department. So let's do this. What we are going to do is we are going to find the age per department. So what this group by is going to do is it allows functions to analyze groups within data. So what I have done over here is I have took average age, means this is the variable name, in that I am going to store the things. So we have this group by function, we have seen it before also, but here what I have did is I have grouped department IT and age together, and from that I have counted mean of that, calculated mean of those two columns by combining these two columns. Okay, and then I have printed that average age. Okay, here what important is group by, and what group by does is it groups the columns, means with this purpose, with this notebook purpose, or with this data purpose, what it is going to do is it is going to group the two columns together, and based on that whatever our next function is going to be, it is going to act according to that. So what this have calculated all together, this what it has done is it calculates the average per age per department. Okay, next we are going to learn about renaming columns. So what happens, sometimes column names are long or unclear. So here we are having all the original column names whichever in our data sets are. Okay, so here ID is okay, but we can write over here, right? It is employee ID. Here name is also okay, age is also okay, salary, joining date. For joining date we can change the column name. For educational level if we want, we can change the city, New York City, San Francisco. These are not column names, right? City unknown and department HR. Why these are not column name while still it is taking? Okay, because it is in this data, this clean data, it is like this, that is why it has took the names. Okay, yeah. So now what we are going to do is we are going to rename some of the columns from this. df is our data set name. We have rename function, rename access is there, as well as only rename is also there. Then we are renaming columns, right? I have did in this renaming column, or how we have renamed the column. Here I have took df.columns. It is, we have seen what it does. It will print all the column names which are present in a data set or which are present in our file. Then what I have did is I have took this df.rename. Rename function is present with us, so I have took this function, and in that we have to mention whichever column, like what is the column name and to what we want to change that column name, like old name and the new name which we want to give to that column. So which columns do we need to change the name of? So that is why here I have given the old name, means like columns. I have to rename, what I have to rename, columns, and then join. This is the one column name, you can see it over here also. It's better if you copy this and then paste it over here. Okay, don't forget for this quotes. And then joining date, it is our old name, and we have to give the new name also. What I have renamed it, joining date to join date. Education level also I have changed that column's name also to education. In place is equals to true, means it is going to change the things into data set only. Okay, and the original file only. And df.head, we know that it is going to print the first 5 columns or rows, sorry, not columns, the first 5 rows of our data set or our file. So now merging is essential when we have multiple data sets that we need to combine based on a common key. So in Pandas we use merge function for this. There are 4 main types of merging options. Like we have inner merge. Inner merge, what it does, it keeps only the matching rows from both the data frames. Here we have now, as merging is the fact of 2 tables or 2 data sets. means we have two tables, data sets, whatever you can consider. Here the concept is joining. We are joining two different things. So for that we have this merge option. In that we have inner merge, left merge, right merge, outer merge. So what inner merge does, it keeps only the matching rows from both the data frames, only the and only matching rows. Left merge, what it does, it keeps all the rows from left data frame and matches from the right. The original ones are going to be left merge, within the left merge, okay, only the left side things are going to be kept, and based on that or matching to those whatever is there in the right side's data frame, it is going to be merged with this left merge or left whatever it is. In right merge, what happens, it is opposite to the left merge. What it does, it keeps all the rows from the right data frame and matches from the left. In outer merge, what happens, keeps all the rows from both the data frames, and if there is missing value, then it will fill it with the null or NaN. So let's take an example of data frame. Here we will need another data frame also, okay. So I'll quickly create that thing, and it is the most common one. And how we are going to use merge, when we are going to give this merge options, that also I'll show. But for that I'll need two different data frames, okay. So I'm creating that. Having two different data frames like df1 and df2. In that there are just IDs, name, score in the first data frame, and in the second data frame or data set or whatever you want to say, file, data, what it is ID, subject and marks, okay. So these are the values. This is a small data set I have took, okay, and this is just random, it is just for understanding an example. So how we are going to, so let's take a variable name. I'm taking this merge df equals to pd. In our pd we have the merge function. Take that merge function, and in that you have to mention which data frame you want to merge. So we have this two different data frames that we have created, right? So we are going to take that, and on which column or what basis you want to merge them. So on the basis of ID I am going to merge right now ID. And now the concept of merge, and now which type of merge we are going to give. The default one which is in this notebook or which is present over here, that is inner. What inner does, we have seen it over here, right? Inner is going to keep only the matching rows from both the data frames. So in ID, whichever ID is matching, only that it is going to print, okay. And even if we didn't give this merge type of merge, then also inner is the default one, okay. This 1 2 3 and here also 1 2 3, these three IDs were common, matching in both the data sets. So that is why only this data is being printed over here. Let's change the type, like if we give outer, what it is going to, we have to execute this first, then we are going to execute this. So what outer did, it took all the values, but whichever means wherever there is no value, it has printed nan, okay. So this is how we are going to merge the data. Here we used how inner, which means only the matching IDs from both the data frames are merged, okay. So as the default one is inner join or inner merge, the rest also you can experiment and try to understand what it shows, okay. So we have seen inner, left, right, outer. Outer will take all the things, right? Let's check that also. Execute it. Yes, here it is case sensitive. So now, okay, so you can see it has joined both the tables with the outer join. Outer has took all the records, and for the remaining or the empty values it has filled with none. So now what we are going to do is we will take an Excel file and open it simply just for our understanding, to that we can take different data files also. Like, okay, we have just took the CSV, we have converted that CSV into CSV again, means like cleaned it and then again saved it in our system. But now what if we have different kinds of files? So we can take that also. We simply need pandas for that, and as we have imported pandas, so there is no need to again import panda. So what you can do is data pd.read, same way as we have did it for the CSV file. So pd.read read underscore CSV it was, right? So here read underscore Excel, the means like whichever file's name you want to take, you can take it. So this also we have the function. So it was just a simple file, okay. In that there were different folders also. So you can take however you want, you just have to take the slash sign which will separate the folders, okay, and then wherever the location of that Excel file is, that you can take it. And same, if we will work on that, if we will clean that file, and same we have to again save it. After cleaning, we want to save it in our system. Then what we are going to do is we are going to convert to CSV or to Excel, like whichever form we want to convert, that we can convert it. So this is how we can take any kind of file whichever we want, and then we can work with it. There is a task for you all if you all want to complete it, okay. So okay, so what we have covered in this video is that we have covered aggregation, what are the aggregation functions, then we have took the libraries, we know this thing, right? We again took that CSV file which we have cleaned in the previous video, then we saw the things like whatever are present in that file. Next, what we did is we understood the this grouping the things together, means like summing up salaries, these things we have did. Next, we find out, like we were working with those functions, like somehow we are going to use min max is there, aggregation functions we understood, mean median mode, what are those things we understood that. Then we learned about sorting the data, how we are going to sort our data. We learned about group by in detail, then how we are going to rename our columns. For that, what we should do, we should first print our column names so that we can understand what are the exact words of those columns, right? Or alphabets properly we can understand, because Python is case sensitive language, okay. So we have to be clear, like whatever we are naming the things. So renaming columns we finished. Then we learnt about merging, like how we are going to connect two different data frames or data sets, like whatever is present with us. Then what kind of things are present to connect those data, to merge those data frame, whatever things we are having, like we have inner merge, we have left merge, we have right merge, we have outer merge also. Then we saw that examples also. Then how to take an Excel file, means if data is present in any different kind of file, we can take it in the same way, like how we were taking Excel, we were taking CSV. So in that cases like that. Then it is the assignment for you all. You have to complete this assignment, and whatever queries or whatever your opinions are there, you can tell me in the comments. And that's a wrap. Today, we mastered data cleaning techniques like aggregation, sorting, group by, renaming, and more, right? So like and subscribe for more amazing content. If you got questions, drop them in the comments. See you in the next video. Until then, happy coding. Hey data detectives, welcome back to the channel where boring spreadsheets come to life. Ever stared at rows and columns thinking, is this a data report or a secret code from Matrix? Well, you are not alone, and today's video is going to change that all. We are diving into the magical world of data visualization using our trusty employee dataset. Think of it like turning numbers into pictures, but cooler and way more insightful. We'll start from the ground up, that is univariate, bivariate and multivariate visualizations, all explained in a super fun and simple way. So grab your chai or whatever fuels your data brain, and let's turn those plain numbers into something spectacular. So alright, let's get into the heart of it. What is data visualization? And why is it such a big deal in the world of data science? So we'll think of data as a treasure chest, full of insights, patterns, and stories. But there's one problem, it's locked. Data visualization is the key that opens it. It's the art, science of turning raw data into meaningful visualizations, like charts, graphs, and plots that help us to see what's going on instead of reading 10 pages of numbers. You get the story in one single glance. So, in data science, we deal with a huge amount of data. And trust me, no one has time to stare at 1,000 rows in Excel. So, here's why data visualization is non negotiable. So, to understand the data, it helps us spot trends, patterns, and outliers quickly. Next is to communicate clearly. Whether you are explaining your findings to a client, your boss, or your YouTube fam, visuals speak louder than numbers. And to make better decisions also. Visuals helps decision makers take action fast based on the real insights. It's like this. If data is the ingredient, then visualization is the recipe that turns it into something more delicious. Now, in this video, we are going to master the three major types of visualization. Univariate visualization. This is when we explore just one variable. How many employees are from each department? We'll use bar charts, histogram, pie charts, and more. So let's get started. But before getting started, we need to load our libraries, to load the data set, and one thing is there that we have to we have to create one different column from an existing column. So let's see how we are going to do that. I'll start by importing the libraries and dataset, okay? Okay, so here I have imported our libraries, like we need Pandas for this, and as we are going to work with the visualization, so we need Matplotlib for it. I have used allies for each and every library, like PD is there, PLT is there, SNS is there, okay? From Seaborn, we are going to get visualizations like we have histplot and boxplot and all those things. Those we can take from Seaborn library. From MPL toolkits, we have this mplot 3D. From that, we have imported Access 3D. Access 3D, why we are going to need this? Because we are going to make one visualizations that is 3-dimensional. So that is why we have imported this. Then I have my dataset, employee dataset is there, employee information file is there, okay? From read CSV, I have given this path to that, means like in my system, this is the location where that file was present. So I have took that, and to view what is there in our data, what I have did is printed first 3 rows of my data, okay? So what we have in this data, we have the first name of the employees, we have the last name of the employees, we have their gender, DOJ means date of joining. In that we can see that we are having a null value, okay? So current date is there, at what time this data set was created, that's current date this is, okay? Designation is there. In designation we have the role of this employee, like analyst is there, associate is there, right? Okay, in age we are also having one null value, and age is in the decimal, like float points, right? So that is not a correct data type, so you have to change the data type also. You're going to do it by yourself, because in the previous videos we have seen how we are going to change a data type. Next, we have salary of those employees, okay? We have unit. In unit, it is department. Like in finance department, that person belongs. In web department, that person is belonging. So like different kinds of unit. If you are okay with this unit, you can keep the column name as unit only. Or if you are familiar with, you can understand things clearly by department, you can change that unit to the department, okay? Next, we have leaves used and leaves remaining of those employees. Ratings are there, and the past experience of those employees, okay? So this is the information we have with us of those employees. Next, what I have did is df.info. With this info, I am going to get detailed information. Like here only we can see the first 3 rows, right? But now I want the detailed information. Like detailed information means what we have used from Pandas. We have used data frame, okay? Data frame, we can see that our data is printed in the data frame only, okay? Then there are in total 2639 entries, and it has been indexed from 0 to 2638. We can understand this thing, right? Means total we have this 2639 rows, but how are they indexed from 0 to 38? This 38. Why one less? Because we have started it from 0, okay? That is why. Then date columns are there, means like columns are there are total 13 columns present with us, like this first name, last name, this. If you want to calculate, you can calculate that. Then these are the column names that we have. They have been indexed from 0, that is until 12, okay? Now why, don't ask me that why they are 13, because it is only showing 12. We have started from 0, okay? Then first name, last name, in that you can see that how many not null values are there, count, and d type means data type, okay? Now you are familiar with these things. What we have, how many types of float data types do we have, means in columns, how many types of float data type is present. There are 4 such columns in which we have float kind of data. How many types of integer columns are there? We have 2, and object 7. Object means that is not defined, okay? The data type is not defined properly. How much memory is being used, that is also shown over here. Now what I'm going to do is I'm going to quickly create one new column. I want the column of year. From date of joining, I'm going to create one new column in which only year will be present, okay? From that only dates, I'm going to just extract year and keep it into new column, okay? So here what I have did is I have took that date of joining, that column is there. We are having this. You can also see this is the column we have with us. In a data set, we have this DOJ I have took. From Pandas, I have this to date time. Means first I have to convert its data type, okay? I have to tell that it is the date time column present. It means information present in that column, okay? So I have converted it first to df.doj, means that I have converted to the date time data type, okay? And from that date time I am telling that I create a new column, that is this doj year. This new column create it, and in that from this date time from this doj just extract year, okay? Just extract year and keep it in this column. So that is why it has created. Now again, if you will see, okay, we'll execute this, and if we will columns, so here you can see that we have this doj year also. If you want to see again df.info, you can print again, and here you can see we have this 13 columns present, means in total we have 14 now, okay? And here if you will see this doj, it is also being converted to date time, okay? And this doj year, it is float. So within this 2 lines only, what we have did, we have converted the data type as well as we have created the new column, and in which we have stored the year. These things now we require. Now you are saying, you must be thinking that within this we are having null values, we might have duplicates also, okay? But what is the thing over here is we are going to clean this data alongside visualization only. Okay, we are going to create visualizations also, and in that only alongside, side by side, we are going to work with the cleaning part also. You will see how. So now let's start with our univariate visualization. We have did all the requirement things which we wanted, okay? We have understood our data. Now let's start creating it. So now we are going to plot the histogram. But first, what is a histogram and why we are using it here? So a histogram is a type of bar chart that shows the distribution of a single numerical variable. It tells us how different values occur in a data set. So in this case, the ages of the employees we are going to take. Okay, to see any of the duplicates, we are going to use this histogram in simple words, if we'll say. You can think of it like sorting people into age buckets and counting how many fall into each one. Okay. It's super helpful to see where most of your data is grouped. So now why are we using it over here? Because before we start doing any fancy analysis, we need to understand how our data is spread out. Are employees mostly young, mid-career, older, or are there any outliers? So a histogram gives us a clear picture of that distribution in just one glance. Okay, so now what I have did is from Seaborn library I have took this hist plot. Okay, hist plot means histogram. I want for short name for histogram is hist in Seaborn library. Okay, so hist plot I have took. In that we are going to work with the age. Okay, so age I have took, and as I told that cleaning part also we are going to do side by side with the visualization only. So I have took this drop null. Drop null means in the age column if there are any of the empty values, it is going to drop here itself only. KDE we know it is kernel density estimation. Okay, it is true, means we are going to see a one smooth curve line in our visualization. Okay, and color is going to be sky blue. If you want to change color or if you want to take any other color, you can take it. Okay, then plt.title from Matplotlib, there is one title name function. Okay, you can understand it like there is one man with the plt, he is known as title. So what is his thing is there, whatever the title we are going to tell him that see distribution of employee age, this I want to pass this title to my visualization. So what he is going to do is he is going to take that title and he is going to give that title to that visualization. Okay, then x label is there. Okay, x label means as we are plotting, so we are going to have x axis, y axis also. So to that x axis we are telling that this age column you will take the responsibility of this age column, means like whatever is there you are going to show it. Okay, this age you are going to print it on that x axis, and y label is going to print frequency. Plt.show, what it is going to do is it is for all these things, that title, x label, y label and all these things, it is going to show the final output by combining all those things. Okay, so let's execute this. Here is our distribution of employee age. This title, it has been printed over it. This frequency, x label, y label, all those things are there. In x label we passed age. This KD means our kernel density estimation. This line curve is there. By looking at this curve also, like where it is peaked and where it is low, we can understand by that also. Okay, means like we can see that 25th age of persons are most, okay, they are higher in that organization, like that we can see over here. And with that, by looking at this chart only, we can understand the things. Plt.show, what it has done, it has made this visualization that we can observe now. Okay, color sky blue is there. You can see the color of the bars. If you will not pass this color, then also it is okay. It is also going to execute still. Then also copy this and then delete it for a time and then execute. You can see the color is still there. Okay, means I think default color is also there. This is the default color only. Let's think that if I'll execute, I think blue color should have come. Okay, default color is also I think blue only. That is why if you change this color to pink, now let's see. Oops, we have passed this 2 times. Okay, see, you can see the color is being changed. So that is only the thing that this color is doing. Okay, default color, if we didn't pass, then it is blue. So whatever color you want, you can give it. Okay, so this is a visualization we have created. This is a histogram. Okay, you can understand by looking at it only what are the things. So now what this plot is telling us, we can instantly see which age ranges are most common among employees, and it is also telling us that if the ages are evenly spread or clustered around a specific range, right? Combined with the KDE curve, it gives us a clear story of our employee age distribution. That is also the thing, right? So if you want to take any of the real world example, so let's see what we can take. Okay, if you were working in HR or planning training programs, okay, this chart would help you tailor initiative based on employee ages group, right? So now let's focus on our next visualization, that is going to be box plot. So why are we going to use box plot over here? A box plot, also known as box and whisker plot, is a fantastic tool for summarizing how your data is spread out and spotting any outliers. It shows 5 key summary points. Those are minimum, first quartile, medium, third quartile, maximum. And if any data points are way higher or lower than the rest, they are shown up as outliers. So why are we using this box plot over here? Because we are analyzing employee salary, and let's be honest, salaries can vary a lot. Some might earn average pay while a few might be making way more. And if we want to see that clearly, then let's understand this box plot. So now let's check this code, okay? So here from Seaborn we have took the box plot, okay? In that Seaborn, it is box plots requirements are like it have y-axis, okay? One of the axis we have to pass the value for that. Now as we are checking the salary, so that is why from our data set we have passed that salary column. Color we have given light green, okay? Whichever color you want you can give, okay? Now you have seen how we are going to use this color. Then title, y label and show, those things are familiar with us, right? So simple, we have took this, we have passed a column, okay? Here we have did nothing cleaning is there, that in the salary is required, okay? Now if there are any salaries that is way more higher, then we are going to check in this outliers only, right? So right now we are not going to remove any of those things, okay? When we will see in this box plot, then you will understand the thing. So here this is the box plot, okay? Let's understand this a bit. Now in the y-axis we have passed the salaries, okay? We have given this name, salary distribution is there, and this is our box plot. Now here we have this for this minimum, first quartile, medium, third quartile and maximum, right? These things are present. So this, whatever is lying between this line and this is okay, that is fine, okay? Right now we cannot zoom this figure, that is why I'm not able to show it in detail, but now I'll tell you, anything that is lying from this line, means like this middle line you can see over here, from that middle line to this, means like this small line, anything lying between that is known as first quartile. This middle line is known as median, okay? And this line is known as third quartile, okay? Means 75% of the data. So this is the thing that this interquartile range and all those things have been showing, okay? So box plot is good for this, and anything that is lying outside this line you can see over here, anything lying that is outside this line are being considered as outliers, okay? But it is not the case that all the time they are outliers only. There might be the cases like we cannot judge a book by its cover, right? So what happens is, if anything that is out of the range, means in given criteria, if then anything that is out of the range, we are telling that okay, this is not a required thing. The outside things are not the required things, or they are outliers, like that we will consider. But not most of the time they are outliers only. There might be some of the factors that within that they are not fitting. Everything at its place is good, okay? So we cannot consider everyone as outlier only. So now this gives us an overview of the entire salary distribution, right? And we might see, so those dots, those are whiskers, okay? They are also being flagged as outliers, but it is not all the time that they are outliers only. When we group the salaries by department or unit, those so-called outliers might actually be normal salaries within that group. It's like calling a manager's salary an outlier just because we didn't compare it with other managers, right? Okay, so what do? Simple. We break it down with subplots. Now I'll create subplots and I'll show, then I'll explain it, okay? So you can see where I have written this code, and then we are by each department unit, okay? Department thing was in a unit, right? Unit column was there. So by each unit I have separated everyone's salary. So in there may be experience, so we can take the experience column also. But here, as we are learning with the univariate thing, but now as we have passed two different columns, so this is not univariate now, it is multivariate, okay? But for understanding this is important. So this units and num units, what we have done here, we first grab all the unique values from the unit, okay, which tells us all the departments or teams. We also calculate how many units we have, because we'll need this to decide how many subplots to create. Then next what we did is fig axis, this axis, right? These things we did. So now what these are, I'll explain this. We use plt.subplots to create grid of plots. We are arranging the plots in 3 columns and the number of rows is calculated to fit all the units. The +2 ensures that there is room even if the numbers isn't a perfect multiple of 3. We then flatten the axis into a one-dimensional list so we can loop through it easily. For next this, for I in unit, like these all things, now that I'll explain, okay. We now loop over each unit. Inside the loop, we filter the data frame to only include rows from that specific unit. Then we use sns.boxplot to plot the salaries of that unit, and then each subplot gets a custom title like salary in sales or salary in IT, and then we label the y-axis as salary for clarity. Then what we have did is, sometimes we create more subplots slots than needed. Like if we had a need of 7 units but made a grid for 9. This loop deletes those extra empty plots to keep the final figure clean and professional. And what's this tight layout? This prevents the plots from overlapping each other. It adds nice padding between subplots. Finally, plt.show, we know now what this does. Okay, it displays the 4 beautiful dashboards of salary box plots by unit. So why we did this? By plotting the individual box plots per unit, we were adding context to the salary data. What looks like an outliers in the overall salary box plot and may actually be normal within that unit, right? So that is why we did this. So this is a perfect example of how multivariate visualization tells us a deeper story. So let's say you have an employee data set and you want to find out which unit or department has the most employees. That's where Seaborn's count plot comes in. So now let's learn about this count plot. So now let's understand this count plot. Okay, from Seaborn library we have took this count plot. Here we have x, so we have passed the unit to that x. Then we have created one variable named data, and in that we have stored a df. Okay, df means a data only. Then palette is there. Palette why we have took, because this color you can see. If we remove this palette, what is going to happen? Let's see. See, the default color is given to all of the things. So that is why to make it clear, to make it visually look appealing, that is why we have took this palette. Okay, but whenever we are using palette, we need a hue with it. Hue is what, when we want to pass any third column to it, then we are going to use this hue. Then next what is there? Title is there. Title what we have given number of employees in each unit. Xticks is there. Xticks and rotation 45 we have added. Okay, here you can see that this finance, web, IT, they are slightly bent. Means like 45 degree they have been bent. Okay, if we make it as 90, we have learned in a school also, right? Then it will look as, oops, close, executed. You can see now they are fully bent. So that is only the thing that is x6 is doing, and then plt.show we know. Here also what is the error it is telling us, that count plot x unit data and palette is equals to this, whatever it is. So palette we have assigned, but we have not assigned hue to it. That is why it is telling us that we cannot use palette, but palette should be used with hue only. That is the thing it is telling us. Okay, and here is a plot. This shows us how many employees are in each unit. You can instantly see which departments have the most or least number of employees. You have no need to scroll to the rows and rows of the data, right? Count plots are amazing for visualizing categorical variables. They help us to see patterns at a glance, which is super helpful in EDA. Now let's start with the bivariate visualizations. Okay, so here's our data set. It includes employees' details like their age and salary, right? Which is perfect for a scatter plot. So let's go plot the scatter plot and then I'll explain it. So here we have plotted a scatter plot. Simple things are there, like scatter plot is there in Seaborn library. Okay, we have took that, we have passed age to it, we have passed salary to it. Okay, now two different columns we have passed. That is only thing in the spivariate visualization. Data we have, df means our data is stored in data variable. Okay, and color we have passed, that is red color. Okay, you can pass any other color whichever you want. plt.title, x label, y label, those things are okay. But new thing what is here, that is grid. Okay, grid we have passed true. Let's see if we make it false, then what it is going to happen. If we make grid false, then you can see that those lines were there, boxes were there, those are being removed. That is only the thing that this grid is. Okay, now let's make this. So with these grids we can understand our data more clearly. That is why we can understand the actual points that within which range which those dots are being lying, that we can understand. Each dot on this plot represents one employee. The horizontal position shows their age and the vertical position shows their salary. Okay, now let's analyze this. Wherever there is dense area, just focus on that. Okay, if the dots are moving upward as age increases, that means that older employees tends to earn more. But if the dots are scattered all over with no clear pattern, there might not be a strong relationship between age and salary. If you want to take any of the real life example to understand this, then let's say that you are working in a company and you notice that most freshers in their 20s earn around 25 to 35k. But people in their 40s or 50s might be earning 70 or even a lakh, right? A scatter plot will help you to visualize this trend. But here's a twist. Sometimes young techies with niche skills earn high salaries too. That's why scatter plots are greater for revealing exceptions and outliers. Now let's imagine we are working with a company employees data and we want to check if their salary is difference between male and female employees. Instead of reading rows and rows of numbers, we can visualize it using box plot. But now we are again plotting box plot. Okay, but we are using with bivariate visualizations, and there is going to be a twist also. So just wait for that. So here you can see that again I have used palette. Okay, so that is why it is telling me that you should use hue. That is only this error is telling. Okay, this red highlighted thing is telling. Rather than that, you can just focus on here. Box plot, we know from C-bound we have to box plot. Here we have passed two different variables. Okay, and data is there. Now let's use hue also here. Hue. Okay, now you can see this thing. From we have passed x, y, and this hue we have given. How to give this hue? In that we can pass any third variable which we want. Third column I have passed which I want to view. Okay, based on that I want to view this. That is why data palette. Now you are familiar with this. Title also you are familiar, and this also familiar. Now we know how to read this box plot also. Female, this is there. Male counts are different. Female and male by gender we have segregated the things. Their salaries we have segregated. Okay, there are many outliers present, but they actually they might not be outliers. Okay, finance is being defined by green color, web is being defined by orange color. So that is only this hue thing present over here. If you are familiar with Power BI, then you can if you know the tooltips, then you can understand the things. So this is a simple box plot. For right now I'm not going to use this hue because I want to explain the things in this way only. Okay, the box shows the middle 50% of the data from the 25th percentile to the 75th percentile. Okay, these box these things, these known as, these are showing the 25th and 50th and 75th percent of the data. Okay, the line inside the box is the median, the middle salary of those employees. Okay, the male, this middle salary, this line is known as middle salary. Okay, that is the median. The whiskers extends to show the range of the data except outliers. Okay, these are known as whiskers and they are showing us the extent, range, and those little dot outside the whiskers, those are outliers, usually high or low salaries. The whiskers extends to show the range of the data except outliers. This area is known as whiskers. Okay, with anything that is lying in this range, that is known as that is okay, those are not outliers, and anything that is lying outside to that is known as outliers. By comparing the two boxes side by side, you can immediately spot the differences. Is the median salary for males higher than for females? Now answer these questions, okay, in comments. Is one group salary range wider, or are there any more outliers in one gender? So you can tell me these things in the comments. If you want to take any of the real life example, then what we can take is, for example, if the female box is lower and tighter, it might mean most female employees earn similar, possibly lower salaries. And if the male box is higher and has more outliers, it might show higher variation, possibly more people in the high paying roles. Okay. So of course, just seeing a difference doesn't automatically mean discrimination, but it's a starting point for deeper analysis. So now why these box plots are powerful? Box plots are super powerful because they tell a whole story in just one glance. What's the typical value, how spread out a data is, and there are any extreme cases. So like those things, box plots help us. Now I'll ask you a question, okay? How have salaries changed for employees who joined in different years? To answer that, we can use a line plot. So here is a line plot. From C1 we have took line plot, okay? We have assigned, now as we are time over trend is we are going to show in this. That is why for that cases mostly line chart is only used, okay? So line plot we took, for in that line plot it is having x axis, y axis, okay? We can pass hue also because we have passed a color. So those things are there, okay? Data is equals to dir ci. What new thing over here is the ci is none, that I'll tell, okay? Color, purple, title, x label, y label is there, and then show is there, and here is our line plot, okay? So what is there in our we created this new column, right? Year of joining. So in 2013, in 2014, like that it is showing that in these years not most employees have been hired, like that. And their salary ranges, okay? So like that, these things are present over here. The CIN, what it does is, we are telling Seaborn not to draw confidence intervals, to keep the plot clean and focused. Okay, if we remove this CIN, now this is the single line, okay? We don't want confidence intervals here itself. So that will not show our data more clearly. So that is why just copy this and then remove this, because we are going to add it again, okay? Now see what this confidence intervals are. So we don't want, it is actually be not giving us a proper fixed that exact number which we want, right? So that is why we did that CIN. We want the clear picture, so that is why we just made this line. This plot shows the average salary for employees who joined in each year. The line connects those average salary values across the years, giving us a clear view of trends over time. Now, if you notice a sharp increase around 2018, so if you want to take any of the real world example of line plot, what we can do is, there are HR analytics, business strategy, financial forecasting, even marketing performance tracking is also there, okay? In these cases, this visualization can be used. Now let's move on to the next visualization thing, that is multivariate visualization. Now, as the name itself is only telling us that what this multivariate visualization is. First, in univariate visualization, what we were doing is we were just passing one column, okay? And in bivariate visualization, we were passing two columns, okay? Two columns, two variables, whatever you can think. By two things, we are comparing in one chart, okay? Now here in this multivariate visualization, we are going to take multiple factors, and based on that multiple factors, we are going to compare the things, okay? Now here, by looking at this example, you can see that selected calls. I have created one variable, and in that I have passed multiple factors. Multiple factors means multiple columns over here, okay? Age, salary, past experience, and ratings I have passed, okay? From that, then I have took this pair plot. Pair plot, what it is going to do, by the name on itself only, we are going to understand that it is pairing some of the things, okay? So this pair plot we have took, and we have passed the selected columns, means these 4 columns in that pair plot, okay? Then we are going to drop any null values within these columns if any of them are present, okay? And then we have what we want, diagonal kind of KDE. KDE means we know, and corners true, that I'll tell, okay? Subplots, like there are going to be different numbers of plots, okay? So you can see this, there are many plots over here, okay? So this subtitle is there, means subtitle means to each plot individual name we want to give. So that is why, okay? So what it is going to be subtitle of that is age, salary, and all those things is there, okay? This y 1.02, I'll tell that, and this show. Now hold on, let me explain this down before your brain yells 404, understanding not found. So the selected calls I've took because we picked the cool kids from the data frame. Okay, means like age, salary, these are our cool kids. Okay. Drop null, it is going to, because nobody wants empty values, right? So we are going to drop any of the empty values present in this. Diagonal kind of KD means smooth curve on the diagonal instead of boring histograms. You can see these curves here. Then corner is equals to true means because we don't want to be too repetitive, right? One triangle is enough. So that is why we have took this corner is equals to true. And let's say your scatter plot says as age increases, so does salary. That's right. Experience does pay off unless you are an influencer. So my dear data ninjas, the pair plot is your best buddy when you want to check relationships between multiple variables fast. You want to spot trends, clusters or outliers. You are building a machine learning model and need to see what's related. So in those cases, this plot is very useful to us. You can see. Yes, we are turning the heat up and throwing in some color drama too. Now let's start with the heat map. Okay, I'll quickly write the thing and then I'll explain. Why this heat map we have took? Because every data set has secrets. And this plot, it's basically the neighborhood gossip auntie. It tells you who's close to who. Now alright, line by line, what is happening over here? Let's start. Okay. Before here, we have created the selected calls. Okay. Now here what we are going to do is we are going to use that thing only over here. So ds selected calls dot core means that is this thing. Okay. I'll tell this. This calculates correlation coefficients for all numeric features. And not true, what it is doing is because we want the juicy details, not just colors. That is why. CMAP, cool warm, fancy way to say blue means chill, means like negative, red means things are heating up, positive. Okay. Line width is equals to 0.5, that is separates cell with some neat, clean grid lines. Classy stuff, right? So here now as we are learning this correlation thing, in the previous videos we have understood that what is correlation. Okay, in correlation we have ranges from like 0, -1 to -1, 0 and 1. This is the range of correlation. Okay, so correlation values goes from -1 to +1, right? So +1 means best friends forever, -1 means they are sworn enemies, and 0 means like they don't even know that each other exist. Now let's say you see age and salary equals to 0.82. Okay, so it is strong positive, and if salary and ratings are like -0.3, then someone's getting paid but still gets roasted in the reviews. Now let's understand 3D plot. Okay, now normally we do 2D scatter plots, but with the 3 numeric variables, how do you show all of them together without making it look like spaghetti? Simple. We take it to the 3rd dimension, and don't worry, you don't need 3D glasses for this one. So now I'll explain this code. Okay, figure plt.figure fixed size 8.6. Okay, first line, we are creating the canvas of destiny, big enough to fit our 3D masterpiece. Okay, it's like whatever the area is required, we have mentioned that. We have mentioned the size for our plot. Okay, 8/6, that is thing. Then AX second line, what it is? This line tells us Matplotlib. Yo, we need that 3D sauce. The second line, it is telling that Matplotlib that we need the 3D plot from your XYZ. What these are? We are assigning age to X, experience to Y and salary to Z. Basically building the XYZ Avenger squad. And then scatter and all those things. The purple dots are where your data lives. Each dot equals to one person's story. And why we have choose purple? Because it represents royalty. Okay. Alpha 0.4, 0.6, whatever we can take. Okay. Transparency. This is because data should be open and honest, and rest of the things you are now familiar with. Okay, so this blue color, purple, and one circle is representing one person's information. Okay, we have known all those things, and this thing is there all over. Salary is there, past experience is there, age is there. Okay, let's increase this alpha size, and you can see. Okay, I'll make that 0.6. You can see the circles are being a bit dense. Okay, so when they were 4, it was a bit good. I'll keep this only. It is not looking that good, but okay, you can understand, right? The good part over here is like whenever you want to now, okay, you want to make a presentation of this. Now you want to keep this figure into one PPT. What you can do is you can just drag this and then drop it over there. That is also a thing you can do. And then rest of the detailed description you can write side by side to it, right? This is also the thing that we are going to do. So making presentation also, it helps us. So ta-da! There is a galaxy of data points. Look how salary changes with age and experience. You can rotate this baby and view it from different angles like you are inspecting a diamond. See those clusters? They might show you where the experienced people are earning more, or maybe some young prodigies make it big. So why we use this 3D scatter plots? They are perfect for exploring relationship between three variables, great for finding clusters, outliers, or patterns that 2D plots just can't catch. And honestly, they just look awesome. Want to make it even cooler? You can add color coding based on the fourth variable like education level, department, or hair color if you are into that. So that's your quick dive into the world of 3D scatter plots. And boom, there you have it all. A full roller coaster ride through the land of univariate, bivariate, and multivariate visualizations. Remember, data isn't just about throwing spaghetti on a chart and calling it insight. It's about telling stories, spying patterns like Sherlock Holmes. Drop a comment below and tell me which chart you liked the most and which one made your brain go confused. And bonus points if you give your favorite chart a superhero name. Smash that like button just like it's spilled coffee on your laptop. Subscribe and hit that bell like you are waking your data from a nap. Because more awesome data content is coming your way with fewer boring lectures and more. Wait, did I just laugh at scatterplot? Until next time, keep plotting, keep questioning, and keep dancing with your data. I am Daivishri, your data DJ, signing off. Hello friends, welcome to the magical world of machine learning. Don't worry, it's not actual magic, though it sometimes feels like it. In simple terms, machine learning is when computers learn from data without being explicitly programmed. Or, in human terms, it's like teaching your pet dog to fetch the newspaper without ever saying a word, but using lots of treats, or in ML's case, data. So if you are into AI, automation, or just want to sound super smart at parties, ML is your jam. Today, we are covering ML basics, types, examples, and deep diving into something many people fear, that is statistical modeling. So let's get started. So let's talk about the three main types of machine learning. That is supervised learning, unsupervised learning, and reinforcement learning. So let's understand supervised learning. Now imagine you are studying for an exam with an answer key. You learn from the labeled data, like teacher showing you the right answers. Means in this supervised learning, we have the things prepared for us. We just have to revise those things. We just have to understand those things. So that is why the labeled data here means the things which are already labeled or which are already in the categorized, sorted. So like that, some of the data is present over here. And based on that, that model is going to be trained. So that is why here we have labeled data in supervised learning. Like if we think of example, think of email spam filters. The model learns to recognize spam by looking at emails that have already been labeled as spam or not spam. Algorithms mostly used over here are like linear regression, decision tree, KNN, basically the usual suspects in the world of learning. These algorithms are used. Now, what these algorithms are, how we are going to use these algorithms, and where these algorithms are being categorized, means they are also being categorized into some of the divisions. So, we are going to understand those things also. Okay. So, for right now, just understand that if we are going to go with the supervised learning, or we have some of the labeled data, then we are going to use these kinds of algorithms to build our models. So what are the algorithms? That are linear regression, decision trees, KNN, basically. Okay. Now let's come to the unsupervised learning. Now, as by the name only we can understand that in the supervised learning we have some of the labeled data, but here there is no labeled data. Okay, the model is given data without labeled. Okay, now imagine you are thrown into a mystery novel with no clues, no answers, no help, just a big puzzle to solve. How will you feel, right? You are not having any clue, you are not having any answer, no connection with anything. So that will be the difficult task, right? But once you learn it, you will understand those things too properly, right? For example, okay, ever wondered how Netflix knows what you like? It's using unsupervised learning for things like customer segmentation or market basket analysis. Now, what this market basket analysis is, that is also I'll explain, okay? In this unsupervised learning, the algorithms which we used mostly are k-means, hierarchical clustering, no labels, just data trying to make sense of itself. Okay, I'll quickly tell you what this market basket analysis. Okay, now as we have took this in our example, market basket analysis means what happens. Okay, if you are going for shopping, okay, let's consider you are going for Star Bazaar, DMart, wherever you want. Okay, there, have you ever observed that how the things are kept? If we are buying any of the phone, okay, let's consider we have bought a phone, then related to it, like headphones will be shown, chargers and any other covers like that, right? Which means these things are connected to that thing which we are buying. So that is known as market basket analysis. Okay, nice marketing strategy, right? Now let's move to the reinforcement learning. Okay, this one's like training a toddler. You give them a toy, they play with it, sometimes messes up, and either gets rewarded or scolded, hopefully with love though. Example, if we take of it, then think of self-driving cars or those cheeky bots in the video games that learns from every oops moment. Here we don't have any like trainer or labeled data, unlabeled data. Okay, here what we have to do, here we just have a vision, we have to follow that. If we are doing correct, like as we were thinking of it as toddler, right? So parents will give us reward or we will be get scoldings. So like that, if we are getting scoldings, we are not going to do that. If we are getting rewards, we will move with that only. So like that, machine learns by itself only, by working out. So here the algorithms used are like Q learning, deep Q networks. It's the toddler learning through trial and error. Okay. So what's your ML personality? Are you a label lover, a lone explorer, or a reward chaser? Let me know in the comments. Now let's understand some real life examples of machine learning. Okay. So let's play this quickly a game. Okay. You have to guess who's using machine learning in this. So Netflix recommending that new series you just can't stop watching. Yep, ML in action. So next, Google Maps yelling, take a U-turn. What it would be? Of course, that's ML2. Your credit card sending out a fraud alert. Yes, you guessed it right, ML. Your phone unlocking with just your face. Magic? Nah. ML at work. So if something smart is happening on your device, machine learning is probably the one behind the curtain pulling the strings. Like we have seen those puppet shows, right? Those puppets have been dancing, doing whatever their magics are, but it's not the actual magic. The one who is handling their strings is behind it. So here also machine learning is behind this, and it is pulling the strings, and then these things are working. So now let's understand how ML workflow is. I'll understand this by a minute chart. Okay, so here is that. So let's get behind the scenes and see how machine learning actually works. Think of it like baking a cake, okay, but with Python instead of eggs. So here's the process. Our first step will be, or we can say that machine learning's first step will be problem definition. Of course, it is the beginning step, and everyone, whenever we are doing any of the thing, we should understand what is a motto behind it, what is the thing we have to achieve when it, right? So here first is problem definition. Here we have to understand what's the goal. Predict prices, detect cats, save the world, whatever it is. We start with a clear question. Always questions are not bad, okay? We should ask questions. So if you have any questions, you can also ask me in the comments. Okay, next step is data collection and cleaning. Now, as machine learning works when it is being given some of the data. So data is we need data. So data collection and cleaning it are the important steps, and this also takes most of the time. Okay, data collection, cleaning the data, exploratory data analysis, these things takes a lot of time. Okay, so collect your data and then clean it up. Think of this as making sure there's no flour spilled before you start baking. Now, as we are considering this as baking, so I'm telling the things with that explanation only, with that example only. Okay, so keep in the mind, just think like how is the workflow going. Okay, first, now as we know, we have to first is problem definition. So here we understood that we have to make a cake, right? Next is we should see that our place where we are going to make the cake is clean, the flour spilled or any other thing that is not needed are kept on the kitchen, like that. Next is exploratory data analysis, EDA. Now, you play detective. You look at your data for hidden patterns, outliers, and maybe a few plot twists like in the serials. No, not like that. So we have to understand our data in exploratory data analysis. We have to, when we know our problem definition, so we have to understand what are the required things, if anything that is outlier, what is hidden patterns, and those all things. Now you are very much familiar with that, right? We have covered these things in a Python series also, as well as in statistics also. So we have to find those hidden patterns, any of the trends, anything that is not working normal. Like if considering with the example of a baking, we'll think that if we have the amount of flour, if we have the amount of sugar, eggs, all those required things are there and they are in the proper format or proper amount, we can see. Okay. Next is feature engineering. Now pick the right ingredient. Sometimes you might even invent a few of your own, right? That happens the things like if we think now this in our recipe book, one of the thing is not shown, but we want to add, like if it is our favorite ingredient, then we want to add it, or we want to add, they have told the little amount of sugar and we want it extra sweet, so we are adding some of the things by our own only. So that thing comes in this feature engineering. Okay. Next is model selection and training. Now here when we were discussing about unsupervised, supervised learning and reinforcement learning, there I told that some of the algorithms are there, right? So here there are different types of algorithms present. Now it's our choice or it's our thing that which model we should, which algorithm we should choose for our model training. Okay. So that is said as model selection and training. Now time to pick your model. It's like choosing a baking recipe. Then you let the model study before the big test. Now if you like, okay, while preparing for the exam, if a math paper is there, okay, on the next day we are having a maths exam. Okay, and we are preparing for the science. So this is two out of syllables, right? We will, that is not in the correct flow, right? So we need to choose the right syllabus, right recipe, or whatever you can say in this, right study before our exam. Okay, or also right subject before our exam. If not, then you can also understand what will be the result, right, in the end. Next step is going to be model evaluation. Now we have built a model, okay, we have trained it, we have built it, but is it correct? Now this question mark, we have to do experiments on that, and then we can give the final results, right? So model evaluation, test your model. If it's good, great. If not, you have to go back to the drawing board or the oven. Okay, before serving others that cake, we will take one of the bite and taste it, and then understand it by ourselves only that we should serve it or not, right? Then if it is correct, then we have to what we are going to do is, if not, then we are going to the exploratory data analysis and checking what is being not correct, okay, or even we are starting it from the beginning. So that is it. And if it is good, then what we have to do is we have to deploy it. Finally, your ship is out into the world, ready for action. That is the process in the deployment. And behind the scenes, what it does, like it's need for problem definition, data cleaning, data collection. Now it depends how we are going to clean the data, from where we are going to collect the data, then how we are going to find the patterns, insights, trends, anything that is. Then if we want to make any person understand that data, then we need visualizations things, right? Then visualization thing is done, then feature engineering is there, machine learning comes into action. Okay, then we have to train the model, we have to do prepare many of the tests, and then that model has to pass those all tests, right? All, or at least 90% test it has to pass. Okay, then model selection training is done, evaluation is there, testing model is done, then we need to deploy it. So it has to pass many levels, right? So machine learning, it's like baking, but with more math and fewer cupcakes. Now next we are going to learn about statistical modeling. Now let's begin with the basics, okay? What is statistical modeling? It's the process of using math to explain how things work in real world. Think of it as taking a messy situation and turning it into something understandable with structure. Like for example, if you are curious about how coffee intakes affects your mood on Monday. We have all been there, right? Statistical modeling helps you figure out by finding patterns in the data. Now once we have understood statistical modeling, we are going to understand it in the deep when we will compare this with the ML model. Okay, there are different models present, like statistical modelings are categorized different and machine learning models are categorized different. So we will understand that also. There you'll understand this in the deep. For right now, what we are going to do is we will understand now what is population versus sample. Now that we know what statistical modeling is, let's understand the difference between population and sample. A population refers to the entire group you are interested in studying. It's like considering every single person in the world who drinks coffee. Now this, if we are understanding data, okay, these are the different kinds of data types not, but data, how we are going to take data for the modeling. Okay, now we have this population, there are many number of peoples over there. Okay, from them we are only going to take 4 to 5 peoples, like that. So and that will be considered as sample. So we should take population or we should take sample, that we are going to understand. So a population refers to the entire group you are interested in studying. Okay, however, studying every single person in the world would take a lifetime, right? So instead we use a sample, a smaller manageable group that reflects the population. It's like choosing 100 coffee drinkers to represent everyone. Like even when we are playing any of the team game, okay, let's consider cricket only. Okay, there we have the captain. Okay, so that captain knows everyone's habits, right? His team, he should know, he should have the knowledge of his team, like which player is good at what thing, which player is good at anything like that, who gets easily angry, who is better calm person, who should be played where, right? He knows everything. So we just take the captains of 4 to 5 teams and we just ask him the things, and then most of the information we get from that also. So that is why the sample is there. Okay, so we use sample, manageable group that reflects the population. So it's like choosing 100 coffee drinkers to represent everyone. Next we have this descriptive stats and inferential stats. Now this will be very rude if you have not watched my previous videos. We have covered on statistics 2 to 3 videos. Okay, so in that I have explained this descriptive statistics in detail, whereas inferential statistics in detail. So I'm not going to explain much about it, but still let's talk a little bit about it. So let's talk about two important types of statistics, that is descriptive stats and inferential stats. Okay, so descriptive stats is all about summarizing and describing what's happening. Imagine you're looking at a chart showing how much coffee people are drinking and simply describing the trends. Whereas inferential statistics, what happens? It takes a step further. It's about making predictions or drawing conclusions. Like for example, after analyzing the coffee data, you might predict that people who drink coffee are likely to feel more energized on Mondays. That's making an educated guess based on that data, right? I prefer you all to follow the series, okay, because that is why only you are going to understand the things. Now, as I have explained descriptive and inferential stats in the previous videos only, so it will be very good if you are going to watch those videos. Now, next let's learn about types of statistical models we have. Now, let's take a closer look at the types of statistical models we use to make these predictions. First we have in that is linear regression. This model is used when we want to predict a numerical value. For example, predicting someone's salary based on years of experience. A simple straight line relationship, right? The next is logistic regression. See, now okay, keep that aside for logistic regression for a minute. Okay, now we are just discussing about these models. Okay, but one by one we have to understand each, we have to build a model in each of the regression, then we are going to understand it in detail. Okay, so that is why the most important are linear regression and logistic regressions. Okay, linear regression and logistic regression, and that is only mostly used. Okay, this ANOVA and time series models we should know, that is why I'm telling. Okay, so here we are just going to understand the definition of it, theoretical part, and in the upcoming videos we are going to build one by one models. But now what happens is people want accuracy. Okay, they don't want how detailed it is or what the behind the scenes is going. Okay, they want the output, they want the accuracy. So that is why the ML models comes in over there. Okay, so ML's models, most of the task is, we will understand that its task is like it should give accurate results. So here what happens in this linear and logistic regressions, what happens means like statistical modeling, what happens, it tells us most of the things that what is behind the scenes going on. We'll learn about this models also. Okay, so what is the logistic regression? If we need to predict a category, like whether it will rain tomorrow, yes or no. So this is category, right? Yes or no. We have the data into categorical form, right? Means like this is non-numerical data, right? So that is why yes or no, 0 1 0 1 is not, but like that conditions are there, then we are going with this logistic regression. So there we use logistic regression. Okay, it gives us a yes no answer based on the data. So next is we have that is ANOVA. Sometimes we need to compare multiple groups. So let's say we want to compare with ice cream flavor is most popular. So let's say we want to compare which ice cream flavor is most popular. So ANOVA helps us compare all the flavors at once, find the winner. So time series model, what happens in this? These are used when we want to predict future values based on past data. It's like forecasting the weather by looking at past weather patterns. So what are the assumptions in modeling? Like what are the faiths, beliefs in the while modeling? Okay. To make sure our statistical models are solid, we need to consider some assumptions. Think of them as a foundation of a good model. So these are assumptions, let's discuss them. Okay. First is linearity. The relationship between variables should be linear, meaning a straight line connection. If it's too chaotic, the model will struggle. Okay, so it should follow linearity. Next is independence. Each data point should be independent of others. Like imagine your data points are free agents, okay, not influencing each other too much, like that. Next is equal variance. Now your data should have consistent spread or variability. It's like making sure everyone in class is contributing equally, not just a few people dominating the conversation. Okay. Next is normality. For many models to work well, your data should follow a bell curve. This means most values are centered around an average. Now what this average is, what this bell curve is, that also I have explained in detail. Okay. So this means, so it should follow the bell shaped curve. Okay. And most of the means are centered around the average and fewer values are at the extremes. So there are small concepts that we should know, okay, like multicollinearity is, what are outliers and what is overfitting, so that quickly understand those things. These we just need to know these things. Okay, before we are going with the actual functional part, we should be clear with our theories. That is why I'm explaining these things we are going to need, and if anything that is required at that time, that also I'll explain, but this we should have the knowledge before moving to the machine learning. Okay, before this is only machine learning, but we should have these things knowledge, and then we are going to go with the functional part also. So let's quickly talk about a few troublemakers in statistical modeling. Okay, that is this multicollinearity. This happens when your input variables are too similar to each other. It's like having two friends who constantly agree on everything. The model can't decide who's actually influencing the results, right? That's where this multicollinearity comes. Next is outliers. They should lie out only. Okay. These are data points that stand out like sore thumbs. Think of them as the wildcards of the dataset. If you don't handle them, they might throw your model out of track. So that is why we need to handle these outliers, and there always these outliers comes. Next is overfitting. This occurs when your model becomes too good at memorizing the training data, but fails when to apply to a new data. Most of us have faced the situation, right? Whenever we have something that is fully prepared in front of us, we try to play in that only, but we don't try it ourselves. But once if we try it ourselves, then most of the things becomes easy for us. So this overfitting occurs when your model becomes too good at memorizing the training data only, but fails when to apply it to a new data. Now it's like memorizing the answers to practice problems, but freezing on the actual test. In exams, these things happen, right? If we have just memorized what the answers are given by our teachers or any of the books, guides, those things, then in the actual exam we don't remember, mesmerize it, all the things accurately, right? If we have understood the things clearly, then we can write the answers on by own also. Okay, now from the starting we are discussing about the statistical modeling and everything, its factors, its assumptions and all, which are the algorithms used in this. But now let's discuss about why the statistical modeling. So why we care about all the statistical modeling? Simple. It helps us explain why things happen, not just what happens. When you understand why something happens, you can predict it better next time. Now, let's say you are analyzing sales data, okay? Understanding the factors that drive sales growth means you can take steps to improve those factors in the future. In other words, statistical modeling helps you to make better decisions. Now come the most important part. Okay, we should understand what statistical modeling is and what machine learning models are. Okay, so comparison between them, statistical models versus machine learning models. It's like comparing Sherlock Holmes with Iron Man, all in one logic and dedication. The other, all is one logic and dedication. The other, gadgets, data, and boom, predictions. So, what are statistical models? Okay, so let's start with the old school legend, that is, statistical models. These are like the wise teachers. They love to explain stuff like, why is the variable important? Let me draw a graph and talk for 2 hours, like that. They explain the things in too much detail. Statistical model is a mathematical equation that explain relationship between variables. Let's say you want to know if studying more helps you score better. Stat model says, okay, I'll check how study hours affect your marks. Here's a line and here's r squared. Boom, explained. But here's the catch. They come with conditions. Like they'll say, I'll help you only if your data is normal, linear, independent, and the stars align. Just kidding, but not really. It should follow linearity. Whenever we are passing the data, it should follow linearity, no multicollinearity, constant variance, and normally distributed errors. Basically, if your data misbehaves, the stat model goes. Not my job, bro. Now let's talk about ML models. Now enter the cool kids machine learning models. These models don't care about any assumptions. They just want to predict and predict well. Like ML model learns patterns from the data to make predictions. They don't bother much with why. They focus on what. Think of them as magicians. You gave them a rabbit, that is data, and then they gave you a hat, that is prediction. And you like, how? ML says, don't worry about it. Here, accuracy is everything. ML models are all about accuracy. They've used when we have got a tons of features, messy data, and want a superior performance. Want to predict which customer might leave your platform? So if you are working anywhere and you want to predict which customer might leave your platform, XGBoost says, I got you fam. 20,000 features, 5 million rows, and ML just flexes. Now, what we will do is we will just understand it. Means like let's break it down with the real life examples. Okay. So I'll tell these are the tasks. Okay, so I'll tell these tasks and you have to which model we should go with, that we will discuss about. So predicting salary from years of experience. I have told this example when we were learning that statistical modeling also. Okay, so stat model will be there, and which algorithm we are going to use in this, that is linear regression. Next is detecting fraud in banking data. So we should go with the ML model over here. And model will be like random forest. Don't worry by hearing the names of these models. Okay, this random forest is ML model. Okay, we have not discussed that, right? Because we have mostly discussed statistical modeling, because our next topic is also going to be that only, statistical modeling only, like linear regression and logistic regression. We will focus on that. So understanding how each factor affects health. Here also we are going with the stat model, and in this, now what type of data will be there? When we will look at the data, we can understand the things, right? So that is why stat model. Here we are going to go with the logistic regression model. Now recommending movies. Now as we were discussing about the Netflix example, so which model it will be? It will be ML model, and here collaborative filtering will be used. Okay, can be used. Okay, if you have any different ideas, then you can go with that also. So okay, stat models, it explains the things in detail, and ML models, it directly predicts. It doesn't care about if who will understand him or not, who will think like how it has worked or not, like that. Like most of our generation is like this, right? Okay. Now, how to choose. So when do we use which? If you want to understand relationship, explain causes, or your boss says, explain this to the client, then go with the statistical model. If you want high accuracy, lots of features and don't care about why, then just what works. Then go with the machine learning. Or better yet, use both. Use stats to understand, ML to boost the performance. So both are legends in their own way, right? So we have to choose the things on our data, our goal, and our audience. And that's a wrap up for today's machine learning intro. I know, your brains are probably overloaded right now. But hey, you survived your first lesson. So don't worry if you didn't catch everything today. We'll go slow and steady, and before you know it, you'll be a machine learning pro. Make sure to hit that like button if you are excited about the journey ahead. And subscribe so you won't miss out on any future videos. Trust me, there's a lot of fun coming your way. Till next time, keep learning, keep experimenting, and remember, even robots needs a coffee. Hey everyone, welcome back to the channel. Your favorite pit stop for decoding the techie stuff without the headache. In the last video, we tackled the basics of machine learning, the theory, the buzzwords, and all the good stuff. If you missed it, go give it a watch, because today we are cranking things up a notch. We are diving into supervised learning, one of the most important pillars of ML. And don't worry, this isn't going to be one of those only theory, no action lectures. This time, it's theory plus hands-on coding. So yes, expect some Python magic and maybe a few friendly bugs along the way. By the end of this video, you will know how to train a model to make predictions like a pro, and no, you don't need a PhD or superpowers. Just a bit of curiosity and a laptop. So buckle up, because this machine learning's journey about to go full speed ahead. Now let's understand what is supervised learning. Supervised learning is like having a super strict teacher. The teacher gives you questions and the answers. Your job is to learn the pattern between them. Example, if I give you photos of cats and dog and labeled, okay, means like cat's photo is labeled with cat name and dog's photo is labeled with dog, okay, you learn to identify them yourselves only. If I tell you that if I show you two different animals and tell them that which is what, you can identify the cats in them as well as dogs, right? So I just showed you pictures with the labeled, but in the real world then you can understand the things, okay? So that is only the thing. The labeled thing is given, and then we, by watching it or by looking at it, we can identify the things. That is only the thing in the supervised learning. You always have labeled data. Answers are provided during the training only. Okay. Now, as we are learning about supervised learning, why don't you know some of the history of it? So once upon a time in the 1950s, the legendary Alan Turing asked, "Can machines think?" A few years later, Frank Rosenblatt built a Persistron, the first machine that could learn from examples, like a baby learning to recognize faces. But dreams crashed in the 1970s. Computers were too slow, data was too small, and faith faded. AI winter froze everything. Fast forward in the 1990s, technology rolled back. Faster computers, more data, smarter minds created decision trees, SVM, that is support vector machines, and better algorithms. By 2012, deep learning exploded onto the scene. Now, supervised learning powers everything from Netflix recommendations to Siri's voice. A journey of dreams, falls, and rise. Supervised learning grew up alongside us. It quietly runs the modern world. Now let's move on further. This is the history of supervised learning. Next we have is types of supervised learning. What problems are there? Now imagine you are a computer. Yeah. Sorry, no feelings, no TikTok, just pure calculations. One day, someone asks you two different questions like, is this email spam or not? Or what is the price of this house? Now tell me, first question is a yes no thing, right? Second question needs an actual number like 25 lakh, 30 lakhs, right? That's the heart of this topic. Classification means categories, categorical data. The output is labeled, it's like sorting laundry, socks, t-shirts, lost dreams, like that. If you are getting email, okay, considering this email spam example, okay, if we are getting an email and it is, we have two buckets, consider it as buckets, okay, we have two different buckets. In that we are one is written as, one is labeled as spam, one is labeled as not spam. In not spam, if any email comes, okay, it is being categorized, it is being undergone from this both the buckets, and whichever buckets categories are fulfilled by that email, then it is going to be categorized in that. Means if spam is having some of the conditions, it is fulfilling its condition, it is going to go in spam. If and in not spam's bucket having its own conditions, and if that email goes in that conditions or fulfills that condition, then it is going in not spam's bucket. Okay, like that this data is being sorted. If we take the example of cat or dog, then also it is going to do the same. Here what is important thing is we have labeled data, and in classification we are getting the data in categories. Yes, no, like that. It's all about putting things into buckets, right? We have different kinds of bucket like spam, not spam, cat, dog, science, etc. Not in actual there are buckets, behind the scenes there are not actual buckets, okay, but we are just trying to understand the concept here, okay. Now next we have that is regression. Regression means continuous values. It's when the output is not a category but a number. Classification, regression are opposite. Okay, just remember that classification we are getting the results in the yes no form, textual forms, and in regression we are getting the outputs in the numeric forms. That is the main important thing. So we get the output in the number, and that number can slide up or down like your mood at 3 a.m. Not actually, okay. So examples of this we can take as predict the price of a house, predict your weight based on the number of burgers you ate. I know, no one is going to tell the truth. Okay. There are infinite possible answers, not just 1 or 0, right? Now I'll give a cheat code for this, okay? If your answer sounds like yes, no, this, that, it's classification. If your answer sounds like number, it's regression. Okay, now let's move on to the next topic, that is variables. We have two different types of variables, that is dependent and independent. Here variables means quantitative data, okay, quantitative values. We can calculate them like that. Now let's meet these two besties who rules supervised learning. Independent variables are like, these are the input features like ingredients in a recipe, and independent it is opposite. This is the final dish, the output, the result, or whatever the food ingredient we are making. Okay, now let's take example of cake. Okay, we have took this example previously also when we were learning the machine learning's workflow, right? Okay, in the previous videos it was. Okay, now let's focus on this. Here also we are taking the example of baking. For baking we need ingredients like flour, sugar, butter, right? Those things are there. So these we are considering as independent variables, okay? And the final, the cake, when we prepare it, it is dependent. It is dependent on these ingredients, right? So just that is the thing over here. If we take the example of house price prediction, and we are going to, this house price prediction, we are going to perform this actual, okay, this with linear regression, we are going to perform it. Size, location, number of bedrooms, these all things are independent. There is no dependent relationship on each other, right? But price, like if there are 3 to 4 numbers of bedrooms, then its price is high. If there is just one bedroom, then its price must be low from the 3 bedrooms ones, right? Let's say you're predicting a person's salary based on their experience and education level. This can also be the example, right? Independent variables are like years of experience, education level, right? And dependent variable will be salary, because salary depends on the experience and education level, right? Now next what our topic is going to be y equal to mx plus b. This is the equation of linear regression, and we are starting with the linear regression, okay? So what is this linear regression? Everything we are going to understand with practical. We will build a model and side by side we will also understand the things. So to make understand this equation of linear regressions equation, I'll explain it with an example, okay? Here you can see this one of the example is there, okay? Just keep in the mind that we have the equation y equals to mx plus c. For that we have different values, okay? Now whenever we are building a model, okay, we have data, okay? Data we have, so this x and y, this we are having the data. We are giving some of the things to data, and based on that we want rest of the things outcome, okay? Rest of the things, whatever it is, we want outcome of it. And here you can see the circles, okay? These green circles are there. We will consider it as balls, okay? Then what you can do is, first ball is small in diameter, okay? Its diameter is small. Next ball's diameter is bit big. So like that you can think of these circles, okay? Now what the thing is over here, that we have 1 diameter ball, 2 diameter ball, 3 diameter balls, okay? So we are considering it as that. In our x variable we are having the diameters present, okay? In a y variable we are having the prices of those balls. Like that we can consider it over here. These are just circles I have created, but I want to explain it with an example, that is why. So for the 1 diameter we have price of 50 rupees, for the 2 diameter we have price of 55 rupees, okay? Just consider it as that. So we are having some of the values, okay? From rest of the population, like we are having sample, means like just for a 5th till the 5th diameter we are having the values of those, okay? So now we want to predict the values of 6th one. By looking at the data we can understand, okay, that is fine. But what will happen when the diameter will increase, and like we need to predict the values, like, so what we are doing, we are going to build a model which will tell us what is the price of the 6th one, okay? 6th one, if 6 diameter is there, then what will be the price of it, like that we have to find, okay? This is only what we are going to do in this linear regression, and this is only what is machine learning is also, okay? So now we understand that we have the data of x and y, okay? We have data of x and y, and the 6th diameter we have the question mark over there, that value we have to find, okay? So we'll understand the things. Now what is deviation of x, deviation of y, these are the things which we are going to calculate, but I have already written those things, okay? But I'll explain it slowly. Now first, what is there? We know mean, right? What we have to do is how linear regression backstory is, what is this y equal to mx plus b, that I am going to explain it, okay? That equation I want to explain before we get started with the linear regression model, okay? So you can consider it as this. First we just right now we have the one variable that is x and one variable that is y. X values we have and y values we have, but after some of the time we have to predict the y's values, okay? We want the y values to machine predict by itself only. That is only all the concept is going to be over here, okay? So you will also understand that equation, linear regressions equation, okay, in depth. So this is the backstory you should know. We are not going to use it, but we should know. We should understand what is the backstory of that models. So how it is working, okay? So first what we have to calculate is, we have to calculate the mean of x and the mean of y, okay? I have already wrote those things, that what is the mean of x and mean of y. How we are calculating mean? We have to calculate all the values. For right now we are not taking that 6, okay? Don't consider that 6 in the mean of that x. I have not calculated that. Only values from 1 till 5, okay? Now what will be the mean of that? Like we have to calculate. If you will calculate 5 plus 4 plus 3 plus 2 plus 1, the count it will come that you have to divide by 5, okay? Your answer of your mean will come as 3, If you'll calculate, you will get that thing also. Mean of x will be 3, and same goes with that of y also. We have to calculate all the values, we have to add those, take sum of those values and then divide with the number like 5. We have to divide over here. Then by calculating that thing, we are getting the mean equals to 63. Mean of y is 63. You can see it into left side. Okay. So now we have got the mean values, we have got the of both the variables, right? So this is only what x, y, mean. Up till now it must be clear, right? We have got the mean and we have got the mean of y, x, l, both the things. Okay, this is simple. Next we have to calculate the deviation of x and deviation of y. Now how we are calculating deviations? Okay, I'll tell that. What you have to do is you have to take the variable x value, x minus mean. So 1 minus 3, what it will be? It will be minus 2. 2 minus 3, what it will be? It will be minus 1. 3 minus 3 is going to be 0. Mean of x, okay? X minus mean of x will be deviation of x, okay? So that is only, I have calculated the values and then deviation of x values I have got. Same goes with the deviation of y. Here we have to minus the things, y variables we have to minus with the mean of y, okay? So 50 minus 63 is going to be minus 13, 55 minus 63 is going to be minus 8, like that I have calculated the deviation of y, okay? Simple things up till now, okay? What we have did, we have just calculated mean of both the variables and then calculated the deviation of both the variables, okay? Next what we are going to do, we are going to combine this deviation of x and y, okay? Means we have to make the product of both the things. So 13 into 26 is 13 into 2, what it is going to be? 26. And why we have not took minus? Because minus minus becomes plus, right? Minus into minus equals to plus, right? This we know things. So product of x and y means product of deviation of x and y, okay? So I have calculated the values. So I have got 26, 8, 0, 7 and 24. If you will calculate all the values, we'll get 5 different values and those are I have mentioned over here. 8 into 1 is going to be 8, 0 into 2, anything multiplied by 0 is going to be 0 only, 7 into 1, 7 and 12 into 2, 24. That I've got the values, okay? I've got the product of deviation of x and y, okay? I have to, now what we have to do is we have to add all the, means the product values we have to add, okay? After adding all the product values, I'm getting the 65. Okay, if you will calculate, you will get the 65. So this is the all the thing that we have got, okay? So next what we have to do is we have to square of deviation of x. We have to measure the squares of deviation of x, okay? Keep in the mind of deviation of x, okay? Means this minus 2 square is going to be 4. Minus minus we are not taking, okay? Means minus minus becomes plus, that is why we have not given minus sign. 1 into 1 is going to be 1. 1 square is 1, 0 square is 0, 1 square is 1 again and 2 square is 4. We have got the square of deviation of x, right? We have got those values. Now what we have to do is we have to add these values also. Okay, what is the sum of square of deviation of x? That also we have to keep in the mind, okay? What you are going to get 8, 9 and 10. You are going to get 10 value of it, right? Now next, what is the formula? Here you can see we are proving the formula, that is y equals to mx plus b. On this formula linear regression works, right? So what y is there in that? I'll tell. Y means prediction. Y and x values, we have those, right? We are getting the data that is dependent, independent variables. We know what those are, things are there, right? One is based and other is based on that. So one is independent, which is not based on any other factors, and dependent one is what? It is based on that independent one, right? Like that thing. So we have x values, we have y values. That is simple thing, okay? We don't need to go in depth of that. Here important is what? M and b. M is slope, B is intercept, okay? M means how much y changes, okay, per unit change in x. In simple terms, what we can say that if we are making any of the change, a single unit's change we are making in the x-axis, then how much y variable or y-axis varies. That is only the thing, that is slope, okay? We'll see that one will once we will make the changes, okay? Once we'll understand this formula further. Next, B, intercept, okay? Value of y when x will be 0, Okay, that you have to understand. That is intercept. Formula for m I have mentioned over here. Okay, sum of product of deviations. We got 65, right? Something that value we got. And sum of square of deviation of x. We got 10 value of this, right? So 65 divided by 10, what it is going to be? It is going to be 6.5. Keep this value in your mind. Okay, 6.5 the value is going to be. Then next we have this b. B means our intercept. Okay, we have just splitted this formula mx plus b. Okay, that I am explaining. Here we know y, what is x, what is y, what is m, what is b. These things are there. Okay, next what is there? B is there. Okay, so what is b's formula? Mean of y. We know this value. Okay, and then minus it with the slope, whatever we are going to calculate, that once we get the slope. So slope's formula is also there, right? M's formula is also there. So once we calculate the slope, we have to multiply that value with the mean of x, and that we are going to get b. Okay, after doing all these things, we got all the values, and then we will put it into this mx plus b. Okay, and then we will get the value of y. Here y, what we have to calculate here? We have to calculate, means our x is 6, right? Then what is y? That we have to calculate, right? We want to find the diameter. If diameter is 6, then what the value is going to be of y, right? That is only we are predicting, right? So that thing we will get once we get the m and this b, the slope and intercept. Clear? Now next, let's see if we got the values. Okay, so we will quickly calculate the value of m and value of v. Now value of m is 6.5, right? We have got that thing. Sum of product of deviations divided by sum of square of deviations of x. We have calculated these values. Okay, don't get confused. Now next is mean of y, and mean of x and mean of y, we have known the values, right? 3 and what was there? Something was there of mean of y. Okay, and just m we have calculated now, that was 6.5, right? So now here you can see that m was 6.5, we got m value 6.5, and when we calculated b value, we got 43.5. Okay, clear? Now what we have to do is we just have to put this into that mx plus b. Okay, y equals to mx plus b, 6.5 multiplied by 6 plus 43.5. Okay, m into x, I have did. X was 6 because we were finding the diameter, like diameter of that circle is diameter is 6, and then what will be the value of the y, then we wanted to find, like what we should keep the price of that thing. So what is the answer? You have to comment. I have splitted this formula and also calculated most of the values. Now what is going to be the diameter, what is going to be the price of when the diameter is 6, you have to tell me. Okay, I'll also mention the answer, but you should also tell me. Okay, this is simple. Now you just have to calculate the thing. 6.5 multiplied by 6 plus 43.5. Okay, leave it, I'll tell the answer only. So the answer is going to be 82.5, means what we are going to keep, the round of figure we will keep. Okay, 82 will be the price when the diameter is 6, like that we have calculated. Okay, now we will give the data into the bulk amount. Okay, like if diameter is 7, diameter is 8, diameter is 9, it is going to calculate automatically. Okay, but we have understood the behind the scenes, the behind logic of the linear regression. Okay, what is its equation? It is y equals to mx plus b. We have to keep it in mind. How we are finding m, how we are finding b, what those values are, we are clear with it. Okay, this is simple example. If you feel any difficulty in understanding this example, please let me know in the comments. Okay, what the answer is there? 82.5. If our diameter is 6, then the price of that product will be 82.5. Clear? Now next what we are going to do is we will start building a linear regression model. Simple model it is going to be. We can consider it as mini project also. Okay, and it is going to be simple, very clear. We are taking that example again and again. Okay, house price prediction that we are going to make. Okay, so we need to open a Jupyter notebook and then we will start creating it. So I have opened this Jupyter notebook over here. Okay, I'm using it as we are all along the way we are using this only. Okay, I have named this notebook as house price prediction. Okay, and then what I have did is linear regression. We are learning what is the equation of linear regression, that is y equals to mx plus b. I have mentioned it and we know what the backstory of this equation. Okay, we also understood how and this linear regression is working in the behind. Okay, so linear regression is a statistical method used to model the relationship between dependent variable and one or more independent variables. When more independent variables will be there, it will be considered as multilinear regression. Okay, we'll understand that also. It finds the best fit straight line. Okay, in simple linear regression, straight line we will get that minimizes the difference between actual and predicted values. Okay, we'll see this. Okay, first things first is libraries. We need the important libraries. Okay, so NumPy is there. NumPy I have taken because I wanted to store the data. I have just created a simple data over here. We have not took any CSV file or any other data set. Okay, if you want you can take that also. Then I have took Pandas. Okay, now this is then this Matplotlib is there. These three libraries we have been familiar. Okay, Scikit-learn also we have used. Okay, Scikit-learn, that is only this library. Okay, from Scikit-learn. Now as Scikit-learn is machine learning's library, right, we can say that from Scikit-learn it is known as Scikit-learn. Okay, so Scikit-learn we have took linear model. Okay, linear model for linear regression as we are building that only. Okay, model selection we need this train test split. Now why this train test split is there, how it works, that also we will see when we are, let's start building it, and whenever this train test split will come, I'll explain that in the depth. Okay, then from Scikit-learn means like Scikit-learn we from that we have matrices. Okay, from that matrices what we have imported, we have mean squared error and R2 score, means R square score. Okay, these three things are there, that is train test split, mean squared error and R square score. Okay, I'll explain that also. From Scikit-learn we have imported these things right now. Understand that things, these are just the libraries we needed. We imported the things whichever we wanted. Now next we need data to work with, right? So I have just took two variables like we were understanding in the examples of this diameter ones. Okay, I just took x and y. Here also area and price. Okay, area is, let's consider as area as x variable, and then price as y variable. Okay, so which is dependent, which is independent, right? We can understand that area is, no, whatever the area is there, but area is not dependent on price. Price is dependent on area, right? You can understand this thing. So let's assume this area is our independent variables, means this price is dependent on this area. Okay, once we understand the data, by just looking at it only we can see the things. If we are familiar with data, if we are working with it again and again, then we will understand the things by just looking at it and understanding it and deeply. Okay, so as simple thing is there, area cannot be dependent on price. Okay, and price will depend on area. Simple concept. Okay, so dependent variable, independent variable we have identified. Okay, we have identified our x and y in simple terms. Okay, now I have created array. Okay, if I would have taken any CSV file, then these things were not there. Directly the PD we could have made it. Okay, so I have took this data. If 500 area is there, 500 square feet area is there, then it will be then its price will be 50 lakhs. Okay, so like that I have calculated, means I have given this data. 20% of the data I have given to this. Okay, simple concept, no need to just go high and mess up the things. Okay, up till now it is too simple. What we have did, we know independent variable, we know dependent variable, we just sorted the things and we have given 20% of the data to our model to understand it. Okay, so it will understand, and then when we'll give this areas, then it will give us price automatically. Okay, so next what we did is we took variable, in that we store our data. Okay, data frame I have took for area it will be column names. Okay, I have given that. You can see this area right now. First it was like this. Now I have renamed the column names. Okay, area and price, I have told that these are the column names of that. Okay, so I have converted it into data frame. Okay, and then this data is printed over here. So this is our simple data. In real life we are not going to have just this much data. We are going to have different kinds of file. We'll need to understand those files, and then we'll need to understand what is independent variable, what is dependent variable, what we need from that, and what we need to predict from that. Okay, so that is going to be our work. Okay, so until now it is very clear. What we did, we just took the data and loaded the libraries, and then took the data into data, small variable data. Okay, simple concept. Now next what we will do is Now let's start building our model. Okay, now here the main story starts. Okay, so what we have to do is we have to tell a model, okay, whatever we are building, we have to tell that this is my x and this is the y. Okay, now here over here it is not mentioned that what is x. We have understood what is x and what is y, okay, but we have not told machine that take this as x and take this as y. So what we have to do is we have to define the features of x and target, that is y. What is a target? What we want to predict, okay, that is our target. So we want, what if we'll take that example of diameter, and that what we have to do, we have to predict the price. Okay, so here also our target is going to be price only. So we have to define those features. Okay, how we are going to define is we have to take the variable of x, we have to take the variable of y. Okay, from data we are taking area. Okay, area, then it will be as x, it will be stored in the x variable, and like that only we are going to do with the price. Okay, so I'll quickly do that. So here we have simply defined x and y. Now that what we imported from Scikit-learn, that was train test split, right? So we are writing this data into train test split. I will quickly write and then we will go and understand that train test split in depth. Okay, so see how this train test split is written. Train means we have to train the data, not that actual one trained. Okay, train means training data. Okay, x test means testing data. Okay, then y train and y test is there. Okay, see, some of the data we have to give to training, okay, to train the model, and some data we are going to test. So like that the things is going to be. X train means some training data from x variable, x test means some training data from x variable. Okay, this thing is there. Same goes with the y. From y variable we want some of the data, that is training data we have passed. Okay, and from y only we want to predict some of the values, right? So y test data is also there. This is clear. Okay, then how we are writing, how we are giving values to it, x like we are writing this train test split, and x and y as we are working with those variables, right? So x and y, how we have mentioned x is capital, y is small. Okay, this is written in the sense, if you can take any different variables then also it is okay. Okay, but you have to understand, what variables you are taking, and you have to clearly mention them. And it, remember, Python is case sensitive, so keep that in mind. Okay, test size. Now this test size will be, I'll tell you when we will predict. Okay, so like that this test size is there, and random state is 42 is there. Okay, I'll explain these two things also. Just keep in the mind that this is how we are writing a train test split. What variables are there we have took, right? And how we are writing this train test split. Now let's understand this train test split in depth. Now I'll start with an example for this train test split. Okay, what simple things are written over here? It's a technique to split a data into two parts. Okay, training and testing. That is the thing, simple thing. Okay, training data is there, testing data is there, we are splitting the data. The training set is used to teach the model patterns, okay, in the data. Training one data which we have splitted, it is used to train that model. Okay, and the test set evaluates how well the model performs on unseen data. When we are whenever we are doing tests on it, it tells us that how the model is performing, it is good or it is bad, like that. Okay, when we are splitting commonly, okay, whenever, if we don't know like what the output is going to be, then common type of split is that like 80% and 20%. Okay, I'll explain this with simple example. Okay, now imagine you are baking cookies for a party. Okay, you have made 100 delicious cookies, but before sharing them with your guest, so you got to test them first, right? So you secretly eat 20 cookies for quality control, and the other 80 you save for your guest. Fair enough. Okay, so now let's take this example in the machine learning world. Now replace cookies with the data. In machine learning, we have got a data set, say 100 rows. Okay, before making our model meet the world, we need to test it ourselves, right? That's where this train test split comes in. It splits your data into training data, that is 80%, where the model learns the recipe. Okay, testing data means like 20%, where we test the model. Why do we even do this? Why not just use all the data to train the model? Well, that's like baking cookies for guests and never tasting them. What if they taste like burnt toast? So sad, right? We test on unseen data to check if model can generalize well. Can it handle the data that it has never seen before? Or is it just memorizing like a parrot? So simple terms are there. X is your features, cooking ingredients, and Y is labels. okay, cookie test score. And test size means, like we have mentioned, that 0.2, right, means 20% of cookies go to testing. Okay, so hope this train test split is being understood by you. Okay, if you have any doubts in that, you have to mention in the comments. Okay, now let's go to our data and we will. So here if we reduce this value like 0.2 to 0.3, means 30% of the data we are giving for the testing. Okay, so like that is the thing. So this is how this train test split is working. Okay, now you have understood we are giving some amount of data for testing and rest of the amount for predicting and all the things. Okay, so how much amount of data we are giving, this is random one. Okay, so what we have took is we are giving a 20% data to test and then prediction on 80% data, like that. Now let's create and train our model. So we have created model. Which model we were going to learn? Okay, that is simple thing. We have used this linear regression. We have called now all the things we have prepared. Now we are calling our linear regression model. Okay, and we are fitting the whatever we have splitted the data for testing and for training. We have given this to this. We have fitted that data into this model. Okay, model means linear regression. Okay, simple concept is there. Now what we are going to do is we are predict whichever data is there of that training data, for learn that. We are telling this linear regression that learn that data and then predict the things. Okay, so for that we need to create a variable and tell that model that this is the testing data, learn that data and then predict on that. Okay, and those things we are going to and make predictions based on that, and from that we are going to store those predictions into this variable whichever we will give. Okay, so I'll quickly write that. So now let's assume that it has made predictions. Okay, now what we are going to do is we are going to compare actual versus predicted values. Okay, now we are entering into, now we have took the model, we have we have fitted the data in that model, and now we have now this is our testing part. Okay, now we are testing that model if it is working fine or not. So we are going to compare actual values versus predicted values. Okay, now here what we have did is we have took variable, we have compared the actual prices versus predicted prices. Okay, we know what actual prices was in the y test. Okay, and predicted prices were in the y pred. Okay, price we have took, the just focus on this price here. Okay, price means our y column. Okay, y variable, in that prices were there. Okay, so actual prices were this much and predicted prices means it is going to predict the prices into this much. Okay, whatever it has learned it is going to predict like this. Okay, now next let's understand the mean squared error and R2 square. Okay, means R square. Okay, now here comes this mean square error, means MSE. MSE means mean square error. Okay, and R2 means R square. Okay, R square score, that is there. How we have written this mean square means like how we have understood that train test split, we are going to understand these things also. Okay, mean square error, and in that we have given this test and this predictions whichever we have made. Okay, R square, R2 score is there. Okay, in that y test and y predict we have passed the values. We need this thing. Okay, it is important for us to understand what is mean squared error and what is R2 square of those things. Okay, and simply we have printed the things. Okay, mean squared error is 12.5 and R2 score is there, R square score is there 0. This thing. Okay, this value is there. Now let's understand what these two things are there. Okay, and then we are going to make visualization of whatever thing we have done up till now. Okay, so MSE and R square. Okay, MSE means mean squared error. Okay, what it measures the average of the squared differences between the actual and the predicted prices. Okay, predicted values, in our case it is predicted prices, right? It will measure the mean. Okay, mean square error, and mean is average. Okay, so it measures the average of the squared differences. Here squared is important. Squared means what it is going to do. Now our value was something like 250 was there. Okay, so it is going to square that and then square both the values. Okay, and then it is going to understand the difference, means it is going to subtract those values and then it is going to make the things. Okay, that is our mean squared error. Okay, simple terms. R square, what it indicates, how well the independent means x. Okay, how well independent variables means area. Okay, in our case independent variables, explain the variance in the dependent variable. Means whatever changes are happening in the y variable, that it is going to explain. So that is there. Okay, so you have understood that slope, right? Means it was like that yeah, slope. So it was like whenever 1 unit of change we are making into x-axis, then how much difference is happening in the y-axis, that was thing, right? So that is only over here also. R square, what it is going to indicate, it indicates how well the independent variables, means that is x variable in our case, that is area, okay, area of those houses, explain the variance, explain the difference, or explain the changes happening in the dependent variable. Okay, simple terms, no complex things. Okay, over here. Now let's go to our model and then we will make visualizations now. Now we have covered most of the things in our visualization video also, right? Visualization chapter also. From Matplotlib we have to scatterplot, okay? And as we are taking it in from Matplotlib, okay, we have to pass most of the things to it, like what is x train, what is y train, means x-axis variables, y-axis things we have to pass it. Color we have passed, and label, what is that? Training data. If we would have took it from scatterplot, then we would have not needed to give this label, okay? But some things are good at its own place. That there are some of the reasons that I have took this not took from Seaborn, I have just took from scatterplot. Okay, next is there for x we made, okay, for y we need, okay, for training data we have given blue color, and for test data we have given green color. Simple things are there. Okay, label, what is that? Training data is there, testing data is there. Next we have made plot from plt.plot. How it works we also know. Okay, x model predict x axis means x values we are giving for the x, color will be red, line width will be 2. So we should understand how that line is going to be. See, we are going to see a straight line, okay, here, and label will be regression line. Okay, x label we know, y label we know, title we know, house price prediction as we are making. Legend, what it is going to be, I'll tell once we will print it, once we will visualize the thing. Okay, and grid we know that boxes will come, grid lines will come. Okay, grid lines we have kept true because we need most of the things to understand, because some values will not be actual, right? Actual number only, it is not going to be whole number, it is not going to be, there will be points. Okay, so like that. And we are not predict in y-axis, we are not going to write from 1 2 3, not like that, right? So, and plt.show, it is going to show. Now let's execute this. See, house price prediction, title is there, index is there, price rupees, price in lakh I have given over here, and area in square feet I have given. Okay, we have got this regression line. Okay, we have passed this regression line, we want it red, testing data will be green, training data will be blue. So we can understand the things very clearly. Grid lines is there. Okay, legend means this thing only. Okay, means it is creating this legend. If we'll just where was that legend? Okay, we'll just comment out this line. What you can see is, okay, so now if you'll execute, you cannot see that legend. Okay, that box means legend was there. Okay, and it was easy to understand the thing, so we'll keep that. Okay, simple concept is there, no difficult task. Okay, so this green means what we have did is, this green dots were representing testing data was there, this much testing data is there. Okay, this and training data is this much. Okay, this is small data, that is why we are saying it is not more clustered. Okay, that is why. So for 50 it is going to be for 500 area is there, 500 square feet area is there, 50 lakh is there. Okay, in between of that, if any would be there, then this much value will be there, or this much price will be there. If 1000 square feet is there, then it is going to be 100, like that. It is telling us, we are predicting the house's price. Okay, simple is there. Linear regression, we are getting linear line, right? We can understand the things, and as we have removed the squares and averages and all, we are getting data in that line only, not scattered and all, because we have removed outliers. So linear regressions, there are some of the assumptions that we need to keep in mind, that we need to make our data in that form. Okay, means like it should be linear, it should have no multicollinearity. Those things I have explained in the previous videos also. Okay, you should understand the things clearly. Now what we will do is, we will give it a new variable or new x value, okay, x variables value, x, what were there in x, we were having area, okay. So here it is, okay, till 3000, okay. So what if the value is like more than 3000 or in between like that, 2000 is there, okay. I'll give it as 27,000, then what will be the price? I want to know this thing. So we are going to check for the new area, okay. So I'll quickly write that thing. We have passed our data into NumPy, right? So we have to give it that only. And how we have given our data? I wanted to check the price of this much square foot area is there, okay. I'm having this and I want to check what price I'll get by this model. Once now I have created this, okay. I'm just going to pass this linear regression model to it, okay. Model I have given and predict the price for this, I'm telling it. So now let's see, our model is giving us the price or it is going to give us some error, okay. So we will understand that if we have built this model clearly or if we are getting any error or something we have missed, okay. So this is our final step and we are executing and our project will be completed. This mini project will be completed, okay. Oops, we got error, predicted price is not defined. Sometimes this case sensitive things becomes too hectic, okay. Okay, so we have got our output clear and clean now. We have removed the errors, whatever we were facing, this case sensitive thing. So here you can see predicted price for 2,700 square foot. What it is going to be? 270 lakhs. Okay, if I'll change the value over this to, let's say 31 square feet area, what it is going to be? Oops, here I didn't change that. So see, you can see the values, it is changing the value. See, now we don't have, now if we just have this square feet, how much square feet area is there? If anyone will come and tell us that I'm buying this house and this is the area of it, okay, this much square feet area is there, okay. So what you can do is you can just pass this value over here and then we'll get what the price should be there of that house. Now next it is going to be that there might be no just area is there, okay. If it is in city area then its price is going to be more. If it's in some of the rural area then might be the prices will be less, okay. So that thing depends on area, but there might be other factors also, like there is a swimming pool in that house, okay, or like that, or there is station areas are nearby, or some of school facility is nearby, so those factors also affect. So now we are having this multiple x variables, so that is what it is, multilinear regression, in which there is no single x factor, x variable, okay. There are multiple x variables, so like that will be multilinear regression model. So now we have in linear regression we have these two types also, multiple linear regression as well as polynomial regression, okay. So what is this multilinear regression or multiple linear regression? Predicting one output using multiple input variables. And so as we were taking this real world example like of this house price prediction, we have created this mini project also. So in that what happens is, as I told, that location might matter, then number of bedrooms might matter, then where in which location, like if schools are nearby, or travel facilities are nearby, railway stations are nearby, then also those factors also affect, okay. So based on that also we can predict the things, so that it comes in multilinear regression. It is also having its formula, okay. But key assumptions for this multiple linear regression is there, like data should be linear, okay, no multicollinearity, homoscedasticity and normality of residuals. Those things matter. We should keep that our data is fitting in this of the things, okay. But what happens, like what are the challenges that we face when working with this multiple linear regression? If there are too many variables, model becomes chaotic. Next we have is polynomial regression also with us. Polynomial regression is also a regression model, but it is a little wiggly one, okay. If we want to take any real world example, then modeling the growth rate of a plant, it is not straight, right, but it is curvy. We cannot actually decide. We need to wait a lot. We need to have a lot of patience in this polynomial regression. Okay, it is a regression analysis where the relationship between independent variable and the dependent variable is modeled as the nth degree polynomial. Here we have different degrees. Okay, that is based. If you want to learn polynomial regression in depth, then also I can explain it. But what happens is, why I am telling this, I want to explain linear regression and logistic regression in depth. Okay, but most of the things, what happens is, now in this time what is happening is, we are using machine learning models, ML models we are using. These are statistical models. Okay, linear regression and classification, these are statistical models, but we are using ML models, and that we need to understand in depth. Okay, this we should, now as we are moving further, we should not leave our roots. That is only the thing. That is why we are learning the statistics also, and that too in depth. So alright, my future data wizards and algorithmic architects, that's a wrap for today's Tech Jam. From super strict teacher vibes to banking metaphorical cookies to predicting house prices, we went full main character energy today, didn't we? Remember, every model you build is basically you're teaching a baby robot how to see the world. No pressure, right? So if you liked this mini journey through supervised learning, smash that like button like it's an AI winter trying to stop you. Subscribe if you want to grow your tech glow up, and hit that bell because next time we are diving deeper, and trust me, you don't want to miss it. Until next time, keep questioning, keep coding, and remember, machines may learn, but you are the real magician behind the scenes. Wait. Before you scroll past thinking this is just another boring tech video with more math than memes, hold up. Ever wondered how your inbox magically knows what's spam? Or how Netflix just gets your taste in shows better than your best friend? That's not luck, fam. That's classification. And today we are diving into this beautifully nerdy world of binary choices, multi-class chaos and multi-label madness, with a dash of humor, a sprinkle of visuals, and yes, sigmoid sauce on top. Ready to turn your confusion into a confusion matrix? Let's go! Now, in the previous videos, as we have learned about machine learning, we have learned in that supervised learning. In supervised learning, we have two terms, that is classification and regression. In a previous video, we learned about regression. We created one model to that, right? And we explored about those things. Now, in this video, we are learning about this classification. It is the term of supervised machine learning, okay? So, why this classification? So now classification is used in supervised learning to automatically assign data into predefined categories, okay, enabling efficient decision making, pattern recognition and prediction in various real world tasks such as spam detection, disease diagnosis and image recognition. This is theoretical definition. Now let's understand this with an example, okay? So let's get real for a second. The today's world, it's noisy, messy, chaotic, right? We don't need information, we need to make decisions fast and right. Is this email spam or not? Is that tumor benign or malignant? Is that cute animal a cat or just an extremely fluffy pillow? Here what important thing we have to keep in mind, that is classification is the term of supervised machine learning, okay? And here we get the data into categories, okay? Classification into 2-3 different kinds of categories we get, and in that we have to classify the data. Here the simple concept is that, okay? Now what is this classification in actual is? Classification is type of supervised learning. It is going to come in every term, okay? It is a term of supervised learning, now that you know. Goal is to predict categories, okay? We get the answer into categories, okay? Or class label. And in supervised learning, as we have labeled data, right, we have to keep this in mind. I have taught supervised learning in very depth in my previous videos, okay? You have to watch those previous videos before you're watching this video. So what this classification is, Simple. It's about sorting things into group based on what they are. Think of it like your grandma organizing her kitchen. Sugar goes here, salt goes there, and that mysterious spice from 2003, yeah, it goes in the trash. So classification equals to organized chaos. Machine learn from examples to put things into the right bucket. Okay. So now this term we have understood like what is classification, but there are how many types of classification? Now let's understand that. So type of classification are binary classification, multi-class classification, multi-label classification, and imbalanced classification. First is binary classification. Spam versus not spam, disease versus no disease. Should I text them first or die overthinking? Next we have is multi-class classification. More than two options because life isn't just black and white, right? Recognizing whether a photo is of cat, dog, or a rabbit. Predicting which subject you will nap through in class like maths, history, or physics. Simple terms, okay? Next we have is multi-label classification. Now this is where it gets juicy. One thing can have multiple labels at the same time. For example, a YouTube video like this one can be funny, educational, life-changing. Machines can assign all relevant labels at once. Multi-talented like you. In imbalanced classification, it is not mostly used but still we will learn about it. One class is having samples more than others, okay? And for example, in fraud detection, it is being used. Now let's learn what is logistic regression. Okay, logistic regression, it is a statistical method like how in the previous videos we learned about linear regression. Here we are having logistic regression. Simple, don't look at this definition. Okay, what will happen in the logistic regression? We are going to get answer whenever we are going to build the model. In linear regression, we were getting a linear line. Okay, we were getting linear. There were some of the assumptions that we have to follow when we were giving data. Okay, and here in the logistic regression, it is a statistical method. Okay, we have to predict the probability that a given input belongs in a particular class or not. Yes or no, true or false. These kinds of answer we want from the model. Okay, we don't want any particular number. When in the previous video when we were learning about linear regression, we created house price prediction, right? House price prediction example we created, and there we were getting the number, the price when we were giving the diameter, we were getting what price we should keep of that area. Okay, like that we were getting. So here we don't have any price, we don't have any number, we are not getting output into the numerical forms, we are getting output into the categorical forms, that is yes, no, true, false, this, that, and all those things. But we are getting it into 0 or 1, binary, okay, like that we are getting. So it is mainly used for binary classification where the output is either 0 or 1. Okay, simple terms, no difficult task. Now when we are learning about this logistic regression, we should know what is the behind the scenes logic, what is working when that logistic regression is being created or when it follows. Okay, what is the terminology behind that logistic regression? That is sigmoid function. Okay, so we will quickly understand the sigmoid function a bit, like how it is, what it is. Okay, I'm not going to explain it in depth because most of the concepts are cleared in the previous videos also. Okay, so here this sigmoid function is there. Okay, y equals to 1 and divide by x means the predicted probability it is going to show. Okay, next we have a1 and a2, those things are intercept and slope. How to calculate those things, that also I have told in the previous video. Okay, and e's value is what is there, it I have mentioned over here. Okay, 2.71828, that is the e's value. Okay, so we have to simply work with this formula. Simply this is going to follow, this is going to be followed by that model, and then it is going to give us the outputs. Okay, give us those answers in the binary forms, that is 0 and 1 form. Okay, don't think much about it. We are going to create one model, okay, and then we'll understand it in the depth, like how we are getting outputs. Okay, but which function it is using? It is using sigmoid function. The behind logic of the logistic regression is with the help of this sigmoid function. And how is this sigmoid function? Okay, you can see over this. Now let's start creating our model. Okay, so open up your Jupyter notebooks, give it a names, load those libraries, and then we'll start. So first things first, what we have done, we have summoned the machine learning gods, okay? Scikit-learn, NumPy and Pandas. These will help us load data, split it, and most importantly, train our logistic regression model, okay? In those, we are familiar with NumPy, Pandas, Matplotlib, Seaborn, okay? From Scikit-learn, we are taking model selection, what is train, test, split, how it works. I have explained that. Logistic regression, you're going to see in this video. Confusion matrix, accuracy score, classification report, these terms I'm going to explain a bit by bit, okay? Now, as we have loaded the libraries, we need data set to work with. Here also, I am going to create a dummy data set, okay? Data set by myself only, or you can also take any of the CSV files or any of the external data set you want, okay? If you are working with. For right now, our main purpose over here is understanding. And for understanding, if we take a bit small data, then it will be clear, okay? First, we can work with this small data, and then we'll try to swim in the ocean, okay? So let me create the data set and I'll explain it. So here what I have did is I have created the dummy data set, okay? In that, what is there? I am having the count of if I am getting any mail, and in that I am how many links are mentioned in that mail, okay? Suppose you are getting a mail and in that there are two number of links. Number of links means how many number of links are present in that mail. Next to that, how many capitalized words are being used, that is mentioned, okay? That count we have to take, and if there is, then is spam or not, it will going to detect, okay? If 2 is there, then yes it is. If 5 is there, then yes it is. If like that, it is being categorized, okay? So we have given 20% of the data or 30% of the data that he will understand when we will split the data into train, test, split, right? That time we can understand that how much data we are giving for machine to learn. Next is that I have stored it in the df, okay? For to data, I have converted it into df data frame. I am printing it into data frame, okay? You can see this. Let's do one trick. You can see if I change it into series in Pandas, as we know, we are having data frame and series, okay? So here you can see how this data is being printed over here. We don't want that, okay? Number of links, okay, this much, but we are not getting a clear understanding with this data. That is why data frame is used, okay? And then df.head, we know what it is doing. It is showing some of the part of a head, right? No, it is going to show the first 5 rows or first five rows of our data, okay? If you want to mention any number, that how many numbers of rows you want to see, then you can mention it over here. Simple data is not, no complex things are over here, okay? Until now, it is very clear that how we are working, okay? Next, we are simply going to visualize it now. So now let's visualize this, okay? I have created this visualization, you know, from Seaborn, I have took scatter plot, then for X, I have assigned number of links, and Y, I have assigned number of capitalized words. Hue, third variable I have took is spam, okay? You can see blue dots are there, then it is 0, means there is not spam, and if 1 is there, then it is spam. So you can see how our data is scattered, okay? We have spam mails also, and we have not spam mail also, okay? Data, df that we have did, then title and show, we are familiar with it. This is a scatter plot, we have created it, okay? Number of links, number of capitalized words, it's spam. This is hue, we have created, okay? You can already spot patterns. The spam messages have more links and more capitalized letters, okay? Spammers really love caps lock and hyperlinks. Now, as machine needs some of the data to work with, and then it can understand, and then it can follow that pattern, right? So we have to split some of the data. Whatever data we are giving, we have to split that data, and we have to tell that learn these patterns, learn whatever insights are there in this data, and then work with it. So we have to assign X and Y. So let's split our data. So now we have splitted our data, okay? You can see this X is over here, Y is over here. For what values I have assigned to X means like independent variables, these are, okay? The values which I have assigned to the X, those are independent variables. Here also there is independent and dependent variables, okay? Don't forget those things. So here what is there? Number of links and number of capitalized words. You have to understand this, means I am telling machine that you have to understand these things, okay? And then in Y, what I have stored is spam or not, means like this is the dependent, okay? If there is in the number of links, in the mail there is number of links or capitalized words, then it is going to be categorized, right? First, so a spam variable has to see those first number of links and that variables, right? That columns, right? So these things are there. We have targeted we have categorized independent and dependent variables. Okay, next what we have did is trained test split, taste test, you remember? So xtrain, xtest means some of the data to training and then test within that data, then some of the data for the training and test on that data. Okay, so we have to do this thing. Then train test split, how we are writing, what we are want to split for testing and training data, we want to split x and y variables. So we have given those. Then how much size, like how to categorize that, what is the test size and what is, means how much data we should take for testing and how much data we should keep for training. How we are going to do, we are going to give that to the machine with this test size. Test size we have mentioned 0.3, means 30% of the data is going for testing. Okay, sorry, training. 30% of the data is going for training. Okay, and what this random state is there, 42 we have mentioned, but it is not like it should be there. Okay, means now as we have data, okay, it starts from 0 1 2 like that, it is starting. Okay, consider this thing. Okay, and whenever we are splitting the data into some 30% and then rest of the 70%, we are splitting this data, right? But it should not be repeated within that, like it should not be shuffled. That is why this random state we have mentioned. Okay, it should be like within the order only, and then we can give that data. So like that, that's random state is mentioned over here. It is not that much important, but we have to mention it. Okay, now what we have to do is we have splitted the data. We are knowing now what is x is there, what is independent and what is dependent variable is there, all the things like libraries and dividing the data in order and all the things we have done. Now here comes the superhero of this model. Okay, which model we have choose, that we have to mention over here. So now our time is that we have to tell it model selection. Okay, in simple words. So as we were learning about logistic regression, so we are telling that this is logistic regression and fit that data within your conditions. Okay, it requires means like calculation requires, right? It's according to sigmoid function, it is going to adjust all the things and then it is going to do the classifications and calculations and all the things whichever it is requiring. Okay, we have given the data, we have splitted the data, we have told that this much data take for your training, this much data take for testing. Okay, so like that we have given the things. Now it's machine's work that we have also told that I want results with this model, logistic regression I want results with, and then fit it all according to your needs and then give me the results. Okay, now next part what it does, now we have given the model is being built, we have selected, it is fitted all the things according to its needs, right? It is all been adjusted. Okay, now next, what if this model is correct or not? This question arises, right? We need testing, so that is only the phase now it is going to be make predictions. Okay, so like that we are getting. Now here comes these three terms, that is confusion matrix, accuracy score and classification report. Okay, so let's understand these things in simple words and then we'll come again over here and then we'll understand this. Okay, but see first how is this confusion matrix. Okay, in confusion matrix we have true positive, true negative, false positive, false negative, like that, like those things are there. Okay, accuracy score is there, how much it is, 1.0. okay, this is there. In classification report it will tell us precision value, recall value, F1 score, support, and these things are there. Okay, just keep in mind that these terms are there and I'll explain these things in simple words. Okay, so what is confusion matrix? And a simple definition is that confusion matrix is a performance evaluation tool for classification models. Okay, it is a table that compares the actual values with the predicted values to show how well a model is performing. Now as we are in the testing phase, so that is why this confusion matrix is there. Okay, just remember in the confusion matrix we have matrix. Okay, there we have actual and predicted values. Okay, based on that this confusion matrix it is going to classify. Okay, so here's what the matrix tells us. Okay, true positive, model said yes and it was yes. True negative means model said no and it was no, model was right. Okay, false positive, what happens? Type 1 error, model said yes but reality was no. And false negative, type 2 error, this is model said no but reality was yes. If we want to take any real life example, then let's say you are building a spam detector. Okay, now as we are building a spam detector, so let's take that example only. A spam email marked as spam, it is true positive. Okay, a normal email marked as not spam, it is also true negative. A normal email wrongly marked as spam, false positive. A spam email missed as normal, false negative. Now you see every model mistake has the real world consequences. Now there are some of the matrices from the confusion matrix, right? We saw that things, right? When we get the matrix, how do we use it? We have accuracy in that. True positive plus true negative divided by total predictions. Okay, it means that how often are we right? Okay, let's understand it there only. Matrices from the confusion matrix, that is accuracy. Okay, this accuracy is there. Accuracy, it has been calculated by true positive plus true negative divided by total predictions. It means that how often are we right. Next is precision. Okay, that is true positive divided by whole true positive plus false positive. Okay, it's like when we say yes, how often are we correct. Next is recall. Okay, true positive divided by true positive plus false negative whole square. Okay, so this is recall. Okay, it's like of all actual yes cases, how many did we catch? And F1 score, it is like 2 multiplied by precision into recall divided by those things. Okay, the balance between precision and recall, it is known as F1 score. Only accuracy score can also tell us most of the things. Then why we are not just using accuracy? Okay, it's the trap of the accuracy. Now I'll explain this with an example. Okay, imagine 95 out of 100 people are healthy. You build a model that always predicts healthy. It's 95% accurate but useless. It never catches the sick people. That's where precision and recall comes in, especially in medical fraud or crime detection. Now let's understand what this classification report is. A classification report is like detailed feedback from your classifier. It's not just like good job model. It actually breaks down how good the model is at classifying each class. It's the part of supervised learning, especially for classification problems like spam detection, fraud detection, or disease diagnosis. So now these terminologies are clear. Okay, what this confusion matrix is. So this is how confusion matrix is. Okay, actual values and predicted values. Okay, positive 1, positive 2 means like true positive, true negative. Okay, these things are there. True positiveness, true false positiveness. Like it will tell us that whether we are actually faking any of the scene or faking any of the illness, or it's really an illness, like that things it can show us. This confusion matrix can show us. Okay, this is the example of how confusion matrix looks. Okay, and rest of the terminologies of the confusion matrix we have learned. Okay, so what is classification report, what is precision, what is recall, all those things are now clear. Okay, so let's move further in our logistic regression. Now let's see if a model can perform accurate or not. Okay, let's test it live. If you get it 2 links and 3 shouting words, it says yep, that's spam. Let's run this. This is the final step of our model. Okay, now you can see we have got the output 1. 1 means it is spam. Okay, means what are the inputs we have given? 2 and 3 means like number of links are there 2 and capitalized words are like 3. Okay, so what it has classified? It has classified it as spam or not spam? Yes, it is a spam email. Okay, so like that the classification is done. So logistic regression isn't actually about regression. It's a classification model. Okay, now here this is there. Okay, there is one more file I have created of this only, this mini project only I have created, but there is some of the different things that is present. Okay, I'll show you that quickly. Here same project is there. Okay, libraries, then data set, same data set I have took, then visualizations I have made. Okay, then we have given this logistic regression model. Okay, here it is GUI based. GUI means graphical user interface based. Okay, means like now it is going to show us what is spam, what is not spam, those things are there. Okay, but when we will execute this, you will see I have to run it from above. So now I have executed it. You will see the output. This is the output of that. Okay, so spam detector, it has been created whole GUI. This is graphical user interface. Okay, means it has been created visually appealing. Okay, that only simple output like yes or no, like that we were getting. Okay, so same we will pass here. Number of links, there were 2 and capitalized words were 3. Okay, even though if we pass different values, then also we are going to get the results. So it was spam, right? Here also, and when we will come in this predict, it's a spam. Okay, so next if we'll change the values, like there are no number of links and no capitalized words, then if we'll predict, then it's not spam. So like that it is being categorized. So this is the different terminology. Same project is there, but just I have added some of the interface to it. Okay, graphical interface to it. Okay, that is with the help of GUI. If you all want to learn those things also, you can comment in the comment section. I can make those things also. Okay, otherwise I'll explain this project, or just that GUI part I'll explain. Okay, so now most of the things we have covered over here. Okay, like what is logistic regression, we have built a simple project. Okay, spam versus not spam, you have got idea of how we are creating, how the model is learning, what is behind the scenes logic going on, right? You know, when we started this video, classification might sounded like a textbook term, buried somewhere between confusion matrices and sigmoid function. But look at you now. You just journeyed through the binary logic, multi-class decisions, and even braved the wild land of multi-labels. From zeros and ones to choices and changes, you have leveled up. This isn't just code, it's intuition, insight, and a little bit of algorithmic magic. So the next time your playlist reads your mood or your phone unlocks with your face, smile a little, because you know what the spell behind the sorcery. Don't stop here. There's a whole world of data stories waiting to be told. And if you're down to learn them with me, hit the subscribe, join the tribe, and let's decode the future together. One model at a time. See you in the next one, Data Warrior. Until then, keep asking questions and keep training your brain. Hello and welcome back. Training a machine learning model is kinda like parenting in the digital age. Too soft, the model flunks like it skipped classes. Too strict, it crumbles like a student at a surprise viva. Today, we are diving into the drama behind underfitting and overfitting. Why a model acts like a clueless toddler or a stressed out topper. And guess what? We'll fix those model tantrums using tools like regularization, cross-validation, and the avengers of machine learning, that is assembled learning. Oh, and yes, we will meet the nerdy legends like Guinea index and information gain, fighting for the best split in the land of decision trees. So buckle up, future data scientist. This is gonna be one spicy bite-sized journey. Let's go. First things first, what is underfitting? Underfitting happens when your model is too simple. It doesn't capture patterns. It's like trying to explain a complex novel with just emojis. This can happen when you use a weak model, like trying to fit a straight line through a curvy dataset. Or if you stop training too early, like dropping out of college after 1 week only. How do we fix this underfitting? To fix it, we try a better model, give it more training time, or feed it better features. Think of it like tutoring. Sometimes the students just needs better notes. So next we will learn about overfitting. Now meet this overfitting. This model is too smart for its own good. It memorizes the data like a parrot, but learns nothing. It's like during training it's a rock star, but during testing it crashes and burns. Now what this generalization term is, it refers to the performance of the model. Now whenever we are giving any cleaning data, passing the model, okay, fitting that into that, and whenever we are passing the some of the data for model to learn, then how well it is being trained, okay, that we can perform it by giving it some tests, right? So what tests are those, and what is the output result that on the unseen data, if that model is performing good or not, that term is known as generalization. Okay, next we will know about regularization. Okay, regularization helps us tackle high variance and prevent overfitting by adding penalty term to the model's loss function. Now let's break it down with two major types of regularization, that is L1 and L2. Okay. L1 is known as lasso. Think of lasso as a super tight elastic band that pulls some features all the way down to zero, like cutting unnecessary threads from a tangled sweater. Lasso is great when you suspect only a few features matters and you want to eliminate the noise. Next is ridge, L2. Ridge is like a gentler elastic band. It doesn't kill features but it pulls them towards zero, reducing their impact but keeping everything in a play. If you want to shrink your model rather than delete features, then this is your go-to option. Now let's learn the next term, that is cross-validation. It is another secret weapon against overfitting. This is like running your model through a series of tests, each with different data sets, to make sure it's ready for anything. No more one and done mistakes. So what this cross-validation actually is, cross-validation is a model evaluation technique that helps us better understand how well a machine learning model will perform on unseen data, that is, data it has been trained on. Or instead of splitting your data set just once into training and testing sets, cross-validation divides the data into multiple smaller subsets called folds. This model is trained on some of those folds and tested on the remaining ones. This process is repeated several times and the results are averaged out. The cross-validation techniques gives us a more reliable estimate of a model's performance, and it's especially helpful when the data set is small. If you want to take any of the example, then imagine you are baking cookies and testing only one out of the whole batch to see if they are good. Not enough, right? Cross-validation makes you taste a bit of every batch before giving it a thumbs up. Now let's learn the next term, that is assemble learning. Assemble learning is a method where we combine multiple machine learning models, often simple ones too, to create a strong, accurate model. The simpler models are called weak learners, but when we combine them smartly, they become way more powerful. Like teamwork. Team is better than single person, right? The main goal of this assemble learning is to improve the accuracy, stability, and generalization of predictions. Okay, it helps us to fix the problems like overfitting, underfitting, and low model accuracy also. Now we know what underfitting is, what overfitting is, when a model is too overconfident, when a model is not that much good in performing, it has not understood the things. Those overfitting, underfitting, and if the accuracy is not, then in that cases this assemble learning will help us. Okay, if you want to take a real life example, then cricket match, one commenter might say that the pitch is good for batting while other disagrees, but when you bring into the panel of experts, suddenly the predictions became more balanced and reliable. That's assemble learning. Now let's learn what are the different types of these assemble learning. There are two major types of assemble learning techniques, that is bagging and boosting. These sounds like boxing moves, I know, but they both are very strategic approaches in machine learning. So first learn about this bagging. Bagging, it's a short form for bootstrap aggregation. It is when multiple models are trained at the same time in parallel, okay, using different random subsets of the original data. We divide the data, okay, and then we create subset and then we train a model. So using different random subsets of the original data, each model makes its own different predictions. And the final result is calculated by combining all of those predictions, often using a majority vote for classification or an average for regression. So majority, here what thing is important, that is we are creating subset of data, we are creating different models parallel to each other, okay, and then all the results we are combining, and with the help of majority vote for classification we are making final decision. This technique is especially useful when your model is overfitting, okay, that is it's performing well on training data but poorly on the new data. So bagging reduces the variance in the model, making it more stable and generalizable. If you want to take any of the common example of bagging, that is random forest algorithm. What this random forest is, I'm going to explain it in detail, okay? If we are getting time in this video, then I'll explain it in this only. Which uses many decision trees. So what this decision tree is, that also you will understand in this example, in this video only, okay? Just have some patience. Each tree is trained on slightly different piece of the data, and in the end all the trees vote on the final output. Just for right now, consider it as a tree, okay? Tree is having branches, nodes and everything. So here how we are going to convert that into data, how we are going to understand the thing related to our data or to machine learning, we will see those things. Right now what I want to do is I want to clear all theory first, whichever is required for models and building them. So I'm explaining the theory right now. So in bagging, a common example, that is random forest algorithm. Keep this in mind, okay? You will need these things. Next is boosting. This is on the other hand. Boosting is all about learning from mistakes, just like life. Here, models are trained one after the other, and each new model tries to correct the errors made by the one before it. It's like elder child is learning, making mistake, and then he's getting punishment, and then the younger gets aware about it, right? This technique focuses more on the data points that were predicted incorrectly in previous rounds. So the model becomes more accurate with each iteration. Boosting helps reduce bias and is best used when your model is underfitting or failing to learn patterns in the data. So powerful examples of this boosting are like, it includes gradient boosting and XGBoost. What these all are, we are going to learn, okay? For right now, in this example, I think I'll cover decision tree and random forest, okay? Let's see up till when we have time, we are going to complete it. Now let's come into some of the real life examples, okay? Let's bring it back to school for a second. Imagine you wrote an essay and it was graded by just one teacher. That teacher might be in a bad mood, or maybe they really love Shakespeare's and you didn't quote him even once. Unfair, right? Now imagine your essay is graded by a panel of teachers. Each brings their own perspective and the final grade is an average of their judgments. It's fairer and more balanced. Assembled models works the same way. They take information from different models and make a final decision that's less biased and more reliable. So here what important thing is there, what is assembled learning? Assembled learning's types are bagging and boosting. In bagging we have random forest, in boosting we have XGBoost and those all things, okay? Now let's move further, that why we should use these assembled learning, okay? Because assembled learning techniques improve prediction, accuracy, handles messy real-world problems like are overfitting or underfitting, and is useful in everyday applications. From spam detection in your email to fraud prevention in banking to recommendation systems on your YouTube and Netflix. In short, assembled methods are not just smart, they are industry smart. So let's move on to our next topic, that is gradient boosting. Gradient boosting is a machine learning technique for classification and regression problems. Now what this classification is, what is regression, we know that all. It's a part of boosting family where the ideal is to combine multiple weak models, typically decision tree. Now decision tree only we are going to learn in boosting, so that is okay. Have some patience, then we will understand what decision tree is also. Into a strong model, okay? We are combining small weak models and then making a final strong model, okay? The gradient part refers to how it minimizes the loss function, okay, by taking steps in the direction of the negative gradient. Imagine you start with a dumb model, okay, that barely gets anything right. You're asking yourself again and again that where am I messing up? You know the errors, okay, that is known as residuals in this machine learning language, and train the next model specifically to fix those mistakes. Whenever we are making mistake, we learn something from that, and the next time we are not doing that thing. This is only life, right? So now repeating this process multiple times, each new tree focuses on the residual, that is errors of the previous one. Combining all the trees, you have got the model smarter with each step. Now what is advantage of this? We got high prediction accuracy, we handle missing values well, work with different types of loss functions also, we reduce biases and variances also. But there are also some of the disadvantages, okay? So disadvantages like it is slow to train, okay, if we are having large data sets. It is prone to overfitting if not tuned properly, okay, we need to make sure of overfitting and underfitting problems also. Harder to interpret than a single decision tree. Some of the real life examples are like credit scoring, spam detection, churn prediction, medical diagnosis, okay. What is this entropy? Entropy is a measure of uncertainty or impurity in a data set. Alright, data warriors. Let's say you are building a decision tree. You have got questions, features, and a burning desire to split stuff up. But how do you choose the best feature? You call in the legends, that is information gain and Guinea index, and let them battle it out. First in the ring, we will learn about information gain. This pranic uses entropy. Now what this entropy is, we have understood, right? Which is just a fancy word for the chaos. In our data, something is impure, then we will say it is chaos only, okay? If your data is all mixed up, yes, half no, entropy is high. But if you split your data smartly, entropy drops and boom, you have gained information, right? It's like cleaning your messy room. The more junk you sort out, the more info you gain about where your stuff is. Now there enters the next term, that is Guinea index. It is smooth and calculated. He doesn't care about entropy, okay? Here is all about misclassification risk. He asks, if I randomly assign labels, how wrong would I be? Lower Guinea, better split, less risk, more confidence. Both love pure, clean data. Both want this perfect split, but there's drama. InfoGain is sometimes biased toward attributes with many categories, whereas Guinea, it is less biased, but not always as mathematically deep. So now what this decision tree in actual is? It is a question. Now decision tree is a supervised learning algorithm, fancy name, okay, but it is simple logic. It is used for both classification like spam versus not spam and regression like predicting house prices. So now in the previous videos we were learning about logistic regression, linear regression, and we understood about their examples, okay. We were having multiple linear regressions also. Those things were there, okay. Now we studied each of them examples, okay, with small practicals, okay. We understood those things. But now here what this decision tree is doing, it is both the classification and regression terms, both are combining. We can work with this decision tree and we can gain the access of both of them, both of the classification and linear regression. So which one is better? Decision tree is, right? But we need to understand this decision tree also in depth, okay. So we'll learn this now. Now imagine it like a flowchart with yes or no questions. Each internal node, a question is there. Each branch, a possible answer. Okay, I'll show you example of decision tree only. So here you can see that this is type of decision tree, okay. This is we are going to split our data into, okay. So each internal node, it is a question. Each branch, it may be a possible answer, and each leaf, the final results like yes, buy the product, or no, don't buy it. So it's basically a choose your own adventure book for data. If you want to say any of the real life example, then let's say we are predicting whether someone will buy a phone or not. First question is their age over 30? Yes, cool. Next day, do they earn over 50k? Yes, great, probably a buyer. No, maybe not. And so the tree grows questions by question until we get an answer. There are some of the key terminologies that we should know about this decision tree, okay. We have root node, it is the starting point, okay. It is the trunk of our decision tree. Then we have leaf node, it is the final decision. No more splitting, no more drama. Splitting is done, okay. Basically the gossip that splits the group chat. We have branch, a path from one question to the next question. Decision node is there, okay. A point where question is asked, and we have pruning also. Now what this pruning is, we are going to learn it into depth, but still. Cutting out unnecessary branches like toxic friends in 2025. Okay, but why is everyone obsessed with this decision tree? Here's the tree. It is easy to understand, even if you are not a data nerd. It's like that one friend who can handle both a breakup and a group project, reliable, adaptable, and little dramatic. Okay, let me explain this pruning techniques a little bit. Trees can get too excited, okay, splitting left and right like there's no tomorrow. But too many splits, overfitting. So we use prune, claim things down. Pre-pruning, set limits from the start. Post-pruning, build the whole tree, then chop the weak branches. If we want to take any of the real life example of this pruning, then let's say we are building a model, okay, to predict illness based on symptoms like fever, cough, and fatigue. The tree asks, does the patient have a fever? Yes. Do they have a cough? Yes. Then probably they are sick. If no, maybe they are just tired of Mondays. Who isn't, right? There are some of the advantages of this pruning and disadvantages, okay. It is simple, flexible, there is no scaling needed, okay. It can handle complex relationships also, like and some of the disadvantages are like it overfits easily, okay. It's sensitive to small changes. It can get messy with the large data also and might be biased toward features with many categories. We still pair it with random forest or boosting, and it's basically Iron Man in the Avengers. So now project time, okay. So let's open a Jupyter notebook, create a new file, import some of the libraries, and let's start. So here what I have did is I have imported the libraries which we were needing, okay. So now what these libraries are and how we are importing, why we are importing them, this thing you all know, right? So we have took Pandas, then NumPy, then Matplotlib, Seaborn, and from Scikit-learn, that is machine learning's library, okay, we have took decision tree classifier, okay, from that plot tree also we have took. Then from model selection, it is for train test split. Now what this train test split is there, how we are writing it, we have learned it in the previous videos. Then from scikit-learn.matrices, we have imported accuracy score and classification report. These terms also we have learned in our previous videos. If you have some questions regarding them, then you can ask me in the comments, okay. Now why every time I am creating sample data sets? Because okay, I have explained data cleaning, okay, I have created videos on that, okay. If you have watched those videos, those were focused on that part only, that was data cleaning. Here what I want to tell is I want to teach you a decision tree, okay. So my main focus is going to be on that. So why I am taking sample data set? Because this data set is being manually created by me. So that is why there is no need of cleaning or organizing the things. Okay, I know what is there in the data, okay, how this data is there. So understanding and cleaning, these two steps are being skipped in this part because we have created the data manually as per our understandings, okay. And we also get the idea that how is data being created. So that is why I am always taking data manually only, okay. And these are the rough things, okay, these are not the actual data sets, but in real life we are going to take files, right, from different sources we are going to connect files. So what I have did is I have created this sample data set, okay. In that I am having age, gender, estimated salary, and purchased. Purchased means if they are buying it, then it will be 1 or 0, and if they are not buying, then it will be like that. So I have told over here that is. And purchased means what? If they, here I have wrote it in the comment also, okay. If 0 is there, then that means they have not purchased it, okay. And if 1 is there, that means they have purchased it, okay. It is just a sample data, no complex thing, okay. It is easy to understand also. That is why I am not wasting much of the time on data sets, okay. So that is why I am just creating sample data so we can understand things quickly. We can focus on the main thing, that is why, okay. So what is we are having over here, that is age, gender, estimated salary, and purchased. Then what I have did is I have created a variable, and this data I have stored in that variable, that is df, okay. And from that I have, in what type I have stored this data, that is data frame, okay. Then I am just going to print this sample data, okay. This is the sample data set, so I am just going to print this sample data. So let's execute these libraries, then this data, and then this print our data. So you can see this is the sample data, okay. In that I'm having age, gender, estimated salary, and these purchase things. In all we are having 15 entries, okay. If you want to see, you can see the information range index is there. There are 15 entries. They have been indexed from 0 to 14, okay. How much columns are there? We are having 4 columns, okay. Then see, now here there is no empty values, right. So this is good thing. Then data type is there, integer type is there, object is there, integer. Okay, here we can see data types. Okay, integer types of, we are having in 3 columns integer types of value, and object, that is characters, that is text, means here this male female, this column it is showing, it is having in one column we are having object type of data. Okay, simple clear things. If you want to understand your data a bit more, now as we have created it manually, so that is why I can just go directly with it. Okay, move further. So next what we are directly going to data preprocessing. Okay, we are going to learn data preprocessing. Now we are arranging our data, fitting our data into train, test and building our data so that we can pass it, splitting we should do, and then we can pass it to the model whichever we want. Now in this we are learning about decision tree, so we are going to pass for that. So done, this thing is done. Okay, we have misconverted that data, that text type data, object type of data. Okay, now what is there? Feature selection. Feature means like independent and dependent variables that we know what are there. Okay, so what we are going to do is we are going to take multiple values, and one thing, this purchase is a target in this thing, right? This is dependent on these all things. Okay, so these things, these age, gender, estimated salary, it will come in X, and this purchase it will come in Y. This is a target. Okay, defining X and Y, you can say that. Feature selection, you can say that. Okay, in short, these all terms are that we need X and Y, and based on that X and Y we are going to split the data, right? So that things we are going to do. So I'll quickly write train, test, split also, and then feature selection also. Okay, so now we have done this feature selection in X. This is our independent variable. So in that I have passed age, gender and estimated salary. Okay, clear this thing. Then what I have did is Y variable I have declared. Okay, Y variable, in that target what is there, purchased is their target, so I have passed it there. Then now we have got this X and Y, so we are going to split our data through the train, test, split. Okay, how we are writing train, test, split, we know that what it does, that also we know that. X and Y is their test size, it is means we are passing 20% of our data to machine. Okay, so that machine can test on that data, whatever it is going to learn, that the rest of the 80% data is there, which is for training, so it can use that data and learn the things. Then after learning we are passing that this percent of data is there, you have to test the things, you have to give your exam and pass that test. Okay, so 20% of data is there for the testing purpose. Okay, we have done that thing. Now next step is there, simple. Every time in every model there is the same steps are there till we are defining the model. Okay, so what now, and even though after defining the model we need what we need to do is, now that model is being trained. Okay, so what we have to do is we have to take test of that model. Okay, testing purpose is going to be, and then if it is going to perform accurate, then it is good. If not, then we have to again go in the previous steps. So model selection, now we are learning decision tree, so we will do with that only. So now let's see if our model is being okay or not. Decision tree classifier I have took. Okay, criterion, entropy and random state, you all know now what it is. Okay, then I have fitted into the X train and Y train. Okay, now let's execute. So decision tree we have took. Okay, we have told the model that use decision tree and learn the things. Okay, learn. Now let's test our model. So we have created this new variable, that is ypred, what is y prediction. Okay, and when we have passed the testing data to it. Okay, next now let's see evaluation. Let's do the evaluation things. Evaluation, what I wanted, that I wanted accuracy score and classification report. This report can help us to tell detailed information. Okay, that if it is performing good in actual versus predicted values, how we are going to get any differences or not. Okay, so that we can understand with this classification report. And accuracy, it is giving us 0.333, that type of accuracy. Okay, classification report, this evaluation, in that I have passed accuracy score, means I want to know the accuracy of our model. Okay, then I want classification report. In classification report we have precision, recall, F1 score, support, these all terms I have explained in previous videos. Okay, so we have got accuracy of 0.33. okay, infinite number is there. Then classification report, what it is telling is that for zeros we have this much values. Okay, for ones we have this much values. Okay, in a purchased, if there is 0, then precision is 0.50, recall is 0. All the things are there. Okay, support is 2. For 1 the terms are being given. Whereas accuracy, real accuracy, you can see that 0.33 and 3 support is there. Okay, macro average, weighted average, all the things have been mentioned. With the help of this classification report we can understand things clearly. If you all want a detailed reading of this classification report, means understanding how to understand classification report, then also you can comment it in the comment section. Okay, because I feel that this classification report you might have not understood in depth. Now let's see whatever things we have did up till now, are though accurate or not. Now let's make a visualization and understand things. Okay, so we are going to visualize a decision tree, and this is the final step. Okay, then we will understand that how to read the decision tree. Okay, what it is going to show in actual, that if this project is there, what it is telling us. Okay, here what I have did is in the final project we are going to solve the errors also whichever we are getting. Okay, here I am telling that how it is being created. Okay, here I am not going in depth for the accuracy. Okay, so here just our main motto is there, we have to understand the things, and in the final project we are going to work with all the terms. Okay, like if there are any errors, if in this classification report some of the things are not accurate, then we have to go back, then solve them, and again come how to read the classification reports and all the things. Okay, in the final project. So let's focus on here visualization. We know how visualization is there from Matplotlib. Figure, we have to figure what it will tell us. It will define the size of that figure, whatever visualization we are creating. Okay, you can increase it, decrease it. Okay, plot what we want, tree model we wanted, and as we are using Matplotlib only, so we have to give the detailed information. Okay, filled, it is true. Feature names are like X columns, classes, what we want to, what is a target, like purchased and not purchased is there, that is why we have given those class names. Also title, what it will be, decision tree. Now as we are building the project, that will they buy a mobile phone or not, so that is why I have given this name to this, and then plt.show, we know what it does. So let's execute this cell. So you can see this decision tree is being created over here. Gender, then it has categorized, means like gender is smaller than equals to 0.5. then what is this entropy? Entropy is impurity in a data, right? Then samples 12 is there, value for 8 is there, means like for a female, male, so like that it has categorized. Okay, and class, purchased or not purchased. If purchased, then true, if not then false. It is going, and then again it is showing some of the things, then again it is dividing it, then again, so like that it is there. Okay, this decision tree we have formed. Now how to read this decision tree, what we are getting from this decision tree, let's understand those things. So root node, we know root node is the trunk. Okay, means it is the starting one. Okay, so this tree starts by looking all the features and asking which feature splits the data best into zeros and ones. Okay, it uses a concept called information gain, we have known what it is. Okay, to decide which feature reduces the messiness of the data the most. Then we split the data into left branch, that is age is less than or equal to 35, then right branch, this age is greater than or equals to 35, like that. Okay, then each of these two groups now become a smaller data set. Again the tree asks which feature should I split this group on. So let's say in the left group it decides like estimated salary, okay, which is less than equals to 30. So like that this data is being splitting, it keeps doing this, checking every feature and continues to split until one of the stopping conditions is met. Now when does this tree actual stop? Because pure leaf, okay, this pure leaf is there. Okay, all examples in that node belong to the same class, that is zeros or ones. Max depth, we will pass max depth also. Okay, you can set a maximum number of split like 3 levels or 5 levels also. Minimum samples, if too few samples are left it may not split further. And if no gain, if the split doesn't improve information gain, then it will stop by itself only. Okay, now let's break it down, that this estimated salary is all like, okay, all the blocks. Okay, all the nodes we will say of this. First we are getting this estimated salary. Okay, then entropy is there, then samples, value and class. Now let's break it down in detail. Estimated salary, first thing, that is feature used to split. Okay, it is the feature that is used to split the node. Then entropy, how mixed the data is, like 0 is there then it is pure, and if 1 is there then it is completely impure. Okay, so it has not given proper 0 also and proper 1 also, right, in some of the cases. So here entropy is 0, entropy is 1, like that. Okay, here also entropy 0 is coming, sample is 1 is there, means no more thing is there for splitting. Okay, samples, how many data points reach this node, In this, there are two nodes which have reached. Okay, there are two data points which have reached this node. In sample, here are three. In samples, you can see only one node and only one node. Okay, means there is like one value is there, one person is there from male or female. Okay, is purchased and one value is there. Okay, value means like how many zeros and ones. Example, 6 not purchased is there, and then 4 is purchased is there. Okay, so here you can see values is there 0 and 7, means 0 was for not purchased, right, and 1 was for purchase. So 7 are there, those who have purchased. Here 4 are there, those who have not purchased. Means like if their salary is 27,000, okay, or equals to or greater than, like that is there, then 4 of them are like that those have not purchased, right. So majority is not purchased, so class is this not purchased. Okay, then it is dividing further, like that is there. Then class what is telling, it is predicting the outcome, okay, of that node, majority vote. Here also what is there, majority vote means most of them have purchased. Okay, this is coming into this class. Here if you can, this number is higher, so not purchased is here, also not purchased is there. Here both are equal, so not purchased class, it has been divided because some of the factors are also there. Okay, above factors are also there because this is highest here. Then here what it has done, here this purchased one is there and here not purchased one is there. Okay, so this is how we are reading a decision tree. Now let's take some of the real life examples so that you can understand it. We are taking this only example, that mobile phones example only. If the person is about 35, yes, do they earn more than 50k? Yes, okay, very likely to buy. And if no, then probably not. Maybe sometimes a person wants, person don't want, like it depends on moods or even the conditions, right? That's literally how a decision tree thinks. It split people into categories using yes, no, gates until it makes a prediction. Okay, so what is advantage and disadvantage of this decision tree? Let's discuss some of the advantages. Okay, it is easy to understand. Okay, visual and interpretable. Okay, we have visualized it. Okay, and we can understand things in better now. Okay, there is no need for feature scaling. Okay, let's discuss some of the disadvantage of it. It can overfit if to depth. Okay, not great with small changes in data, unstable. Okay, it is less accurate compared to assemble models like random forest. Here is a tip for you all. Okay, to avoid overfitting, we can prune the tree, cutting off unnecessary branches like trimming a bonsai. That keeps it simple and general. So what did we learn today? Your model isn't just a bunch of numbers, it's a vibe. Treat it right and it won't just memorize, it'll understand. Whether you are battling underfitting like a bored student or overfitting like an anxious perfectionist, the key is balance. Throw in some regularization, test it with cross-validation, and let's assemble models, run the show like a talent squad. And when it comes to decision trees, split smart. Prune the noise and let the guinea and information gain do their dance. Got questions? Drop them in the comments like hot potatoes. Don't forget to like, subscribe and hit that bell so you don't miss anything regarding this machine learning series. Until next time, stay curious, stay caffeinated, and may your accuracy always be high and your loss delightfully low. Ever wish your model had a second opinion or like hundreds of them? Welcome to Random Forest, where we don't trust one tree, we build whole forest and let them vote like it's democracy in action. Today we are diving into the ultimate tag team of machine learning, bagging, bootstrapping and trees that split smart. By the end of this video, you will see why Random Forest don't just predict, they collaborate like legends. So grab your chai, open that Jupyter notebook and let's grow this forest together. Now first things first, what is random forest? Random forest is a popular and powerful machine learning algorithm which is used for classification as well as regression tasks. It works by building multiple decision trees and combining their results. Hence its name is forest. For classification, what it does, it takes majority of all the trees. Okay, we are having one decision tree and Based on that tree, here what it does, it creates small decision trees, not just one but many of them, and by taking the majority it will take a final decision. Okay, that happens in this random forest. For regression, what it does, it takes average. As in regression we are getting a number, as in output we are getting a number, so therefore what it does, it take averages of their predictions. Think of it like asking a panel of experts for their opinions instead of relying on just one person. So now this random forest is okay, but why was this random forest needed? Before random forest, we had decision trees, right? We learned that in the previous videos also. They were simple and interpretable, but prone to overfitting. Now we know what overfitting is, right? Overfitting means a model performs great on training data but flops on unseen data. We needed something more robust, accurate and generalizable across datasets. So there comes this random forest. It uses an assembly method, training multiple trees on random subsets of data and features to solve the overfitting problem. So now, okay, this random forest is there, okay, but how does random forest works? So first what it does, bootstrapping. It creates multiple subsets of the training data by sampling with replacement. Okay, then decision trees with a twist. For each subset, it grows a decision tree, but only consider a random subset of feature at each split. Then individual predictions. Each tree make its own prediction, right? Now as we are creating different trees, we are getting different answers also. Okay, then what it does, it combines the result. Use majority voting for classification or averaging for regression. Okay, this randomness in data and feature selection adds diversity, reduces correlation among trees and boosts performance. Okay, so now overall this was good. So what are the advantages and disadvantages of this random forest? Let's discuss them. Some of the advantages of it are like it's a high accuracy, works for both classification and regression. It handles missing data, fills the blanks like a pro. Okay, then it resists overfitting also. Randomness ensures it learns patterns, not noise. Then it scale with big data, handle high dimensional data sets with ease. Okay, feature importance is also there. Okay, it provides feature importance insights, tells you that which feature drives the result. Now these were the advantages. Let's discuss some of the disadvantages of it. It is less interpretable. Okay, every forest or every model is going to have its pros as well as its cons. So it's less interpretable means, unlike a single decision tree, what it does, it's a bit of black box. Means hard to follow hundreds of decisions, right? So there are many options and we get confused. It is computationally heavy. Training and predicting with many trees takes time as well as resources. You have to agree with this, right? And not real-time friendly. What it does, its lower perfections makes it less ideal for fast-paced systems, right? So now let's create a simple project of this, okay, so we can understand this random forest better. Okay, we will create this in Jupyter notebook. What we are going to do is we are going to create a product recommendation system. Okay, what its requirement is like, we have to build a machine learning model, okay, using means like random forest only we are learning, so we are going to use that. And that random forest machine learning model should analyze users and predict whether that user will buy that product or not. Like that we have to do. And what the goal is, its goal is to enhance a recommendation system and boost user engagement. Okay, and also it will boost our sales also. So this is the type of requirement we have to perform. Okay, so let's go into a Jupyter notebook and we will start creating this random forest mini project. So here I am in my folder. What we are going to do is we are going to create a new file, quickly give it a name, okay, and import our libraries. So here what I have did is I have imported libraries. Okay, we all know Pandas, NumPy, Matplotlib, Seaborn. Okay, Scikit-learn also we know. From Scikit-learn we are taking some of the things, like from Scikit-learn we have took what assemble. Why we have took? Because it's subcategory of that, right? Assemble methods. Then from that what we have did is, from that we have took this random forest classifier. Okay, this is the model which we are going to need. Then model selection, it is for train test split. Means you should understand that till train test split the things are going to be similar. We need data, then we need x variable, then we need y variable, means like independent dependent one, right? If there is some data cleaning part needed, then we can do that also. Okay, next from matrices, what accuracy score and what is confusion matrix, we have learned those things in our previous video also. Based on this accuracy only we are going to see that how a model is performing, right? What is the final score of our model, we are going to get that thing. Next comes is data set. Now all these things on what we are going to perform, that is data. So that data also I have created manually because I want to focus on random forest, and as I have created this data manually, so what happens is I know what is there in the data. Okay, so that is why, and I have took small data only so we can understand the things clearly. What is there in this data, we have to understand the things. There is age. Okay, see, now any person who is going to purchase a thing, is going to purchase a product, then we are taking his age. Okay, then his income level. Okay, if income level is low, medium, high, that thing we have categorized. Okay, next is browsing time. On a website, if that person is browsing for 5 minutes, 10 minutes, like that, this browsing time we have took. Okay, how much time they took, so we can understand this thing also, and based on that then we are giving them the products. Okay, what they are searching and all those things also we could have took. Then clicked ads are coming between. Okay, means like we are on the screen and we have seen some of the ads also sometimes pop-ups, right? If we click those ad or not, like that. Okay, if 0, what it is telling, that person is not interested, they have skipped the ads. As well as if 1 is there, means that person has interest in that ad. Okay, means that person is going to see that product. So like that we are creating a thing. Simple. If you want to see the data, you can see it. Okay, this is our data. Okay, we have created a data. Now next what we are going to do is, after creating data set, what is needed, we need to convert categories to numbers. Now what is in the category over here, that is income level. Okay, machine is not going to understand this low, medium, high. I'll show you when we will perform the model, and that also I'll show you one in the last. Okay, so now here is what is the problem, that we have this income level which is in category and we want it in the numerical form. So we are going to convert first that, and then next, and then independent variable and then dependent variable. Okay, so how should we convert these? We have to, of course it is in data, so we have to take data. Okay, then what we want to convert, income level, right? So take that name, we took this income level. Okay, now what we want to do is we want to convert it into data. Okay, so again income level, we are not deleting anything. Okay, you remember map function? Okay, we have this map function. How we are using it? We are using it to map the things. Okay, so low is there, what we are going to do, this low is there, we are going to assign the value 0 for this low. Means if in our income level there is low, this category is there, then what it is going to assign, it is going to assign 0 to that. Okay, next we have is medium, right? For medium also what we have to do is we have to assign a number for that medium also. How we are going to assign that number? So of course from low, medium is a bit of high, so that is why I have assigned 1 to it. Then next come high. See properly what is the value in the income level. Okay, if L is capital in low word, if L is capital, you have to write L capital because it is case sensitive. Okay, Python language is case sensitive, you have to keep in mind that thing also. So high, for high what we are going to give, number, whatever you want to give you can give it, and you can then you have to keep in mind that what value you have assigned to it. Okay, closing brackets are there. Okay, everything is clear, just execute and see if you are getting any error. No, we are not getting any error. Okay, so what we have did, okay, I have not mentioned this. Oops. This is clear. Okay, model needs numbers, so we have given numbers by using map. Okay, we have mapped low value to the 0, we have mapped medium to the 1 and high to the 3. Okay, sorry, high we should give 2, right, because we have already given 1. I want to keep it in sequence, that is okay, I'm changing it. If you want you can keep that only, but you have to keep in mind that you have given it 3. Okay, now let's split the data, okay, into dependent as well as independent variable. Okay, features we are saying it as target feature, okay, like that. All the target and features we are going to tell. Okay, I'm not going to write what the step is called as. Okay, now you all are mostly familiar with that. So data, okay, from data which columns do we want to take? Now see, I am taking multiple variables, that is why I am taking 2 brackets over there. Okay, I want to take age also, I want to take, because these factors, on these factors that add is going to be clicked. Okay, so like that I feel, so that is why I'm going to take. Okay, income level also I will take. How is that income level written? Okay, so this income level I took. Now as I have converted it, why I have converted it? Because I need that. Okay, so that is why I'm taking this. So now next was browsing time, right? So let's take that browsing time we took and then close it. Okay, it has already been closed. Okay, now let's define for y data, and from data we have what? Clicked add. Clicked add was a target. Okay, as I am passing just one variable, that is why I have given just one bracket. You can execute it and you can see. Okay, so we have understood what are independent variables are there and what are dependent variables are there. Now what we have to do, we have to bring our train test split. Okay, we are going to write it into train test split. So I have splitted the data. Okay, you can see this x train, y train, all the things I have took. Okay, x variable is there, y variable is here. You can see test size what I have mentioned over here as 0.3, means 30% data I am going to give to the machine, to the model, to test. Okay, keep this in mind, to test I am going to give. 70% of data is there. What it is going to do is it is going to be go to train the data, train the model. Okay, model training is going to be on the 70% of the data. Okay, so far all good. Now our next step is going to be, every time it is common step, we need model. Okay, model is there. Okay, data we have separated, splitted the data. Now what we are going to, random forest classifier, we are working with that, so we have took this model. Okay, now here you have to mention some of the things for this. So you can see I have passed the variable, this model variable is there. Okay, random forest classifier I have selected. Here also we have to mention this random state and n estimators we have to pass. Okay, we have to pass that value for that. Then what I have did is training data, testing data. I have 70% separated and 30% I have splitted the data for training and testing. Okay, so I have fit that data into this model. Okay, for training and y training is there. Okay, just for training, that 70% data I am giving, I have made fit that data into this random forest classifier. Okay, why we are using this random forest classifier with 10 trees and train it on our data. Now next step is going to be making predictions. Okay, so we need to make predictions. For that what we do, so far so good. After this what I have did is y prediction is there. Okay, from that what I have did in that means like whatever there is there in testing data, with the help of that I want to make predictions. Okay, so the new values which are going to be predicted, those are going to be in this y pred. Okay, in this variable. So after that we have accuracy and confusion matrix. Okay, it is the comparison between actual values versus predicted values, so that is why y test is there and y pred, because testing data is there which on which machine has given tests, right, and whatever the predictions after giving that test it has done, it is in this y pred. Okay, so accuracy core is there, confusion matrix is there. When I printed accuracy I got 1.0. accuracy means our model is performing 100%. Okay, so that is the thing. It might be the problem of underfitting. Okay, because a model, it's rare, it's too rare that a model performs too good, but now as data was created manually, so that might happen. Okay, there are chances. So I have created this visualization. Okay, from Matplotlib figure I have mentioned the size whichever I wanted. If you want to increase a bit then you can increase it. Okay, I have kept it small only so you can see Then heat map I have created. Okay, now you all know what the all these things are there. C map is there, X text, Y links, labels, all the things have been cleared in the previous videos also. So title, X label, Y label, okay, confusion matrix is there, is for product recommendation. Okay, we are making that thing, so that is why. And this plt dot show, it is there. Now what we are going to do is we are going to test this on new data. There is let's pass some different values to it. Okay, so let's see if it can perform on that or not. So far so good. What we have did is created a new variable. Okay, data frame we were using. Okay, when we were creating the data in data frame we have took, okay, age, income level and browsing time. Now why I have not took clicked add over here? Okay, you can see how our data was. Okay, in same kind I have created, just I have passed different values like these. Okay, clicked add was a target. Okay, so that is why I have not, because that was only the thing which you want to predict, right? So that is why I have not passed the values for that. I have here different data. Okay, 3 persons data is there. Okay, age is there. Okay, I have mentioned income level, medium, high. Okay, sorry for the spelling, but we are going to get error for that. Okay, I'll clear it. Okay, fine. Then browsing time I have mentioned. Okay, then new prediction I have created this new variable. In that model I have told, means whichever model I have created, I have told that model, so take that model. Okay, this new data wala variable pass to that and then print it. Okay, print for unseen data. Now let's execute this. Oops, we got error, and what it is telling, could not convert string to float. Okay, medium. So in this line only it is giving us error. Why this error is there? Because when we created a data, what we did first thing, we converted categories into numbers, right? We mapped this thing. So this thing we have to do again. If we will copy just this thing, okay. Now when you are working with your projects and all the things, you should understand the things that what we have did, what which thing. Okay, so you can just paste it over here. So now let's see, just paste it. Okay, again, but it is not data, right? What you have to do is you have to mention here new data. Okay, new, sorry, new data, and here also. And then if you will execute it, you can see we have got predictions for unseen data, that is 1 1 1. Okay, what does this mean? Okay, when we test a new customer, we are getting the output like 1 1 1, right? Means the all three predictions, all three persons may be interested in the product. Okay, that is why we have created this. But now as you see, you this converted categories into number, you are taking all the time. This is not needed, right? We were telling that we are having a data by our own, we have passed these values by our own. So what we can do is, for medium we know what value is there, it is 1, then 2, then 0, right? So what we are going to do is 1 2 0. I'll pass this only, and if I execute it, then also we are getting the same answer. So it depends like how we are prone to these things. Okay, how much we have spent the time on these models, we are building these things, so it depends on that. Okay, what we should learn from this, we means what are the, okay, let's create summary. Okay, I'll tell summary of this. Okay, what key takeaways are there? Okay, we prepared data for this. Okay, used random forest classifier, then we evaluated model for accuracy, and then made predictions on the new data. So this is product recommendation mini project, you can say. Okay, so what is this support vector machine? It stands for support vector machine that we have got. Okay, it is a supervised learning algorithm. Okay, it is mainly for classification. When we were using random forest, it was for regression as well as classification, but here this is support vector machine is for classification, though it can handle regression too. Okay, it can handle regression too. If there are two data points, okay, what SVM will do is it finds the best decision boundary, okay, called as hyperplane. What that does, hyperplane does, to separate them with the maximum possible margin. Okay, Then the next concept comes, that is the concept of maximum margin. Now we have learned this thing that maximum possible margin is there, okay, to separate them. Then this concept of maximum margin, what it does, it doesn't just pick any line to separate data, okay. What SVM is doing, it is not going to pick any line, okay, to separate the data. It chooses the one that is farthest from the nearest points to each class, okay. It is not going to choose the line which is near to the points, okay. It is going to choose the line that is way more far from that points, and that is called as support vectors. What it does, this maximizes generalization, okay, helping the model to perform well on unseen data, okay. We have got this. When we will make predictions or we'll make a model, then you'll understand this thing in more clear, okay. But what if data isn't linearly separable? What do we do then, okay? Then there enters a kernel trick, okay. SVM, it uses a kernel function to transform data into a higher dimensional space where a linear boundary can be found, okay. Remember thing, that is kernel function is being used, okay. If you want to know what is kernel function, you can mention it in the comment and I'll make that also clear. Next is common kernels which are included. Those are linear, okay, polynomial, RBF, that is radial basis function. It is great for nonlinear data, okay, and sigmoid. In simple terms, what it does is kernel lets SVM learn complex nonlinear patterns efficiently without explicitly computing high dimensional coordinates, okay. Means like whatever the flaws were there in linear regression, logistic regression, right, assumptions were there, okay. Here there are no such things, right. So we can go with these things also if our requirements are satisfied, okay. Next we'll understand what are the advantages. Now we are learning about this SVM, so what are the advantages, some of the disadvantages, let's learn about that, okay. Some of the advantages are like high dimensional power, okay, excels in data sets where many features like text or gen data is there, okay. It makes clear separation, means it finds the optimal hyperplane we know what is there, okay, when classes are distinct. It is robust to overfitting, okay, means like with proper tuning it balances margin as well as error. It is non-linear flexibility, then memory efficient is there, only relies on support vectors. What we know what support vectors are there, right? Then kernel handles complex boundaries to complex also, means like complex things are there, then also it can handle. Then versatile is there, okay, it is versatile, it adapts to various problems with different kernels. Now let's discuss some of the disadvantages, okay. It is not suitable for large data sets. Now when we were understanding advantage, from that only we can understand that it is not suitable for large data sets, okay. Then parameter sensitivity, that is also a flaw of this, okay. It needs careful tuning of kernel C and gamma, okay. It is less interpretable, means like harder to explain than decision trees. It's, if we are going to master it, then we have mastered the machine learning like that, all models, okay. Next is their noisy data, okay, struggles with overlapping classes, means now as we are taking simple data, manual data we are creating, so that doesn't mean that there is no difficulties in data, okay. Unscaled data, okay, it requires feature normalization, then multi-class complexity is there, needs extra strategies for non-binary problems, and most of the time here it is going to happen that data is not linear, okay. So we'll have to solve the things also. Now let's create a mini project on this SVM also, okay. What is the requirement, okay, we have to develop a machine learning model using support vector machine, okay. What we have to do, we have to classify the vehicles, if that vehicles are either a car or a truck, based on like there are some of the variables like independent variables and dependent variables, we can say. Independent variables are like weight, engine size, and other like vehicle specifications are there, okay. We are going to create this manually only, and the solution, what, when we will create the model, if it is performing good, that solution is going to do, it will enhance the vehicle categorization process in the client system, right? So let's open our Jupyter notebook and create new SVM project, okay. First things first, what we need is, we need to open our Jupyter notebook, okay. I'll close this, okay. Oops, sorry, yeah. So what we need is we have to import libraries, then data is there. Okay, I'll quickly create these two things. You open your Jupyter notebook, okay, you give it a name and start importing libraries. Okay, libraries are common which we need. You can just open that random forest one also, and then you can copy those libraries also here. But we need to change one thing, that is here we are using support vector machines, right? So here I have imported the libraries NumPy, Pandas, Matplotlib. Okay, Seaborn is okay. From Scikit-learn model selection, train test split is okay. Then all the things are from that only. But just this from Scikit-learn, preprocessing. What I have did is standard scalar I have used. I have imported. Okay, I'll need this from then SVM. Okay, support vector classifier we have took. Then from matrices, confusion matrix and classification report is there. Here you can see a bit of change in the data. Okay. So this thing I have created, you can create, because I want to take random values. Now all the time we are giving values, but here it is going to be a twist. It is going to be random values. Okay. So there are these things. Okay. This weight, it is going to be in kg. Then engine size, it is going to be in liters, and all the things I have mentioned over here. If there is anything, then you can tell me. Okay. Next, you can see this data, it has all the values over here are random values. Okay, not single value we have mentioned, all values are random values, but we wanted 500 rows, as we have mentioned. Samples 500 we needed. Okay, so samples we have took 500, and 5 columns are there. Columns we have mentioned, right? This is 3 4 5 columns we have mentioned. Okay, so clear, this thing is clear. Now let's target variable. Now let's create this target, means like x variable and y variable. Okay, we need to do that thing, but here it is going to be a twist. Okay, so here what I have did is this target label. What I have did over here is we label vehicles as truck is there. If there is just truck, means it is 1, and if there means why it is truck, because if they are heavy, they have large engines and more wheels, high clearance is there, or poor mileage is there, then they are truck, and if not, then they are cars. Okay, so these are the common things which we should know about the vehicles. Okay, means if there are more number of tires, then it is going to be truck, right? If there are 4 tires only, then it is going to be car. So like that, some of the qualities we have defined about a data, we have defined about vehicles. Okay, next, count plot is there. Now let's execute this and you will see count plot what it will tell. I'll show you. Okay, so here you can see we have visualized this count plot. Okay, x takes, y takes, all those things you know. Okay, x label, y label there, vehicle type count equal, means 0 is for car and 1 is for truck. Okay, so how many you can also see from here also, means what vehicles are more. Okay, one is for truck, means trucks are more in our data and compared to car, right? With this visualization only we can understand. If we want to know exact number, then it is between 100 to 150 we have cars between that. Okay, and 350 about to that we are having trucks. Got this? Okay, no difficulty, we can keep record of the things, right? The next what we have did is we have separated features like x and y labels. Okay, and scale these features, since SVM is sensitive, okay, to the different scales. Okay, that is why the standard scalar I have took over here. Okay, x and y we have defined. Now we know what is there in x, what is there in y, and now if we have understood that x data is there, y data is there, then next step is going to be train test split. Of course, you guessed it right. Okay, you can start writing it. So 80% of the data is for training purpose and 20% of the data is for testing. Okay, there you can see this thing clearly. Now next is model is there. Okay, we have to tell this model we want, and then what are the requirements of that model, we will tell the things, and then making predictions. Okay, so model we took. Okay, how we are taking SVM not SVC means support vector classifier. Okay, kernel we have to pass, we know what is kernel. Okay, and then all the things gamma equal to scale. We have seen that there are different features that the support vector machine uses. Okay, then fitted the data. Okay, we have told that data that this is training data, this is all things we have told. Okay, to a model. Then next comes predictions. What are the difference between actual as well as predicted values we need. Okay, based on that we are taking confusion matrix, and then we are printing classification report also. Confusion matrix means like true positive 20 are there, true negative 6 are there, false positive 4 are there, false negative 70 are there. Means this model here is not that much accurate. And what accuracy it is giving? It is giving 90% 90% of accuracy. You can see over here accuracy is 90%. For 0 was for what? Was for 0? You can tell me now. 0 was for car. Okay, so car's precision is there, recall is there, and F1 score is there. Trucks things are present also. Okay, you can understand the things with this. Now this was a final step. Okay, this was a model building. It was performing clearly all the things. So we predict on test data and evaluate with accuracy, precision, recall, and confusion matrix. This was the end of our this support vector machine. Okay, you have to understand the things, you have to understand these classification reports, and based on that you need to take decisions. Okay, you can take a step ahead also and create different things with this, but what is the main important thing? That is this. Okay, so what did we learn today? A single decision tree is cute, but a random forest, that's a power move. It's not just guessing, it's a committee vibe check. Bagging check, bootstrapping check, low bias, controlled variance, that's balance, baby. Let the trees argue, vote it out, and boom. A model smarter than your group project squad. Feature importance, it's your model spilling the tea on what matters. And SVM, it's the master of margins slicing through data with precision. Next time you are stuck between accuracy and overthinking, trust the forest and hyperplane. They've got your back, leaf by leaf, vector by vector. Got questions? Rub them in the comments like a fallen leaves in October. Like, subscribe, and hit that bell for more ML wisdom. Until then, stay curious, stay caffeinated, and may your splits be clean and your accuracy evergreen. What's up, my data dazzling crew? Welcome to the hypest machine learning bash on YouTube. I'm your host, ready to drop some serious knowledge bombs on k-nearest neighbor and naive bias. Picture this. You are chilling in a garden sniffing flowers trying to guess their color, or maybe you are karate chopping spam emails like a ninja. These algorithms are like your quickie sidekicks. We've got pizza analogies, dating app vibes, and coding projects so cool. They'll make your brain do a backflip. So smash that like button, grab some popcorn, and let's dive into this ML roller coaster. Oh, and spill the tea in the comments. Ever made a choice because your squad said so? Let's get started. So our first question is like, now as we are learning this KNN, k nearest neighbors, okay, we should know what it is so that we will understand. But now in the previous videos what we have learned, we have started with the machine learning, then in that we learned about supervised, unsupervised, and reinforcement learning, right? In supervised learning we have two terms, that is classification as well as regression. We have learned regression and now we are working with the part of classification. So in classification we are having logistic regression is there, right? And many other there, support vector machine, random forest were there, decision trees were there, right? We have learned previous things. So in this video we are going to learn about this KNN. It is also an algorithm, okay, k nearest neighbors. So what is this k nearest neighbors? KNN stands for what? Now we know that, right? K nearest neighbors. It is a simple yet powerful supervised machine learning algorithm, and it can be used for classification or regression task also. Okay, so it is also used for both, for classification as well as regression. But how? That we will see. Let's take an example, in some real world example. Okay, let's say you move to a new city and you are looking for a good pizza place. Okay, so you asked 5 neighbors nearby what their favorite place is. If 3 of them says Pizza Hut, chances are you will try Pizza Hut too, right? That's KNN classification. You're classifying your choices based on your K, means in this case, okay, 5, okay, nearest neighbors. For regression, how it works? Now imagine asking your neighbors how much they paid for a price, how much they paid for a pizza. You take the average of their answers and estimate your cost. That's KNN regression. So, can you think of a time where you made a decision based on what most people around you did? Drop your story in the comments. Now, how does this KNN actually works? What it does, you give it a new data point. We have to give it a new data point, okay? Like a flower with certain petal size and color, okay? Now we are going to make this mini project in our notebook, okay? We'll see how it works in practical also. It checks all training data, okay? Already labeled flowers are there, it will check that. All training data it checks. It calculates the distance from the new flower to the every existing one. Then what it does, it selects the k closest neighbors, like say 3 or 5, okay? When we'll do an example, you'll understand this thing, right? How is k is there and how we have to select it, okay? For classification, what it does, it picks the majority class among neighbors, and for the regression, what it does, it take averages of the value, okay? Now why is this KNN important in machine learning? KNN is part of the lazy learners club, okay? It doesn't train a model like decision trees or neural networks. So in this, no training phase is required. Then no parametric means like it doesn't assume a fixed form of data, like making it great for complex or unusual patterns. Next is simplicity. It's one of the first algorithm every machine learning aspirant should learn. A doctor diagnosing a new patient might look at similar past patients, their symptoms, age, test results, and base a diagnosis on them. That's KNN thinking. Now, what are the advantages of this KNN? Why we should go with this KNN? Because it is easy to understand, okay, as well as to implement also. Just few lines of code are there and our work is going to be done. No training step is required. In this train test split, you remember that. So that part is not going to be. No training step is required, okay? Just quickly we have to deploy the things. It is flexible as it works for both, like regression as well as classification, so it's flexible. Non-linear decision boundaries. Perfect when your data isn't separated by a state line. And it is also great for multi-class problems like predicting the breed of dog from one image. So in that class. If we take an example, then think about a dating app. If most of your matches are dog lovers who enjoy hiking, the app might recommend more profiles with those traits. That's KNN doing in matchmaking magic. Now, as any of the thing has pros, it also has cons. So let's discuss some disadvantages of KNN. So KNN isn't always a sunshine and rainbows. It had some downsides too. It's slow with large data sets. Whenever we are having any of the large data sets, then its speed is a bit less. High memory usage. It's as it stores the entire data sets. That is why. Sensitive to noise and irrelevant features. Junk data can cause confusion. Okay. And it needs feature scaling also, like standardization. Otherwise, one feature can dominate. And we need to also choose the right K. What is this K? You will understand when we will start creating a project. Now, when should we go with this KNN? When you have small data set, when your data is well structured and clean, when you need a quick baseline model, or you are dealing with multi-class problems, or even you want non-parametric model. So in these cases you can go with this KNN. And when should we not use this KNN? If our data set is huge, if we have lot of noisy or irrelevant features, or our data may have many dimensions. In those cases, then we can try decision trees, random forest, or even SVM instead. So KNN is like going around and asking your neighbors for advice. It's great if you have 5 neighbors, but imagine doing that in a city of 5 million. Not so efficient, right? So now it's the project time. What we have to do in this, we have to predict the color of a flower based on the features like its petal length, petal width, sepal length, sepal width, okay? So let's quickly open a Jupyter notebook and start creating this mini model. But before getting started with this project, with this KNN algorithm, I want to tell the back logic of this. What is the behind the scene, what is the math behind this KNN algorithm, I want to explain that. We'll understand it with a small example, and that only we are going to apply in this mini project. Okay, so let's do that. So here you can see that this is a small table in A, B, C, D. These are the points. Okay, I have named just random names are there. Okay, then X and Y variables are there. In the X I am having 1, 2, 3, 4. These values are there. In Y different kinds of values are there. You can see this. Okay, flower colors are mentioned in the last column. Okay, that will be our target. We have to predict the color. Okay, like which color is going to be. So like that is there. So we are having these 4 different colors. Okay, simple chart is there, no difficult thing. Okay, so how this KNN is going to work, let's see. What do we have? We have a new flower with features, means like in the point section, as these A, B, C, D, these were there. Okay, so like that, for the values we have 3 and 3. These 2 different points are there, and for that we have to calculate, means that we have to find the color, what color for that points is going to be. Okay, so we are using Lucidian's distance, okay, to calculate. And how it is calculated, like it is to calculate the distance between 2 points, like if X is there and Y is there, so 2 different values of X and Y is there. Okay, so x2 minus x1 whole square will be there, and plus we have to do y2 minus y1's whole square. Okay, we have to find these points and the square root of it. So like that we are getting the for all the 4 points with this new points we have to calculate, okay, the things. So when we use this distance, Lucidian's distance formula, okay, for all the points we are getting the values. Okay, you can see the values like 2 is there in this distance column. You can see the values like 2 is there, 1 is there, 1 is there, and again 2 is there. Okay, we have k is equals to 3, right? You can see it, I have mentioned it over here that k's value is going to be 3. So we have to take 3 nearest distances. Okay, so in this our example we can clearly see 1.00, 1.00, that those 2 points we are going to take. Okay, those 2 distances, and 2.83 and 2.24. From these two, which one is going to, which is nearest, that is 2.24. okay, so we will take, so their values, their color values, what those color values are there, pink, and violet. These 3 values we have got when we will calculate the distance. Okay, we have k value. Okay, so that is why we have took 3 values. Then we have points which is x and y. Okay, with that we are having this distance. Okay, we have solved this distance, and based on that we are taking this values. Okay, so when we were having these 2 points, okay, 3 and 3, these points were there, k was 3, we got the 3 nearest values, that was pink, violet and pink. These values we got. Okay, you can see it over here, right? This pink and this violet, we got these 3 values, right? So we have took that here, pink, violet, and the majority. Now next in classification, as we are taking majority, and if it was for regression we were going with the average. Okay, so now we are getting it into classification, so classifier we are going to use. So which value is mostly occurred? Okay, what is majority, means majority vote goes to pink color, right? You can see this, pink is 2 and violet is 1. So the new points which were there, these new points 3 and 3, for them the color is going to be pink. Okay, this is how k nearest neighbors work. Okay, now let's move into the Jupyter notebook and then we'll start creating a project. So here I have opened Jupyter notebook. Okay, now imagine you are walking through a garden and you see a flower sprouting, but you don't know what color it will be yet. Instead of guessing, we are going to use this machine learning to predict the color of this flower. We will learn how the k nearest neighbors algorithm can help us predict the color of a mystery flower based on its petal size. Okay, here I am taking just one variable. Okay, so first we have to do is we have to import our libraries. Okay, and then we will load the data. Okay, so now what I have did is I have imported our libraries. Okay, it is the first step. See, I have imported Pandas. Okay, then Matplotlib for basic visualizations I have imported, and then Scikit-learn from Scikit-learn. Okay, dot neighbors we have imported this kn neighbors classifier. Okay, classifier and regression are different things. Okay, we are working with the classification. Okay, the next step will be like data set. Okay, now we have imported libraries. Here we are collecting tools to make some of the things. Okay, so data set will be there. In data set I have took flower name. Okay, there are different kinds of flowers, and then the petal length. Okay, then petal width I have took, and then color, like what kind of color of those flowers is. Okay, it is not any real world data. Okay, but just I have created this so we can understand. Okay, and next what I have did is df, data frame, all those things now you have known very clearly, right? In this df I have stored the data. Okay, and then first 5 rows I have printed. You can see this is our data. Flower name is there, petal length is there, petal width is there, and this color, this is our target. We have to predict the color of that mystery flower, that unknown flower which is sprouting, right? So what is there in this data? We will be working on this data set, and it includes 15 flowers, and for each flower we have a detailed petal length, petal width, and its color, right? We will be predicting the color based on petal length and petal width. Like you might notice that the data set includes a variety of flowers like roses, lilies, iris, and more. We want to predict the color of mystery flower and unknown color but known petal size. To start, let's visualize the data by plotting the flowers on 2D graph with petal length on the x-axis and petal width on the y-axis. We can clearly see how the flowers are distributed by color. So what I have did in this visualization, I have took this variable name, color map name. Okay, and what I have created, scatter plot I have created. Okay, I have pass these things to it. Now in this x label, y label, title, legend, grid, show, these things you're familiar. Okay, things come over here, that is color map. In color map what I have did is pink, white is light gray, means like colors name I have given. Okay, mentioned for that. Next is there this PLT figure size. Why it is, we have to mention the size, means like what size of this figure it will be, that we have mentioned it over here. For color, in this color, okay, data sets color, okay, unique means first we have removed, means like here you can see this pink is repeated, so only take one time pink. Okay, we want to know how many different types of colors are present in a data sets. You can see it from here also. We have pink, white, violet, right? These colors are there, so we have took those unique colors. Okay, and then what we have did is scatter plot. In the scatter plot we have given subsets like petal length, subpetal length, means like we have to create an x variable and y variable, so like that we have just sorted them. Then colors, okay, sizes I have mentioned, label, colors, and all those things are there. If we execute this, what you can see, flower data set visualization. For if pink color is there, the circle will be shown. If white is there, this will be shown, and violet is there, this will be shown. So we have 7 violet color flowers are there. Okay, pink color flowers, like we can see from here also, because there are not much of the flowers, that is why we can see from this visualization. Okay, grid lines also make us things to understand easy. Okay, this legend is there. Okay, then petal width in centimeter, we can see it over here, and this petal length in centimeter, we can see it over here. Simple visualization is there. Okay, so as you can see, the pink flowers like roses and tulips are in one area, while the violet flowers like violets and iris are in another. This helps us understand how the flowers are grouped based on their size, color. Now next is we have to train the KNN model. Okay, so now here what we have did is petal length, petal width. Now the steps are same. Okay, petal length, petal width is there. Based on that we have to predict the color. These things are there. Okay, so we know what is x, what is y in this. Okay, now as I told, there is no training phase, so no, we are not, as even though we have separated the things, now we are not going to go with that x train, test, split, and all those things. Okay, we are initializing the whichever model we want, right? As we are learning about k nearest. Okay, so we have took this k near neighbors classifier. Okay, and we are executing it. No training phase is there, right? And we have seen it in the theory also. Now when we were training, you can see this n neighbors 3. Okay, that I'll explain you. We'll train a k nearest neighbors model. Okay, now k nearest neighbors works by looking at the nearest neighbors, okay, to the new data points, and deciding the class, means like color in this case. Okay, based on those neighbors. So in this example we are going to take k equals to 3. K is 3 is there. Okay, to make predictions. The idea is simple, that we'll check which three flowers are closest to our mystery flowers and predict the most frequent color. Now whenever we are taking any model, we need to give our data to that model, right? So that was the fitting step, like creating the model and then fit these x and y, means independent and dependent variables. Okay, that we have did over here. Okay, and we have took neighbors, means like 3 neighbors we are going to take. Okay, from there are 15 entries, right, in a data. So the most to that mystery flower, the nearest 3 ones we are going to take. Okay, so how we are going to do that, we will see now. Now we have to make the predictions. So we'll take that mystery flower. Okay, that's data we need. Okay, now we have trained our model. Okay, we have told the things, so we will take that new values and we'll give it to a model. So you can see this new flower to be predicted, like we that mystery flower was there. Okay, for that we need to pass 2 things, right? As we in this x we are having petal length, petal width, so we have to pass these 2 things. Okay, I have passed these values to those things. Then predicted color will be like that model we have to pass, like use this model. Okay, and then use those values in the things and then predict the color and show me, right? We are telling this. So knn.predict. Okay, this we have took over here, and misty flower. Okay, then what we have did is we have told that if petal length is 3.5 and width is 2.1, then tell me which color will that flower have. Okay, so what it is telling, it is telling that predicted color for the flower with petal length 3.5 and width 2.1 is pink. That flower which is blooming will have pink color as per this KNN model. Okay, now it is upon time only that when that flower will bloom. Let's see. In actual it is not going to happen, but still, even though if you are having any garden, then you can perform this thing and you can drop your answers in the comments. So this is good. Okay, we have got the color whichever we thought that it might be of our flower. So we have a logical reason to explain why that flower's color would be pink. Okay, based on this k nearest neighbors. Now let's start with naive Bayes. Okay, so what is this naive Bayes? It is also a machine learning algorithm. Okay, naive Bayes is a supervised learning algorithm based on Bayes theorems. It's used primarily for classification tasks. Okay, especially in like text classification, like spam detection, sentiment analysis, and new categorization. The naive part means what it does, it assumes that all the features are independent, okay, of each other, and which is rarely true in real world. But this assumption often works surprisingly well in practice. So why we should go with this naive Bayes classification? Because it is simple and fast. Naive Bayes is incredibly fast to train and predict. It just calculates probabilities based on data frequency. Like in spam detection, naive Bayes just looks at the frequency of words like free offer or click in spam versus non-spam emails and uses that to classify new emails. Okay, then it works well with small data sets. Even if your data set is small, naive Bayes can still perform surprisingly well because it makes strong assumptions like feature independence. To take example of this, if you are building a model for small school to predict whether a student will pass based on 2-3 habits, then naive Bayes can give you good results without needing tons of data. It also performs well with text data. Naive Bayes is the go-to algorithm for natural language processing, okay, like sentiment analysis, news categorization, email filtering. If you give it thousands of movie reviews marked as positive or negative, it will learn which words are associated with each and can then classify new reviews. It can handle multi-class problems naturally. Unlike binary classifiers like logistic regression, naive Bayes can easily handle multiple categories. Like if you are classifying news articles into sports, politics, entertainment, the naive Bayes can do it directly without extra layers. Next advantage or why we should use this is that probability output. Naive Bayes doesn't just give a label, it also gives probabilities, which is helpful in applications where you want to know how confident the model is. Like in medical diagnosis, naive Bayes might say 85% chance of flu, 10% chance of cold, and 5% chance of COVID. So like that. Doctors can use this probability for decision making, right? Doctors can use this probability for decision making, right? And it is also great for baseline models. It's a good starting point in any machine learning project because it's simple to set up and gives you a quick baseline to compare more complex models against. Like example, if we will take, then when you are testing several models for new product recommendation engine, you might start with naive bias to set the benchmark. Now, as we are discussing why this naive bias, now when naive bias might not be suitable. Despite its advantages, it's not always the best choice, especially when your features are heavily dependent on each other. If you have continuous features, if you have heavily dependent features on each other, or your data set is highly imbalanced or noisy, in that cases, it is not a go-to option. Now let's create a mini project on this and then we can understand the things more clearly. What we have to do is we have to build a simple classifier, okay, to predict whether a student will pass or fail based on features like if he studies regularly, yes or no, or if he sleeps well, yes or no. On these things we are going to create a mini project, okay, and you can understand this naive bias based on that. Let's open a Jupyter notebook and then start create a new notebook, okay. So here I have opened a Jupyter notebook, okay, you can see this. Then I have given it a name as naive bias, okay. Naive bias classification we are learning. With the help of that we are going to create a model. And which model we are going to create? We are going to create like predicting if a student will pass or fail based on two factors, right? Then first thing is there that we need libraries, so we have imported libraries. First one, that is Pandas, we need it. And from Scikit-learn, naive bias we have took, okay, means like categorical NB, okay. Next, categorical NB, you can see why it is, because we are going to get answer in categorical, okay, so it is imported as that. Then model selection, it is used for train test split, and then matrices, it is used for accuracy score and classification report. Next to that we have created data set. Manually created data set is there. Not more complex or difficult data is there that we cannot understand. By looking at the data only we can see most of the things. In that data what I have, students records I have, like he studies, yes, no, like that. In those form I have answers. If he sleeps well, yes, no, those forms are there, okay. And the result what will be? Then I have passed. It means some of the data I have passed, okay. Then next step is our like data frame, converting into data frame, and then so this is our data set. Now let's execute it and you can see. So when we execute our data, you can see that we have a data set. In that studies is there, sleep well is there, and results is there, okay. No complex things. We have seen a data, what is there in data, okay. Here what I have did is I have converted the categorical data into numbers, means like into zeros and numbers, that is binary form. As we know, machine cannot understand categorical data. Like if we are telling machine to wake up, it is not going to wake up. We need to press a start button, right? Like that things are there. So it needs, this data needs to be converted into binary form, that is from categorical to numbers. And what we have for that, we have encoder option, right? Data encoder. What I have done, I have copied this data into a table, okay, df.copy, okay. And then what I have did is encoded this all the things, like in studies if there is a value is yes then 1, and if no then 0. Means whatever values are there in studies, like first two values are like 1, then no is there, so it means 0 is there. So like that it has converted all the categories. And in results how it has done, for pass it is 1 and for fail it is 0. So what it will be in results, if we'll see, so 1 1 0 1, like that it has been converted, okay. So let's execute this. You can see the encoded data also, you can see it over here, right. So next what I have did is, we know when our data is being cleared, okay, then we need to start prepare for the machine learning model, okay. So what model we are going to use, we know that thing. But here what we have to do is we have to separate target as well as features. Means what is a target, result is a target, and rest of the things are x variables, that is independent variables, okay. Encoded values we have took, okay. So means like this studies values and this sleep well values, means like 1 0, these values we are passing to machine, okay. And in encode results this also same. So this is our x independent variables and this is our y, that is dependent variable. Then after features selection, means like target and dependent variables have been sorted, then next what we have to do is we have to split the data. And for splitting the data we are using train test split, right? So this is how we have took this train test split. Then we have passed, as we know what is x, what is y, we have passed those into train test split. And what is the size? That is 0.25. okay, this value means this much data is going to be for test. And what is there after test? You all know, right? So then which model we are going to use? We have separated the data. Now there it was time for the machine to understand like which data means which model with which we are going to achieve our output, that we have to find. And now as we are learning this naive bias, we have took this and the splitted data, the training data, we have given it to the machine. Okay, so this model is being created now we need to make predictions and test, and then our final output is going to be with us. So when that predicted whatever the actual and predicted values were there, okay, we gave that values to the model. From the test data we got the predicted values, means the actual values we passed, and we got the predicted values. Okay, means model has learned the things. Okay, then what we have printed? We have printed accuracy score and classification report. Accuracy score is 0.5. okay, means 5% we have got. And classification report, now you know how to read classification report. Okay, how much accuracy we have got? 0.50. okay, same as that, right? And support is 2 for the, means like this is one for the fails one and this is for pass, right? So what is the precision value, what is recall value, F1 score, those things we can see it over here with the help of classification report. Now to our understanding, what we will do is we will pass a new values like new results of a students. Okay, so let's see how a model will give us output. So I have created this variable named new data. Okay, in that I have passed the values like he studies, yes, he sleeps well, yes. Okay, so those things I have passed. Then prediction, and then I have told this model we have created, I have told that make prediction on this data. Okay, this new data, and make prediction on that. So let's see what it has done prediction, or it is giving us any error. So it has given us prediction. Okay, prediction for new student is pass. If he studies, if he sleeps well, he will pass. Okay, that with the help of this naive bias we have got. So after making new prediction, we have got that the student's result, that he will pass. Okay, if he sleeps well, if he studies well, he is going to pass. And that's a wrap, my ML rockstars. Wasn't that a wild ride? We just turned flowers into color predictors and sorted students like a pro with KNN and naive bias. Your brain's probably buzzing like a beehive, and I'm so pumped you joined me. If you love this, smash that subscribe button harder than you have ever yeet a spam email. Drop a comment with your favorite part. Pizza analogies, coding magic, or maybe you're already building your own model. Share this with your friend Drew and let's keep this ML party going. Catch you in the next one where we will predict even crazier stuff. Stay curious, stay awesome, and keep rocking that data life. Ever wondered why customers suddenly leave a bank without a trace? Is it the service, the policies, or maybe the hidden patterns in their data? In this video, we are diving into the real-world problems of customer churn, but not just with theories. No, we are getting our hands dirty with a full machine learning classification project that actually predicts which customers are likely to say bye-bye to their bank. I'll guide you through everything, from loading the data sets and preprocessing to training the model and evaluating the results. Whether you are a data science student, a fresher preparing for jobs, or just a curious coder, this project is your launchpad. So grab your chai, open your Jupyter notebook, and let's decode churn like a data ninja. Let's go. In this video, we are going to start with this banking customer churn prediction. It is going to be a major classification project. Okay, in this we just have a data, okay, and we are going to take that data, we are going to perform cleaning things on it, we are going to utilize all the things which I have learned in our previous videos. Okay, so here which algorithm is going to be used, which model we are going to be using, we don't know anything. We just have to go step by step ahead, and with that we will understand the things. Okay, so in the end we are going to see all the things clearly. First, we will understand what is churn. Churn means whenever a customer stops using a product's services, like if anyone is selling any kind of product and that they are having customers, so one of the customers is going to stop, or if he will continue with that product, so like that we are going to predict. So with the basis of that, then we can increase or decrease our sales, right? So like that this works in every sector. Okay, that means this churn. Okay, so now let's not waste our time and we will start our tutorial. We will start a project. So let's begin by cleaning up the notebook environment. We are using warnings, filters to ignore them, okay, to keep our output clean and readable. This, what it does, it avoids cluttering the notebook with non-critical warnings that Python might throw, especially from external libraries. Okay, nothing happened, because whenever we are going to face any warning, that time this is going to be needed, right? So that is why we are creating this. We need this. Okay, just we are making sure that whenever we are working, we don't get any different kinds of warning, or there are things, right, exception, errors, like that. So first things what we need is, we need a data set, we need some of the libraries to go with, right? The most common libraries which we have used up till now, we are going to import that. Okay, so we know for what these libraries are there, right? NumPy and Pandas, they are a foundational libraries for data manipulation. Matplotlib, Seaborn for visualizations, right? And next what we are going to need, that is, whenever we are going to need a library, we will come here in this import cell. I'll name it as import, okay, in the comment. Whenever we are going to import any of the library, we will come in this cell and we will import the things. Okay, so it will keep a track of the things. Okay, now next thing, what is there to begin with? We need a data, right? So let's take our data and then we will start working with it. Okay, so our first step is going to be, we have to understand what is there in that data. Now how we are taking any data? I am having a CSV file. You can take data in any form. Okay, I have downloaded it from Kaggle. So now, as I told that I have downloaded, so it will be in my downloads folder. Okay, so again I'll press tab. I know where it is. Okay, so here my downloads is there. Then this is there. Okay, so here I have loaded the data. Okay, this is the path in which my file is present. Okay, how we have did this, I have stored it in the variable named df. You have to remember this df. Okay, it is important, so I have to store it in this df. Now next is, what is there in our data? Let's see that. For that, what we can do is, we can print or just execute this df. Okay, we can see this, we have 10,000 rows and 14 different columns. Okay, and this, but now I'm not going to do that. I'm going to df.head, sorry, and in that I have to pass the value. I'll just see what is there in the first 5 rows. Okay, so yeah, here you can see this df.head I have used. This is the thing that we are understanding our data. Okay, we have loaded our CSV file and we can see this is our things present with us. Okay, so what is there in that? This is the default one, right? It is index, it is given by the this notebook only, right? Then this row number is present. Row number, it is going to tell this. We can see that, right? It is simple. IDs, then customer IDs are being present over here. Okay, customer IDs, we names, and surname is there. Is surname do we going to need that in the further? We'll discuss that. Okay, first we should understand what we want to predict. We want to predict that if the customer is going to leave that bank services or not, right? This thing we have to predict. So surname is not required, but still we will see further what is there in the data. Then credit score. If y'all are having credit cards, or y'all are having any of the EMIs, loans on y'all, then you can understand what is this credit score, right? We need to maintain this credit score by paying our bills on times and all the things, right? Then geography means like where location, okay, where is this bank present, okay, this surname, one person's bank is present in France, okay, his gender or her gender is female, okay, then age, what is the age, that is also being seen over here. Then tenure means year, for how many years they are using that bank services, like that it is a year, okay, we can see that from here. Then balance, okay, the bank balance is also being seen over here. Number of products, now this is not required, okay, then has credit card or not, this thing is also present, okay, 0 and 1 you can see over here, right, means like yes no, like that, okay, it is not following the sequence, okay, they are having or they are not having, like that it is present, okay, the information is there. And if that person, if that customer is an active member in bank, means they are like depositing their money, or they are removing their money, or they are having the active communication or things with that bank, then is that member active or not, that is stored in this column, okay. Then their estimated salary, what is their salary of those customers, that is being stored in this, okay, estimated salary. And then exceeded is our target, okay, exceeded, why is it a target, because it is telling in that, in this column, that if that person has left the bank or not, okay, sample data is there, this is right. So this much data is present, means like 10,000 rows are there and this much is present, and from this we have to give like for training, testing, and then what are the next coming customers or the next rest of the data of the customers which is present with us, we have to predict on them that are they going to exit or not, okay, like that. So some of the data, like if their female is there from France is there, okay, her credit score like this much, then all the things of her, and then she has exceeded or not, like that it is present. Yes, 1 means yes and 0 means no, okay. These things are clear, these things are there in that data, in a data, okay. So these things are present, we need to understand our data very clearly, like we have to by heart that what is there in our data. So we have used this df.head, okay, it is going to show us first 5 rows. So now we have understood our data, a basic opinion of our data, not opinion we will say, but basic idea of our data we are getting, okay, what is there in our data. And what we have to do in this, we have to predict this column, we have, this is a target, okay, we have to remove this from this data, okay. So this is going to be a target, okay. Now let's see what else we can understand from our data, okay. What it is showing, df.shape, what it is telling us, that there are 10,000 rows present and there are 14 columns in our data, okay. It is going to give us shape of our data, like what is there. We can get this information from df.info also, right. Now we are inspecting the structure of the dataset using information, okay. This gives us an overview of all the columns, their data types, and most importantly how many non-null values are present. From this also we can clearly see that the exceeded column, which is our target also, okay, has some null values in it, right. And we need to fix that before any of the modeling or any further steps, okay. Even though we are having in the exceeded null values, okay, you can see this credit score also, it is also having some of the null values, right. You can see this, there are 9,998 values, and here means here in exceeded there is one value that is null, and here in credit score there are 2 values which are null, right. We can see those things from this information, okay. Then you know, from range index it is like 10,000, it is being indexed from 0 to 9,999, right. There are total 14 columns. You can see row number is there, it's integer type, like how many float type of columns are there, we have 4 float type of columns, integer we have 7, and object means like categorical values we have 3, okay. Memory usage, you can see this information we have got from information function, okay. So now here we can clearly see what is there is null thing present in our target only, okay. So we need to remove that or solve that, like how are the and what are the different types that we are using to remove null things or fill that null things. We have drop null, we are going to drop. If we want to fill it with, then we have mean, median, like that thing is there, right? With the average values we can fill. But here what we are going to do, we are not going to impute our target. Target should never be imputed. You have to see like what is the factor, like how many values are there. If we remove that, then what major effect it is going to be, like that we have to see. Okay, now let's see which that person is there, which that row is there which is empty. Okay, and how we are going to find, we are having is null named function present with us, right? So we are going to use that and we are going to see which is that row which is null in exited. Exited is a target, and in that 11th index is there. Okay, row number 12. Okay, that's customer ID is there, its surname is Andrews, his credit score is this much, he's from Spain. Okay, his male, his age is 24, from 3 years he's been using those banks services, and yes, he has credit cards. His no, he's not an active member, like that. So here we don't know that that person has left or not left a bank. Okay, so we cannot understand this thing clearly. So this is this exited column. Now what are the different approaches that we are going to use to solve this? If you have any ideas, you can comment. If you have any ideas, you can comment it. If no, then just pause, try to think, and then if not, then we will follow along. Okay, so what approach I am going to try, you will see. I am going to drop it. Okay, I'm simply going to drop it, because see, imputing the target is not a necessary step. And here now, as we are seeing which column, which row is there, okay, that is empty, we can see only one row, right? Only one single row is there, so we can drop it. We are having 10,000 rows to give to our machine. Okay, in that one row if we'll drop, then it's okay, it's not that major issue. Okay, so I'm going to drop. I'm not going to fill it with any null value or any other like default values or nothing like that. Okay, I'm not going to fill it. Now here also we can see what is the index, but I just wanted to print that separately, that index. So that is why by using this index function, index this I have sorted out the index of it. Okay, it's d type, like data type, you can see it is integer. Okay, now what we are going to do now, as I said, I'm going to simply drop it, right? So let's drop it. For that we have this drop named function, right? We are going to use, then in that for whom we are going to use it, for exited. So we have to mention that column, okay, its name, then what we want to drop in that null value, right? And where and how we are going to find that null value, for that we need to use this is null, right? Is null we are using, and then so what this df drop exited index and this access is doing, access what it is going to do, it is going to drop that row. If access would be 1, then it would have dropped the column. Okay, so this line removes those rows temporarily but doesn't modify the original data frame. Okay, and for that what we have to use is, we have to use in place equals to true, right? In place equals to true, what it is going to do, it is going to change the things in the original data. Okay, means in this file, this which we have loaded, in this file it is going to change the things when we are going to use in place equals to true. You can see this when we executed this, one row is missing, right? We were having 10,000 and 14 columns were there, columns are there, but rows you can see one is reduced, right? But when we are executing this null value, again, this null cell things again, you can see this thing is present still, right? In this exited column, it is still in our data. So what do we do? So we are just going to take this only, okay, or else what we can do is, at this place only we can just come over here, and now if we'll execute it, so we have executed this. Okay, and now if we again execute this, we are not going to see any information. Okay, why this is happening? Because here we added this in place equals to true, right? Because of this, the things are being changed in the original data set only, in the original data frame only, and that is why we are not seeing these values over here also. Okay, now it is being completely deleted, okay, from the data frame. So that is why there is no use of this step also, right? Even though if we will execute this step again. Okay, now let's print it over here and execute. You are going to not see any. We were seeing what? We were seeing this 11th, okay, because it was empty. But now, as we have cleaned it, as we have dropped that value, we are not going to see. And we have also sorted the index also, means like 10, 11. You can also see that by, okay, just I'll cross this and df. And if you execute it, you can see its row numbers are being properly added. Okay, 10, 11 and 12th one, right? We deleted that is why. And here you can see these things are present. Now here is the problem, right? 9, 10, where is that 11th one? Index range is being, right? It is not proper. For that, what we need now, as it is not proper, so what we will need is we will need to reset our index. It is our index, right? So we have set our data frame, right? We have given its names and means like drop that empty and all the things we did. Okay, we have changed the things in the main data frame also. But when this index comes, it was pre-built, right? So we have to reset the indexes also. You can see this 10 and where is that 11th one, right? So we will reset index now. For that, what we are going to do now, from what we are going to resetting the index, we are going to, from our data set, right? We have this reset. Now see, there are many different functions present over here, but we need reset index. Okay, now why I am using this drop? Now as we have removed the rows, now our index numbers are also getting messed up. You can see this over here, right? 9, 10 and where is that 11 one, right? So like skipping numbers, right? It is being like skipping numbers. Our index is skipping the numbers. So what we are going to do? So we are going to use this reset index function, right? We reset them to make everything sequential again. And drop true, what it is doing, it is ensuring that old index doesn't get added as a new column. Okay, this drop equals to true. Now this index is there, right? It is going to make the changes in this thing only. It is not going to add this reset this row, okay, this index column again as a new column. Okay, we don't want that, right? It is not even needed, right? Why to take extra space? So that is why we have used this drop true, and in place true, you know what it is doing, right? Now so let's just take one last preview at our this. So you can see there are no null columns in, no null values in this exited, in this target. Okay, how we are finding that? If in our data set, if in that exited column there is if there is any null value, then give me the count of that. Okay, if you just remove this thing, you will see all the columns. Okay, everything it is telling us false only. Okay, it means like in no any of the value there is not null. Okay, in any row there is no null value. Okay, if it would be have true over here, then we would have to check that again thing. Okay, so it's simple, that just take sum only, right? We have learned these things also. What it is going, it is showing us 0, means like in that exited column there is no null value present. Okay, so now as we were seeing in this info, right, in this info when we viewed things, we got to know that this credit score, it is also having null values, right? You can see its data type is float and there are also some of the null values. So let's see how many null values are there. Okay, this step we are going to, this only cell we are going to copy it. Okay, we will paste it. So see, reusing the cell, we should understand how we are doing that. Okay, now we know what column was there. It was our credit score, right? So if we execute it, we just we know now in which column there is null value, right? We understood that. So I have just replaced the name of the column and same thing is there. Okay, it is going to give me the rows in which null values are present. In credit score, see here there are 2 null values, so these 2 rows are there in which null values is there. Now what is going to be your approach? If you have any idea, you can tell me in the comments, but what I am having the idea, I'm going to use that. Okay, see, these are the index numbers of those rows. Okay, those null values. Okay, in the credit score. Okay, their row number, their customer IDs, their surnames, their credit score, it is null only, right? The geography, one is Spain, one is in Spain and one is in France, right? Means like the banks are in Spain and France. Okay, then gender, okay, one is female, one is male, their ages is there, tenure is there. See, one is using bank services from 6 years and one is using from 3 years. Okay, see, bank balance is also there. Now, okay, if we try to see the null values in the balance, is it going to be, means like, and drop them, so is it going to be fine? No, right? Because anyone can have their bank balance zero, right? If they are not using, they'll keep their bank balance zero. So that also things we need to understand. It is our work to understand our data properly. Okay, the number of products, has credit card or not, his active member or not, their salaries and their exceeded. You can see it is 1% it is being exceeded and 1% it is not. Okay, so now let's handle these two things. Okay, now what is your approach? You can tell me in the comments. You can try to solve it, but if not, then you can follow along with me. But here I'm not going to drop these rows. Okay, here I'll use a little bit different trick. What I'm going to use, majority wins, like that I'm going to do something. Okay, so what I'm going to do is, you can see this null values and credit score, we are solving those things, right? We have these two columns which we need to solve, right? Which we need to think some of the things and then to do with this null values. Okay, so what I have did is, what approach I am going to use is, first you can see that geography is Spain, right? Then their gender is female, right? And age is 43. So likewise, from all the data I'm going to collect the people, means like their geography is Spain, their gender is female and their age is 43. So like that, such kind of similar kind of people I'm going to choose. Okay, I'm going to see their credit score. Okay, and with the average or with the minimum, with the maximum value of those all similar kind of persons, I'm going to fill that value. This is a good approach, right? Take all of the average, means all employees or all customers average is not going to be fine, right? Not going to be a good approach, but taking just similar people's advice, that is going to be fine, right? We can relate to that things. But here when I used this geography Spain, then gender female, then age, these are common things. Okay, and how many records I'm getting? See, these many records I'm getting of those. So what if I add one more field in that? What if I add tenure also, means like if they are using the banking service from the 3 years only. Okay, similar to this I am taking the data. Okay, so I have added one more field, one more column, and let's see how many data. See, now this much, these 5 values I am getting, only these 5s. Okay, so taking the average or minimum, maximum, whatever, okay, things, if we take that thing of this, then we can get this value, right? A little bit of accurate, not proper that value, but bit of accurate value we will get, right? Now what this is doing, you can understand this. Okay, geography, gender, female and all this, tenure is there, but what I have did is, and credit score not null. Okay, not null, this credit score, these all four, rest of the 4 values. Okay, so this is the final filter we are going to apply. Okay, this final filter remove any rows that also have missing credit scores. Okay, so we can use just the valid data to compute an average. Okay, so here what I have did is, I have took this average, means this one variable name. Okay, and that I'm going to see, and now as I was having 2 rows in which empty values were there, right? So that is why this is the first average of these similar things, similar data. Okay, this average I'm going to take, and that I'm going to fill in that null one. Okay, so this is there. Okay, this credit score not null. Okay, I have dropped that, and then credit score dot mean, means these 4 values mean I'm going to take, and then I'm going to fill it in that empty one, first common which was there, which here, this, in that I'm going to fill that value. Whatever the average is going to come of this, of these 4 values, okay, these 4 persons, that I'm going to fill. Okay, and it is likely similar, right? That is why I'm going to take this thing. So let's execute this. So once we execute this, we are getting the mean value. Okay, so now what we are going to do, we are going to directly fill that mean value, okay, to our index only. Okay, and how we are going to get that, what index it was, we can see it, right? where it is, yes, this null value. Okay, you can see this from here also, 4322, or else when we printed just those two rows, that also time we can see that. Okay, 4322. Okay, just pass that value, 4322 it was, right? Yeah, and then after that, what value we want to fill it over there? We want to fill the mean of it, right? So it is there, and where that mean is being stored in this variable. Okay, so just copy this variable and then you can paste it over here, because in this this mean value is present of all those columns, okay, of all these rows, right? Means like this, all these values mean is present in this variable CRAVG1. Okay, and that I am going to give to this index. I am going in this index I am going to fill that average value. Okay, so let's execute this, and then if you will print this again, where is that step in which I have printed this to? Yes, if you will execute this step again, what you will see, just let's see, we can see just one value because this one is being filled. Now there is no empty value over there, right? But that is why we can see just one value. And if you want to see like what value is being filled over there, then you can see it by df from data log. Okay, and then put the value. Now we know at what value, 4322, right? It was this value, right? And then what is the value we want to see? Okay, so just execute this. All the record of this index number, it is going to be seen over here. Okay, whatever the values are there of this index, we can see all the values. Its row number is this much, this, and what was empty? It was credit score was empty, right? It is being filled with this value. Okay, average of all these 4 rows. Okay, it is this much and it is being filled by this value. Okay, so our credit score is no longer empty, right? We are going to use same technique which we used for this first row. Okay, we were having 2 values empty, right? The second is also there. Okay, you're going to follow the same steps and you're going to do the same thing with this also. Okay, and then in that way we are going to remove that row also. Okay, means not going to remove, we are going to impute that row, right? This is null sum. Okay, this is a super handy command that I always use. It gives us a common column wise breakdown of all missing values in the dataset. And right now, as we were focused on the credit score, we are seeing this one more value is there, right? One more row is there which is to be removed, right? Which is to be imputed. So what is the common things which is present in that? Let's see. Here we can see its row number, it is going to be common, right? Its ID is also be going to common. Surnames are not going to be same. Okay, credit code we have to say. So we will choose this geography, we'll choose their gender, their age, their tenure, balance not. Okay, then anything, salaries cannot be common, right? So let's take these things and then we will again sort the things from the data. Okay, so when I took the similar things like geography, France, okay, means like a bank is located in the France, then male, gender, and then age. Okay, I have took just these things. Okay, so I've got this much record. I can take the values, right? If I feel, or should we add one more field to it? Okay, we can take the average of these values, right? So we'll keep this. We are not going to add any one of the field again. So now perfect. Okay, this line filters the valid rows matching our profile and takes the mean credit score. That's what we'll use for our final imputation. Okay, so what we did before, we are going to do same thing. We are going to store it in one variable and then we are going to impute it in the next value. Okay, means next not mean this null value. Okay, we need to drop this, not drop this, we need to remove this from here, then we need to remove the mean of it, and then we need to store it in our this one. Okay, this particular block. So with this we fill the last missing credit score using the average of similar customers, right? This is a smart imputation done manually, far better than dropping or just using just a global mean, right? If you again check if there are null values, then you can see there are no null values present. Okay, and mission accomplished, no missing values left. Our dataset is now clean for next steps. Now next up, what we are going to do is we are going to take a deeper look into a target column that is exceeded, right? Our target is there. I'll write it in the comment only. To be balanced. So when we execute this column, this cell, okay, from our exited from our target, how value counts what it is going to give means how many have been stayed and how many have churned. Okay, so like that this is going to give us the count. Okay, so it's an important check. We want a target classes like churned and stayed, churned versus stayed, to be balanced. A good balance is ideally like 50-50 or at worst like 60-40 maybe. Okay, if it's super skewed, we'll need to handle it using techniques like smart or class weights, etc. So now this was for exceeded. Now let's see for other columns also, other fields also. Okay, checking the distribution of has credit card or not. Okay, it is also an important feature. It tells us how many customers have credit cards. It is good for us to know while doing EDA, okay, and feature selections. Same idea. This one tells us how many customers are actively using the bank's services. It is important for churn analysis, okay? For number of products, okay? Number of products, how many products are there in total? There are, means like if unique we need to find out, there are 4 and then value of this, okay? So, and here's the number of products each customer has with the bank, like 1, 2, 3 or even 4, right? This might be a strong feature when we predict churn later on, okay? Now let's understand our data a little bit more. Time for a bird's eye view. Describe. Gives you statistics for numerical columns like mean, max, median and standard deviation, okay? Adding T means like transposes the results to make it easier to read. Look for outliers and column ranges here. Now let's hunt for the outliers, okay? These outliers are extreme values that can really mess our models, especially in algorithms like KNN or SVM. Okay, if we need to use those algorithms, then we need to handle these outliers also. How we are finding the outliers, you know, okay, most of the things. Okay, now here as we have just printed this described to you, okay, you can just go through it, okay? We'll just quickly check row numbers, how many rows were there. We have deleted one row, right, when we were working with that exited net value. So we know how many rows are there, okay, how many rows are present in a data, okay? Mean values of those, okay, mean values have been calculated, so it's okay. Standard deviations are there, okay? Minimum values. Now here you can see row number, minimum value, okay, it might be 1, it is good, okay? Then ID, the first one ID it would be, right? The minimum ID of the person, customer's ID, right? Then credit score, okay, 350, that is also fine, okay? Then age, you can see the age, minimum age over here is 1. Is it even possible? No, right? So here there is some of the mistake, right? So we need to find this, we need to sort this thing, right? So age is minimum, okay? That we need to clarify, okay? Then tenure, okay, fine. Balance, minimum balance is 0, okay. Then tenure, why I'm saying 0, because there might be the persons, there might be the customers who have newly joined the bank, right? So we can consider that possible outcome also, okay? Number of products, we have seen how many products were there, okay? These many, up till now, these many products one person or one customer was carrying, okay? Then has credit card, okay, fine. The min value, max value. Active member, salaries, okay? You can see this min salary over here, it is 11 rupees. Is it even possible that any one person who is working, who is earning person and he's getting 11 rupees salary? No, right? So that also we need to keep an eye on it, okay? We need to check that thing also. And exceeded, we have almost worked on this exceeded, so there's no problem because we need to find these things only, right? So min column you have checked, okay, 25%, you can see all the things like this. You have to understand by describe, okay? You can understand your data by describe. We are thinking that we have first only viewed our data when we were just loaded our data. No, it's not like that. We need to understand our data. We need to keep learning about our data, the things, okay? Now here we have understood that age cannot be this much, salary cannot be this much, right? These things are too weird, right, to hear also. Then 50% of data you can see over here, 75%. Maximum you can see, maximum row number is 10,000. Okay, we'll take it into consideration, okay, for now. Then credit score, then age you can see 92 is there. Okay, fine, that might be the thing. Okay, then balance, okay, minimum balance was 0 and you can see the maximum balance, so it is also a thing that we need to keep in. A number of products 4, fine. Okay, has credit card, is active member. Okay, estimated salary also if you'll see, then okay, fine, we'll take for right now, we'll take it as fine. Okay, so these are the things we have understood from our data, right? Here when we have come up till now here, okay, we know what our target is, right? Based on that, okay, we can understand like, is customer ID required for it? Is okay, customer ID we will keep, fine. Okay, is the credit score required? Is the age required? Tenure is required? If they have credit card or not, this field is required. Are they active member or not? These fields are required. Are these really required? If you think carefully, then no. Some of the fields from this are not required. The main fields which we are requiring, that only I will take now. Okay. So after analyzing this, we understand that there are many things which we need to work on, right? So first thing which we are going to work on now, that is outliers. We are going to handle outliers. So for handling outliers, what I have did is, the fields which are important, I have took those in this one variable. Okay, means like, see, we understand this row number is just not needed for the prediction of this exceeded. Okay, so customer ID is also not. So like that we discussed like which fields are required, which fields are not. So I feel these 4 important fields are required for my predictions, so I'm going to take this. Okay, in that age we saw we were having minimum age 1 and maximum age was 92, right? Here also you can see that, right, in this describe. So these things are something like which we can't believe or which we can't trust, right? So we need to see those things, and those we are considering as outliers. So to visualize outliers, the best thing, that is box plot. Okay, so we have printed this box plot over here for age. Okay, we are right now working on this age one. Okay, we are going to handle the age fields outliers. Okay, so I have printed just box plot of that age. Okay, from that I can understand that these outliers, okay, this is minima and this is maxima. Anything that lies between minima and maxima is okay, they are within the normal range. Okay, but anything outside them is known as outliers. So these are the minimum one outliers and these are the maximum one outliers. Okay, so what I have did is I have created a list. Okay, in that list all it is going to be stored. Okay, for outliers, to solve outliers there are many different ways, we know, right? The one which we are going to use, that is IQR. IQR means interquartile range. Okay, what happens in that, it is having its formula. Okay, but what we need to do is we need to separate the data into different parts. Okay, into different quarters. That is, I have separated into Q1, Q2 and Q3, and the formula is also of IQR, that is Q3 minus Q1. Okay, so in Q1 25 percentile of data will be there. In Q2 of course it is going to be 50%, and also Q2 means this line, this is known as median. Okay, so it is the middle point, it is the median, so of course 50 percentile is going to be separated at that. Okay, in Q3 it is 75. Okay, this is a Q3. Okay, the rest of the data, 75% of data is going to be in this. Okay, so that's how we have separated our data into Q1, Q2, Q3 into 3 different quartiles. Okay, IQR formula is there, that is interquartile ranges formula is there, Q3 minus Q1, third quartile minus Q1 quartile. Okay, that is the formula. Here minimum what it is going to be, for minimum what formula is there, we have to minus with the 1.5 and multiply it with IQR. Okay, this formula is there, this is separated things. Okay, and this is the formula for that. That for maximum it is this. Okay, we have to add with 1.5 and then multiply with IQR. Okay, means this is going to give us the values of these ranges. Okay, these values we are going to get, and with this formula, that is Q1 minus 1.5, this formula, this minimum, we are going to get this value. Okay, So you can see the minimum value, it has given me 14, and the rest of the things which are beyond 14 or below 14, those are considered as outliers, right? And in this describe, we saw that age was, minimum age was 1, so this 1 is being considered as outlier, okay? And maximum is 62, okay? Above 62, anything that will come, means anyone's age, if it is above 62, then it is being considered as outlier, okay? This is the range we have given. Now anything beyond this, beyond these two values, anything, we are going to store that in a list, okay? For that we have created this function, okay? Anything, see, you can see this formula is there, q3 plus 1, this one was giving us this values, okay? So these values, we have took these values and this value, okay, these outliers value, and we have created a list of it, and we are storing it in that, okay? So these many other outputs which we have got, which we have stored in one list, okay? So these many other, you will see all the values above 62 and less than 14, okay? So we have got those values. So these are those rows, okay? These are those values, means in outlier range, what are the different values, we are getting the full records of them, okay? These are the different. So in all we are having 360 rows search, okay? And 14 columns, we know this thing, right? But I mean, we have segregated this all rows, these 360 rows, with the help of this age column, okay? So every person's age in this 360 rows values in this columns and rows, it is above 62 or below 14, their ages are, okay? So with the age we have separated these values. Now next thing is how to handle these outliers. What we can do, we are not going to drop all those rows, right? Is it a good, do we have a good reason? No. Do we have any value to impute or fill within that thing? No. And ages we can't fill with minimum age or maximum, mean age or like that, standard deviation, variance, all those things, means we cannot impute the age, right? How can we impute the age? Age is different of every person. It is not the thing that we should predict, or we can predict, right? Age might be anything. So what we are going to do is, we cannot delete it, we cannot impute it. What are the other things that you are using to handle outliers? You can tell me in the comments, okay? But what I am going to do is, I am going to see the relation of all these age columns, this age blocks. Do they have any relation with my target? That I'm going to check. If they are affecting target, see, we want to predict this exceeded, right? If the person is churned or not, right? So if age is affecting that, then we need to look at this age outlier, right? But and these are 360 rows, it's not a joke, right? We need to think properly. So but if it is not having any kind of connection between, then why to keep? If one is not related to other, then what is the reason, like why these rows are important, right? Because the main focus is on this exceeded, right? So what we have to do is, we have to check that if there are any trend, if there is any relation between this age and exceeded, means like if age is 66 and it is exiting only, or if age is any other thing, then it is staying only. Is it like that? You can see 66 is there, then 1 is there, 75, 65, means is there any specific trend following in this exceeded? No, it is not. That is the reason what we are going to do is, we are going to remove these 360 rows, these all outlier values we are going to remove, because they are not having any relation with the exceeded column, and we don't need that thing then. Now here I have dropped these outliers, okay? If you want to check, or if we can check, then how we are going to check? We can just do that describe again, right? So how we are doing that? Now you can see in the age, the minimum value is 18, okay? And in the maximum it is 62, right? So we can understand with this also that our outliers in the age column are being handled. Okay, so now as when we created that multiple calls, right, this variable we created, in that we took these 4 different fields, right? So we have handled the outliers of just age. So now we are going to move for this credit score, okay? So I'm going to copy this thing, this box plot. Okay, it gives us nice visualization so we can understand the things, right? So I'll create here one markdown and I'll write here as credit score. Okay, here I'll print this this cell, and here I'm just going to change the name to credit score. Okay, so it is going to give me all the outliers present which are in the credit score. Okay, so here you can see above the maxima there is no outlier, and below the minima there are some of the outliers. Okay, so let's see what these outliers are and how we are going to handle these outliers. We are going to apply same things. Okay, here we made visualization first. Okay, then we created a list, we separated the data into q1, q2, q3, right? We applied the formula, we found minimum, maximum, what are the outliers, right? And then we created this function a little bit, sorry, not function, we created this loop and then checked if they are having any trend or they are having any relation with the with our target, and if not then we have deleted it, if yes then we are keeping them. Okay, but let's see how many are there. Here they were 360 and it was okay to delete them. Okay, so we will see if they are less then we can delete it directly also, but we should check. Okay, so now the same things we have repeated for the credit score also. Okay, here new IQR range we have given. Okay, and thresholds also, and it's super semantic. Okay, we just have to plug it the new column and we have to repeat the things. Okay, simple things are there, just same that, then again that loop. Okay, so we got these values which are considered as outliers. Okay, in credit score, means these values are considered as outliers in the credit score. Okay, so what I have did is I have printed those rows in which these values are there. I have just printed those rows. Okay, first is list and then I have printed all the values which are considered as outliers in the credit score. Okay, so how many values I'm getting, you can see this. Okay, so now we have to investigate these rows, right, and transform them or remove them. Let's see what is that trend with the exited. Okay, if they are following any trend. By looking at the exited only we can see yes they are following a trend. Okay, every outlier, okay, is there, and then in exited we can see that yes they are churned, so we are not going to delete this. Okay, let's see if we can impute or not, or rest of the things. Okay, but I'll suggest that these are not much values. Okay, and they are showing relationships, so we are not going to change anything with these outliers. Okay, we are going to keep these things as it is only. We are going to let these outliers be in our data. Okay, but we know that in our credit score we have got outliers. Okay, let's see what it is going to give us ahead, and if it is needed then we'll come again to this credit score and we will then see what we can do with this credit score. Okay, right now we are going to move because they are not too many values. Okay, as like in age we were having 360 values, but here they are not too many. Okay, so that is why. And this thing we are going to understand when we are going to view our classification reports. Okay, so that is why we need to first see what our data is going to give. We need to clean up the things, and then we are going to move choosing the model, and then when our results come, when our classification report comes, that time we are going to go with one of the report, one of the model, and then we're going to keep it like that. Okay, so next what we were having after this credit score, I think we were having estimated salary, or what it was. Let's see, too many things, right? Yeah, so yes, it is balance and then estimated salary. Okay, so same things we are going to do with this estimated salary and this balance also. Okay, so follow the steps and you can show me if you are doing it before me, or else what are your suggestions, you can mention it in the comments. Okay, so for balance, same IQR process. Okay, and one cool thing you can view is that balance might often have zeros, so expect some skewness or clustering here. Okay, but here also if you just use that same functions and same list and all those things, okay, and then same loop, okay, you will understand the things. Here the minimum value we are getting it into the -1. Okay, so if we make visualization of this, we can see that our data is little bit skewed. Okay, we can see the skewness in the data. We will with these things also, okay, we'll understand there also, but maximum it is okay, but we are getting the value in negative, so that might be the reason that our data is skewed. Okay, we need to check these things, but here right now there is no outlier. Okay, means it is giving us the values. Okay, then whatever the rest of the values are there, we have created a loop for that. Okay, and here you can see that it is showing none of the value, means that it is telling us that there is no outlier, no any value is there which is beyond these values. Okay, let's make visualization of this also. We just have to take this and then we will create a cell above it and just paste it, change this to balance, our field name. Okay, if we visualize, you can see there are no outliers. Okay, minimize also here only, we need to look at things properly. Okay, if we increase its shape also, then also we will get the same thing only. Okay, it is being clearly viewed now. So right now it is not showing any outlier, but we can understand because negative is there. Okay, it is a bit skewed data. Okay, you will see when we make visualization, and if we see the rows in which that outliers are there, as it is no, so it is showing us empty things. Okay, it is not showing us any row in which outlier is present with, if we sort the things with the balance. Okay, so now what we will do is we will just copy this, and I think we have copied that also, but here I'll write as, here also we are not getting any outlier, right? How good it feels to look like this, right? How these visualizations are giving us this tiny little happiness. Okay, but still we will go with this process. Okay, we will just confirm it once, not but just with visualization also we can understand the thing, but still we will go with this also. Okay, because when we viewed these things, when we executed this cell, when we created those things, okay, means like separated the data into q1, q2, q3, and then followed that formula. Okay, we got this answers, right? And with this we can understand that our data is a bit skewed. Okay, so that is why we will go with this also. Okay, so now as we were seeing this visualization also, that also we understood the things, right? But still we have followed the things. Here also you can see it is in negative. Okay, so we are going to make visualizations next. Okay, in that we will understand the things in better way. Okay, so here what I have did, I have repeated the same process, and here also I have not got any outlier. Okay, when I printed the rows of it, then also I didn't got any row. Okay, as there is no outlier, so I didn't got any row of it. Okay, so we here what we did is we handled the outliers in age, we handled the outliers in credit score also, not handled, but we are going to keep as it is because they are not many values, right? So with the minimum visualization, this box plot which is for outliers, how it is showing us outliers, we can understand the things right now very clearly. Okay, so what is going to be a next thing? With outliers handled and data clean, it's time to shift gears. Let's visualize the data and find relationship between features. Quick type check. Before plotting or encoding, we need to know which columns are numeric and which are categorical. This helps us decide the right types of plots and transformation. Just listing all columns. Sometimes handy when you are working in Jupyter or building loops to iterate through columns for visualization or encoding. Now we are revisiting the top few rows because probably to refresh our memory or prepare for visualization loop. It's always a good idea to do a sanity check. Let's start with some visual fun. A count plot shows how many males and females are in the dataset. It's a great way to get an instant snapshot of gender distribution among your customers. Notice any imbalance? That could be an interesting lead, right? Now we are going to make the count plot for geography also. Okay, what I'm going to do is I'm just going to copy this thing. Okay, it's simple, right? Just paste it, and here you have to change it to geography. Okay, I'll copy the geography word also. See, because what happens, it is case sensitive and I don't want to get any error, so that is why I'm doing this thing. So you can see in this count plot we are having our bank banks in France, Spain and Germany. Okay, it's like geography, 3 different types of geographies are there. Okay, you can see in which there are more customers. In France we have most of the customers. Okay, in Germany then next, and then in Spain. Okay, so like that, within that female and male, how many male are there? In most of our customers are male and less female are there. Okay, we can see the count also of it. Okay, with this count plot you can answer the question like where are your customers from, right? It is going to reveal the geographic distribution, like how many are from France, how many are from Germany, how many are from Spain, right? If you are planning any region based marketing like that, then you can get a lot of information from this visualization, right? So yes, if they have credit cards or not, how many are there who has credit cards and how many are there who don't have credit cards, you can see this thing also from here, right? What it is showing us, it shows us how many people have credit card versus how many don't, right? It's a binary column of 1 and 0. 1 means here yes they have, and 0 means that is no. This kind of data is gold for segmentation and modeling. Okay, you know what segmentation is, what is modeling also. Now we are going to plot it for if they are active members or not. Okay, so how many users are active members? Again, it's binary. These type of plots are simple but powerful and help us to understand users' engagement at a glance, right? Now one last count plot we are going to plot. It will be for a target column. Okay. Now we hit the heart of the problem, churn. The exited column shows whether a customer left a bank or stayed. This is your target variable for churn prediction later, and you have to look for the imbalance here too. If you want to see how age is distributed, a histogram helps. This tells you which age groups dominate your customer base. Watch for spikes. Most customers in their 30s, 40s. This guides product targeting. Okay. Same histogram we are going to predict for credit score also. This credit score tells us about financial health. A nice smooth histogram helps us see if people are generally low, medium, high scorers. Any sharp drops or clusters, investigate it further. In credit score, when we were handling outliers, we told that our data might be skewed, right? Here also, if you focus on it, you will understand the thing that why I said that data is skewed. Okay, and which side it is skewed, it is right or left, just comment it. You can see only everything is going okay and this one bar is high. So why it is, you can understand the things now better. Okay, that's expected in banking data sets, but high balances are worth watching. Maybe those customers needs VIP treatment, right? Estimated salary shows income spread. It might be flat or right skewed. Combine this with balance and you can do wealth profiling or tiered marketing. So, okay team, it's time to go deeper. We are going to start exploring how different variables relate to churn. This is where we start spotting patterns that explain why customers are leaving. So what I have did over here is I have created a box plot, okay, as we are going to compare the things with our target. So yes, target is going to be in every that four important fields which were there. There were age, age was there, then estimated salary, balance and credit score. These four were important, right? We are going to keep these for this prediction of exceeded, right? And then what I have did is I have given title that age versus exceeded and then show. Okay, so you can see in which there are outliers. Okay, this is so useful, right? A box plot showing how age differs for customers who stayed versus left. Older customers might be churning more. Is that the case here? Next I'm going to check for balance. Okay, are people with higher balances churning more or less? Sometimes wealthy users feel ignored and leave, right? This chart helps us detect that. Next we are going to see with the estimated salary. Okay, do high earners stick around or leave? These box plots reveal the central tendencies and spread. Super valuable for segmentation. So these things we have plotted. Okay, we are not going to plot the credit score. Okay, with these box plot also you are getting most of the information. Okay, these if they are having any relation with exceeded or not. Okay, that we can see, right? age was not having, okay, age was on his road and exited was on his road, right? It was not having any trade, and credit score, of course, it is going to have, okay, we have understood that before only. Now next we are going to see the count plots, okay, count plots connected with this exited one, okay, churned one. Geography versus exited or churn, you can see. Perfect for region-wise analysis. This helps you know if customers in one country are churning more, maybe they need better service or local offers, okay. Then next was with this gender, we this visualize the thing. Then next with geography, okay, with geography you can see these things, okay, geography and how many from that are leaving the services, okay, leaving the bank. In Germany there are most of the peoples who are living, okay, so we need to focus in this region, okay, geography wise churn it is. Then for active members, if they are active members or not, like that, okay. This we can understand with our basic knowledge also, okay, is with our general knowledge also. The next is if they have credit card or not, okay. If having credit card is having any connection with leaving the bank or not, is not like any logic is there, okay, with that. So these all are the count plots which we have visualized, okay, simple, okay, there is no difficult thing to understand in this, okay, we have got most of the information with this visualizations. So all right, now we visualize the heck of this data set. Now it's trying to prepare it for machine learning, feature encoding, scaling and splitting incoming. So as we have seen every prediction or every important fields with our churn, with our exited column, okay, we have compared those things. What I felt is when we just printed this, okay, def dot head, oops, you can see this customer ID, surname, okay, row number, these are not needed. So what I'm going to do is I'm going to drop these things, okay, for my further analysis I'm going to drop these things. So now if I'll see my data, or else I'll just copy this, come here, paste it and execute it. Now my data is a little bit less, okay, you can see this thing also. That row number, customer ID, these things were not necessary, so they are not here. In credit score, geography, gender, age, tenure, balance, these things are there, and these many things only I am keeping over here, okay. So is it clear that why we are taking these fields? Because the number of data which it is less, if the number of fields are less, we can understand better. So now here we need to work on some of the categorical values also, okay, categorical data also. For that I have created this, okay, I am going to make visualization only, next visualization it is going to be. But here what I have did is I have already mentioned the colors, okay, I have created this colors named variable, okay, in that I have given this 4 type of colors, okay. You will understand this when we have predefined the things, okay, means the common things which are going to be in any of the visualization, that we have predefined it here only, okay. So we will just access one variable and then all the things will get, okay. This is a common cell, okay, I have created. I have used this, or I am going to use this in many of the visualizations, okay. So if we'll execute, you can see these things, that labels, title, labels and all this, limp and all these things are common, okay. Why this limp is there, you will understand when you will see the visualization. These some of the description about that visualization I have mentioned, okay. It is simple visualization only, simple count plot is there, okay, but I have made it a little bit advanced, okay. Distribution of exceeded column, okay, with retained and statements, in that only 0 and 1, okay. I have just created this simple count plot. It is same as like if we have created over here or not. One single variable was there, these are compared ones, right here, these are single ones. So we have created this distribution of age, if it is active member, has credit card and all that, geography, the gender. No, we have not created this, but you can see this thing, this simple one visualization only it is there, okay. This simple count plot is only there, but it is for exited column and it is, I have created a bit advanced, okay. You can see the colors, you can see their percentage, you can see, right, all the thing present over here. That is because just I have created this loop in it, okay. Just simple, this much only is needed, okay. This with this also we could have got the information. So now what I have did is all the categorical values I want to find, okay. Number of products and credit card, these are okay, these are numerical, but this gender, this geography, these are all in categorical, right? So I'm going to separate those things, okay, as machine cannot understand the categorical things, right? So we need to do that. Here just simple histogram is going to be there, okay. Its size I have mentioned, bins, layout, color is going to be edge color, what it is going to be black, and line width is going to be 1.0. Simple histogram is there, but I have given a little bit of description for it, okay. So I have created that, and it is for multiple cols. Multiple cols was a variable for 4 different fields, right? So we are going to get 4 different fields histogram. Age, credit score, estimated salary was there, and balance was there, okay. So we have got this thing. You can see in age, when we were working with the age, we handled the outliers of age, right? So it is a bit okay. You can see this with the help of this. In credit score, we left those outliers as it is, right? Because they were having a relation with our target, right? So there it is going to be like this only. Then next was balance. In balance, we didn't got any outliers, but we saw that we got the values in negative. That I told that our data might be skewed, okay. One side our data is too much, okay. It is bent in one side. You can see the single bar is standing outside, okay, and if this much data you can see, it is okay, but this one bar is making difference, right? And when estimated salary was there, there was no outlier, there was no anything present, okay, and we get this visualization with the outlier, okay, this histogram, okay. You can now understand these details, what is there in the x-axis, y-axis, okay. These are simple things, okay. And for estimated salary, you can see the things by yourself only now, okay. We now understand most of the visualization, how to read the visualizations, okay. So that now I'm not going to go in depth with this visualizations, okay. We need to go a long way ahead. So multi-correlations, as I told that we can compute the standard correlation. What we can do is we can compute the standard correlation coefficient between every pair of features using Pandas correlation method, okay. And that I have created over here. For here it is going to be this things, and for this only I have printed a heat map, okay. Heat map, its description I have given, and here is that heat map, okay. If you find the correlation very high, between like -1 to -7 or 7 to 1, then remove one of those correlated values, okay, or the variables, okay. You can see this thing, heat map is there, okay. Everything is in front of you. And with this visualization, we can understand that there is no significant intercorrelation between our features. So we don't have to worry about multicollinearity. Now what multicollinearity is there? You all know that. So now after heat map, what I have did is I have created a common function, okay, with which we are going to understand those features in more depth, okay. This heat map and this all things, they have given us enough of information, but still we'll need to understand some of the things, because more the visualization, more the hidden depths are being going to found, okay. More insights are being found, okay, if we create. So here also I have created, this is the common one look I have created, okay. For histogram, it is all going to be histogram as well as box plot, okay. So we are going to have box plot also, histogram also in one only, okay. I have mentioned some of the description for them, and then what data is there, okay, that I have passed. So first I have plotted for age, okay. Age you can understand from here also, you can see what color is for retained. Retained means, so the outliers or the box plot for just for churn people is also here, and for the retained people is also here. Retained means those are using, those are stayed, okay, for them. Then for credit score, we have the same, this box plot as well as this histogram also, okay. You can see the information of them also with this. You can see that the persons who have stayed, it is a little bit of left skewed, right? So those things are also there, the accounts you can see, right? And this people's also you can see the graph, okay. Then their box plot you can see. Next is for balance also I have created the same balance also. You can see the thing that it is a separate bar is there, right? Which these all information we have seen here also, okay. Everything that is present over here, that is only the thing which we have printed over here also. But what different thing can you understand by these things, you have to mention it in the comments, okay. For estimated salary also the same thing is there, okay. You can see how the visualization is, right? Most of the things we have seen in a previous visualizations also, okay. But what happens is, whenever we are creating visualizations, it may happen that we might understand more things. Okay, some of the hidden depths also we can get. So that is why we are creating more visualizations, possible visualizations we are creating. Okay, now next what we are going to do is we are going to work with the categorical values. Okay, there are some of the categorical values and which we need to convert into numerical, because machine don't understand categorical or the text forms, right? Machine is not going to understand. Machine only knows binary language, right? Zeros, one and numbers language. So that is why we are going to convert it. Okay, for that this is the predefined things, okay, which I am going to mention, because and I am going to use these things further. Okay, this is the common type which for all the cells I am going to use. Okay, I have mentioned colors first only, what colors I am going to need. Okay, and you will understand this thing when we will go further. Okay, so what I have did is categorical is variable, okay, which we have created first only, in that these much values are there, these fields are there. Okay, but we know that has credit card, it is not a categorical value, number of products it is not, but there are some of the fields. Okay, but these are the fields which we are using up till now. Okay, rest of them like some of them we have deleted. Okay, from here also if there is need then we might delete using these fields. Okay, I am going to create some of the things. It is going to be a common loop. Okay, common loop, and with this also you can understand there are going to be subplots. Okay, subplots, and you can understand the count and geography. Okay, for each field I have created this, and the categorical value or the categorical field which was like geography. Okay, in geography we have these many. Okay, the count has been given. For gender it is, for tenure it is in years. Okay, so that is also not not a problem for us. Okay, number of products is also okay, and has credit card is also okay. If it is active member or not, that is also okay, but you can understand these visualizations better. Okay, in tenure there are more colors, right? And these colors which I have mentioned over here only, right? Color category I wanted is, so this I have mentioned. Okay, and using that it has created this subplots. Now what these subplots are there, we are familiar with it. Okay, why these subplots are there and the necessary things for those subplots are been mentioned over here. Okay, and by watching these visualizations, what the information are we getting? We are getting that the bank has customers in 3 countries, right? We know those countries: France, Spain and Germany, right? And most of the customers are in which country? They are in France. And there are more male customers. With this visualization what do we get? We get that there are more male customers, okay, than female. And what do we get next? Only a small percentage leaves within the first year. The count of customers in tenure years between 1 and 9 is almost the same, right? We can see those things with our eyes. Most of the customers has purchased 1 or 2 products, while a small portion has purchased 3 or 4, right? This also we can understand with the help of visualization. And the significant majority of the customers has credit card. Okay, and almost 50% of customers are not active. This is also the thing that we have understood from these visualizations. Okay, now what we are going to do is we are going to look at these features again in great detail. Okay, so here we are going to understand these things in more depth, right? For that I have created the same things. Okay, multiple visualizations in one thing. Okay, so that thing for geography we are going to go with. Okay, here same things are there, but what we have did is we have added one more field. Okay, so by looking at this visualization what do we understand? Okay, we can understand the things like there are 2 visualizations but with different fields. Okay, so what do we understand with this visualization? That customers in Germany are more likely to churn or exit than the customers in the other 2 countries, right? The churn rate is almost double compared to Spain and France, right? And many reasons could explain this finding, such as higher competition or different preferences for Germany customers, right? We can understand this thing with these 2 visualizations. Same goes for this gender. What do we understand with this gender? By looking at this, say female, their rate means churn rate and retained rate means are they leaving the bank or they are using the services of the bank. Okay, we can understand with this for the females. And for the males, okay, we have got this thing. From here we know that there are more male customers, right? And here what do we get? Gender, female and male. More female are, this is the churn rate, right? More female are leaving the banks. Okay, so this thing we get from this visualization. It means that, in short, what do we get from this chart? That is, female customers are more likely to churn. And for tenure, what do we get information from this visualizations? The churn rate of it is not having any effect on the churn rate, right? That we get from the this tenure charts. Okay, and number of products, what do we get from number of products? The churn rate. Okay, and for this has credit card and this active member. Now y'all are going to tell me these things, that what do we information, that what the information we get from these visualizations. Okay, you are going to mention it in the comments now. Now next what we are going to do is we are going to drop some of the more features. Okay, some features like their salary, I don't want their salary. Okay, so like that there are more features which I don't think that they are important for my target. Okay, for my target prediction. So features to drop like tenure, years. Okay, how many years they are using those bank services, that is also not needed for me. Okay, then if they have credit card or not, these things I'm going to drop. Okay, so okay, I have dropped those things, but what are they being really dropped from a data frame? We need to check that. Okay, and only the rows are being removed over columns, like that also we have to check. And for that what we can do is, I have most common thing which we are using almost, that is this head, with which we can see the first 5 rows, right? So with the help of this you can see, can you see tenure, estimated salary, or has credit card, these fields? No, right? Because we have dropped these fields. Why xs equals to 1 is there and xs equal to 0 is also there? So why these two options are there, you all are going to tell me. Okay, so this thing we are too much familiar with, right? This is train test split. We have splitted the data into train test split because most of the things we have did now. Okay, visualization, cleaning, handling outliers, dropping the columns. Okay, those things we have did. Right, so now what we feel is we are going to split our data into train, test, split. And why it is needed, we know this thing, right? We have used this test in most of our models, right? Algorithms. So but there was one algorithm in which we didn't use this train, test, split. So which was that? Okay, you can drop the answers in the comments. Okay, so here what I have did is, you know what we did, right? Why we are just by reading this you can understand. Okay, drop columns exceeded, this is x field. Okay, that is why we are, means why in x field keeping all the things living exceeded column. Okay, we want rest of the things in x, right? Our feature. Okay, and y will be our exited, right? Because it is the target. Then test size, I have mentioned test size is 0.2. Okay, means 20% of our data is going to be for testing, right? Then random state, that is not much important. Okay, and this you will understand once we will go further. Okay, then here we know what shape does, right? It is going to give us the shape. Okay, means whatever the things are there, it is used, it is going to give us the figure, means number. Okay, so in training how much rows are being gone. Okay, so like that, and how much columns are there. So that is the thing where it is being showing over. See, 1 2, you can see this credit score, geography, gender, age. Why this 7 is there? Okay, here only you can understand it. Credit score 1, geography 2, 3, 4, 5, 6 and 7 till active members, means living exited. Here only we have mentioned, right? Top column exited, and so means living exited. These rest of the columns, it is going to be x. So x, train and shape of it. So total 7711 rows it has took, means leaving them the 20% of data is going to be. Okay, and this much is our 80% of data, and in that how many columns it has took? It has took 7 columns. Leaving this exceeded, this rest of the columns are 7 columns. Okay, so it has took that for training. Okay, so why train, what it is going to be? 770, this same only it is going to be, right? Then for testing, as it is 20% of the data is good, it is going to take. Okay, so leaving these rows, rest of the it is going to be here, and 7 columns, of course it is going to take 7 columns. And for test what it is going to do? It is going to do same thing, but this column is going to be. Okay, so that is why this is how the train test split is splitted. Okay, y test value counts, and what is the value counts of 0 in y test, and for 1 means stayed or churned, like that the count is there. Okay, you can see the things like how many are there and how many are left. Okay, so like that we can see from this also for testing. Okay, so as we were converting categorical values into numeric one, those two fields were there in which there were categorical information, okay, that was gender and geography. So first we are going to convert this gender into numerical form, and we have two ways, okay. We have label encoder, one hot encoding, okay, for conversion of numerical into categorical into numeric, right? So for gender, what we are going to do is we will check first, okay, what is the count of it, count of gender, we will calculate it first, okay. So for male we have 5264, and for female in all we have 4375, right? We have seen this in the visualization also, that we will understand like which number is going to be high, right, maximum, okay. So for gender we are going to use label encoder, okay. So how this label encoder works, you all know, right, what it is for categorical to numerical conversion, right? In training data we have gender, okay, so we are going to give training data only, right? So we need to convert that, so that is why we have to training data, and that value counts we have took over here, okay. So we know on all how many value counts were there, but still we have took this, okay. So we need to fit that. What this fit transform does, we all know, we are very familiar with that, okay. So we have fitted those data of training data and testing data, okay. We have took that and we have transformed it, okay. Then gender, you can see this values are there, means like here you can see here it was male and as well as female, so here it is being converted, okay, it was transformed, okay. So one value is for male, and how many male values are there, you can see this much, same number it is going to be, right, and 0 means female, okay. So it has converted 1 for male and 0 for female, okay. So if we will again do this for checking, so you can see this gender, so you can see this only training data's gender is being converted, okay, because we need that only, right? We are going to pass that thing only to the machine. If you want to check, what we can do is we can just copy this thing, okay, and we can paste it over here and execute it. What the values, these are the row numbers, okay, that indexes or IDs, whatever you are going to say, okay, those things are there. And what are the values, 1 and 0s are there, okay. So this is how we have transformed or converted categorical values into numerical one, okay. So now what next one was there, it was geography, right? So we have to now transform that geography, and for geography we are going to use one hot encoding, okay. So in one hot encoding, what we do, we map the things. We know how many values are there in all, right, in our geography, right? So I have created here a function for that, okay. In that Spain I have mapped with 0, and France also I have mapped with 0, Germany with 1, okay. So like that I have did, okay, geography conversion, and then for training I am going to fit that data, okay. For training only I am going to take, okay, I am not going to take whole of the data, as like we did for this gender also, okay. We took for training data, we took the geography, in that value counts, how many values are there, the 0, and see it is converted, okay. For 0 it is going to be like Spain and France's values are being going to shown over here, and then 1 which is for Germany, these values we can see over here, okay. Its data type also we now know it is an integer, right? First it was in object, right? Then next is testing purpose. So how many values are there in test? You can see in test it is not converted, okay. France is still there, Spain is still there, Germany is still there, okay. It is also 64, means like integer, okay, that is also in this only. Then for testing also we have used here, okay. For testing test data also in geography, okay, we have converted that thing also, okay. So now I am going to use the standard scaler, okay. But what the standard scaler is, it is pre-processing technique, okay. And what it does, it is used for standardizing the features of our data. So that is what I am going to use. And what it is going to do, it is trying to transform our data such that each column has mean is equals to 0 and standard deviation equals to 1, okay. So that is why I am going to use it. And here what it is going to do, this transformation, what it will do, it will result the features with 0 mean and unit variance, okay. Same it is going to do with this also. You can see the values over here also if you want to check. So next we are going to use this mode, okay. Why it is, I'll tell you. But what this mode is, what it is doing, it stands for, first of all, it stands for synthetic minority over sampling technique, okay. And it is popular technique, okay. It is in machine learning, it is very popular technique. What it does, it is used to address class imbalance, okay. if there is imbalance in our classes, yes it was, right, and we know where it was. Okay, so that is why it is used. So this mode technique, it is going to give us this thing. You can see what it is doing. Okay, so that is why I have used this SMOTE. Okay, what it stands for, it is for synthetic minority oversampling technique. So this training data I have fitted in that. Okay, so you can see how the data is being divided now, how the imbalance is being handled, right? Here what we did, we have used the things and created all the things in level, right? So next what it is going to be, next we need to next what we are going to do is we are going to choose the model. We are going to try different kinds of models, and then we are going to choose which one is going to be the final one, okay, with which we are going to keep our results. Okay, so first model which I am going to use is logistic regression. Okay, the basic one which we have used first only. So some of the basic imports were there. Okay, decision tree also, random forest also. Okay, then these were some of the basic imports which I needed. Okay, so logistic regression is the main one. You're going to understand why I am taking, and the main thing which we need is accuracy. This is only going to tell us that which one model is giving us best accuracy, right? This number is going to be, and so overall in every model we are going to get this accuracy, and based on that we are going to take our decision. Okay, so here I have created this logistic regression. Okay, you can just copy this code snippet and then you can paste it. Okay, then this is there. Okay, so what is the main output we got? We got the accuracy like it is 0.72. okay, so we got this with the help of this logistic regression. Next we are going to use that these different what are the common things which we need for rest of the models also. Okay, so that things I have mentioned over here, means like created a list and that. Okay, so next here it is not proper logistic regression. Okay, the basic things which we needed that were there. Okay, so here the logistic regressions things which we need to give it to the logistic regression, those I have passed. Okay, grid search CV also in that. Okay, I have passed the things, so you can see what are the values which we have passed. Okay, logistic regression for the C value. Okay, random state, that is not much needed. Okay, so those things. So for training data I have created different one, and the predicted one, the output one, it is going to give us different. Okay, so we are going to get two different classification reports. Okay, so for training data means like whatever the training data is there for that what it has predicted. So classification report for training data, this is the report which we are getting. The accuracy you can see 0.68. okay, and for predicting means testing data, it has given us this report. So what this report is telling us, okay, in detail what it is telling us. So a precision value first for this training one. Okay, so for precision what we got means for class 0 means not churned one, for what we got 71%, 65% for churned one, right? So these values are in front of you. Okay, so class 1, its information. Okay, the model is better at recalling churned customers, means like 76% recall, than being precise, means 65%. Okay, this means that it's catching a lot of churners. Okay, but also predicting some non-churners as churners, right? Which type of it this is there in class confusion matrix? What it is said as? It is said as false positive values. Okay, precision. F1 score is 70%, right? Means it is solid. It shows the balance between precision and recall. And for class means 0 means not churned one. Okay, those customers which have not left are like precision is higher 71%, but recall it is low, right, 60%. What it means that the model misses many customers who stay, right? And overall accuracy, what it is 68% of accuracy. It is not very high but not too low also, right? Especially for imbalanced classification task. The macro average, what it is telling us, this is just the unweighted average, okay, of the matrices for both classes. What it shows balanced performance across classes. This was for training one. Now let's understand what this testing classification report is telling us. The values are in front of your, okay, you all, right? So class 1, for class 1 means churned customers. What it is, high recall value is there, right? 79%, right? So model is catching most of the churners, and as well as it is having low precision, means like 34 only, okay? So many false positive, that is customers are incorrectly flagged as churners, right? 34%, right? But is it better than testing data? You have to tell me, okay? F1 score is of 48%, right? That indicates an imbalance between how many it catches and how many it gets right. And for class 0 means like not churned, what it is very high precision, 92%. When it says someone won't, it's usually right, but it misses many actual non-choices, means because recall is 61% only. Its accuracy, what's the accuracy of it? It's 65%, similar to training, right? Means what it is suggesting, no overfitting, but model still needs room for improvement. It has not given us two good results, okay? So we have to try different models also, and if they are also showing less performance from this, then we are going to go with this model only, okay? So macro average, what it is 0.63 precision, 0.70 recall. So what it is telling us, it slightly favors class 1 due to its high recall, and what its weighted average, heavily influenced by class 0 due to higher support, right? More data points are there in that, okay? So what is overall interpretation of this report? Its strengths are like this model does a good job detecting churn customers, right? Means high recall because of that, and which is essential in churn prediction, okay? So we might go with this model also, okay? It performs similarly on train and test data, right? Generalizes, it is generalizing decently. But what's the weakness of this? Low precision for churn, means many false alarms are there. Not ideal if actions on churn predictions are costly, okay? And accuracy 65 to 68%, means it is moderate, okay? Common for churn data set, but could be improved also. So after finishing this classification report of prediction as well as training data, we have understood what are the things which it is giving, how much percent of accuracy we are getting from this data, okay? Now what we do is we are going to try more different models, okay? So we know what classification different models are there, right? So that, and what kind of answer we are getting, so based on that we are going to use next model, okay? So here what it is, XGBoost, okay, and LightGBM, okay? So these things I'm going to install, okay? We require that also, means like I'm going to use those models also. Then some of the things from Scikit-learn I wanted, okay? This is, we know what it is, right? So that, then random forest also I have took, and gradient boosting classifier also. These things you all are familiar, we have covered most of the theory, right? These XGBoost and LightGBM, these all are also different models, okay? These we have not looked had a look in depth, okay, at them, but still we will see how they are working, okay? We need to pass same things only for them also. So here I have created for the random forest classifier. And random forest classifier, what is this? N estimators, that means these are 100 different trees, okay? The like that it is there, okay? So like that. Then entropy, what is it? Gini, how it means what these two parameters are for, that also we have learned, okay? Then max depth means how much trees, or how much leaves it is going to, how much leaves it is going to go in depth, like that we know, okay? With this minimum sample leaf, now what is leaf, okay, and what it is going to do, split. These we have seen what random forest is, okay? And for random forest these things are important, okay? So that is why these parameters we have passed for that, okay? For grid search CV, okay, these things were required and that we have passed it, okay? You can just use these things and then you can pass. Then what it is, we have passed those data into training and testing, not just not for testing but for training, okay? So xtrain and ytrain, we have passed that data into this. Then best estimator means like how many number of trees it is going to be. So here the random forest classifier we have used, and what are the description for it, means like maximum depth is what, how much depth it is going to go, then sample leaves, okay, minimum sample leaves and minimum split, what they are going to be, that it has told us, okay? Means that it is going to stop. And for stop we know what is pruning, right? You remember what we learned about pruning in our previous videos, okay? So if you remember that, then you will understand the things, okay? Then best params, okay, means whatever the things were there for it, for the random forest classifier. Those things are mentioned over here. Okay, we can understand with this also that how the tree might look. Okay, we are not going to view here decision tree. Okay, and then what we have done is we have used that training data. Okay, training data. For that training data we are going to predict classification report. Okay, and then for prediction also we are going to print classification report. This random forest, whenever you are using this random forest and you are passing all the things, okay, to it might take a bit of time. Okay, it might take longer than other models because it needs time. Okay, it needs time to make predictions. Okay, to form that tree. Okay, so it will take a little bit of time, so don't panic for that. Okay, and yeah, because I have already executed this, that is why it is showing us. Okay, that is why there is no problem in it, but it took time. Okay, it took at least 5 minutes of time. Okay, it's based on your systems also sometimes. Okay, then for this is for training datas. Okay, this classification report is of training data and this is of prediction. Okay, testing, after testing what we got, and after on training data what we got, the results. Okay, you can see what is there. Okay, now let's understand these reports in detail. So we know we have class 0 and class 1. What is class 0? Means they are not churned. Okay, they are staying in that company, bank. Okay, and they are class 1 means they are churned. Okay, they have left the bank services. Okay, so let's understand for class 1, for churned customers. Okay, in this report for the training data. Okay, we are looking at training data now. Okay, we got recall value. What we got recall value for churn. Okay, for not churn means like 0. Okay, so for churn customer, for look at this one. Okay, this one values. For that what recall we got? We got recall 79%, right? So model is catching most churners. Okay, about precision, what it happens? We have got 34, means like precision is low. Okay, 34%. Many false positive, that is customers are incorrectly flagged as churned one. Okay, and F1 score, what it is? F1 score, you can see that. Okay, it indicates an imbalance between how many it catches and how many it gets right. Okay, now for class 0, very high precision we are getting, right? What is the what is the precision value? We have got very high precision. When it says someone won't churn, it's usually right. Okay, and for class 0, what are the values? We have got very high precision value. Okay, when it says some customers are leaving, then it is right, but it misses many actual non-churners also. Okay, what is accuracy? You can also see macro average. Okay, what values we have got, what is weighted average. Okay, it is heavily influenced by class 0. Okay, so by looking at this also you can understand what is for training and what is for testing, what values we have got. You can see what accuracy here we have got and what accuracy we have got here. Means there is no most, so there might be the thing that there is no overfitting and there is no underfitting also. Okay, because we are getting most of the things similar only. Okay, then what is the precision value for churned one and not churned one, right? Then macro average, weighted average, what these values tell us, we can understand for this test data also. Okay, what accuracy we are getting? 81%. Okay, so this is the thing that we are getting over with this. Then what is precision value? What with the help of this F1 score you can understand the balance, right? So most of the things you can understand with this classification report. This is for random forest classifier. Okay, what the main important thing, the main important matrix would be this accuracy, and this is too good. Okay, this is not too bad, but it is okay, and it is good than this model, right? Which one was our previous model? Logistic regression. It is better than this. Okay, so you can understand by the values only, right? What are the precision, recall, F1, those values. By looking at those values only you can understand that this model is bit better than the logistic regression one, right? So same things we have applied, but here we have used we have used gradient boosting classifier. Okay, so here whatever the things which were needed for gradient boosting, we have placed those things. Okay, n estimators, what are there? Okay, then samples, subsamples, learning rate, means whatever the things which are needed for this model, we have passed the things over here. Okay, then grid search, CV also, for that also we have passed the things. Okay, the main important thing which is this one. Okay, this what you can understand from this. Now you all are at that level that you all can understand, right? With looking at the example, with looking at the model, what are the descriptions, what is printed on that you can understand. Okay, So these things are there. Then we have given this data for training. Okay, with training we need to fit the 80% of the data, right? So we have given that data to the training, and for training we have got this classification report, and for test data we have got this classification report. Okay, so let's understand this classification report in depth. Okay, so for classification report for this training data, what we have got, what is the accuracy we have got, that is 83. Okay, balanced performance, okay, across classes. This model treats both churners and non-churners equally well, right? What is F1 score? F1 score, it is also 83% only, right? For both classes, at that F1 score is same for both the classes, right? For churn also and for non-churners also, it is 83 only. So it is what it is indicating, that it indicates a strong model. Okay, this is a strong model that it is indicating. Okay, so there are no results of overfitting, no signs of overfitting. Okay, test results are slightly lower, but okay, so let's see what this test results are also telling. Okay, class 0, for what is this of class 0? Okay, excellent performance. Okay, especially when it is coming for precision. Okay, you can see this with this numbers also. Very few false positives are there, right? Then class 1, for class 1 what it is? Recall, it is 73%, right? Model catches 73% of actual churners. Precision, it is 54, right? Only a bit better than random guessing. Lots of false alarms are there. Okay, F1 score, what is F1 score? It is 62%, right? Slightly better than random forest. Okay, so these things are there present. Okay, so overall, by looking at these three reports, what we get is overall summary. If we see, okay, so gradient boosting classifier is currently our best performing model. Okay, accuracy is also 82%. Okay, good recall for churn, that is 73%, still important for retention strategy, but okay, and improved churn's precision. Okay, 54 percentage is there, and we need to improve that, better than both previous models, right? So there's still room to improve churn precision, but it's a great balance between catching actual churners and minimizing false alarms, right? So overall, by understanding these report, which model are you are going to go with? Okay, this is our fully machine learning project. Okay, machine learning classification project. Okay, so these three reports, based on three reports only, we are going to go with these models further, and then next things comes for the ML engineers or them. Then we need to save these files into different files. Means like pickle file is there, as well as joblib is also there. Okay, we are then saving these things into those files. Okay, whichever model we are going to take based on these reports. Okay, we can see the reports, and then by looking at that, we can understand if there is overfitting, if there is need of improvement, and like those things we will discuss. Okay, but for right now, I think this gradient boosting classifier is okay, because it is giving on testing data, it is giving nice results. Okay, that is important, right? Because on unseen data it is giving good, but we need to improve for this. Okay, for churners, this thing we need to improve. Then everything rest of the thing is good. It is 82%, this model is good, so that is why we can go with this. If you will go for the random forest one, okay, here it is giving 81%. Okay, this is also okay, but you can see on testing data we need important thing, and that is why we are going to go with this model. Okay, so once we get the model, what our next thing is, we need to, according to the requirement, according to the deployment requirements, we need to convert our files. Means like pickle file is there, joblib is there, whatever the front person's need is there, it is going to be converted in that. Okay, and then we have to pass those files, then the deployment process is of next. So this is a whole project of machine learning classification project. Okay, with this you can understand that which model to go with, and then we can understand that how many customers are living, how many customers are staying, using bank services. Okay, with those things we can understand. Okay, and there you have it. We just built a full machine learning model to predict banking customers churn. If you coded along, you just added a real world project to your data science journey. Got questions, suggestions, or just want to sip tea and nerd about machine learning or anything under the sun? Drop a comment. I'll gladly read them all, and I'd love to hear from you. Don't forget to like, subscribe, and turn that notification bell so you don't miss more practical job ready projects. Until next time, keep learning, stay curious, and remember, real skills, real impact. Let's make the data dance.